Welcome back. In the following section, we'll start looking at a core skill that every React developer needs to develop right from the beginning. And that core skill is to think in React. Now, thinking in React encompasses many different aspects, but in this section, we'll focus on state management. So you will learn when and where to create state variables, when and how to derive state, and also how to communicate between child and parent components by lifting state up. And all these new skills will be needed as we keep building our faraway application. So get ready for some more foundational React knowledge, and so let's dive right in. Let's start the section by discovering what thinking in React is actually all about. So, as you might have noticed by now, building React applications requires a completely new mindset, because it's just very different from building applications with vanilla JavaScript. So to build React apps, you not only need to learn how to work with the React API in practice, like with all the different functions like useState, but you also need to be able to think in React. So you need to basically enter the React mindset. Now, once you have both of these skills, you will have mastered React and you will be well on your way to building professional React applications. Now, what does thinking in React actually mean? Well, while you're building an application, thinking in React means that you have a very good mental model of how and when to use all the React tools like components, state, props, general data flow, effects, and many more. It's also about always thinking in terms of state transitions rather than in element mutations, as we have learned before. Now, you can also view thinking in React as a whole process, which can help us build apps in a more structured way. And the first step in this process is to break the desired UI into components and establish how these components are related to one another. So to establish the component tree. This also includes thinking about reusability and composability of components. After that, we can start by building a static version of the application, so without any state and interactivity. And this is great, because by doing this, we do most of the coding up front before having to worry about state and interactivity. That part comes next, so in step 3, where we think about state. So here we decide when we need state, what types of state we need, and where to place each piece of state. Then, finally, we think about establishing how data flows through the application. This includes thinking about one-way data flow, child-to-parent communication, and the way global state should be accessed. So these points 3 and 4 is what we collectively call state management, which is the main focus of this section. Now, of course, this is not a rigid process that we always need to follow to the letter. In practice, there's always a lot of back and forth between these different steps, and things are never this linear. But it's still good to have a process like this as an overall guideline. Okay, now once you really know how to think in React, you'll be able to answer questions like how to break up my UI design into components, how to make some of my components truly reusable, or how to assemble a user interface from reusable components. Now, we also think a lot about state, like what pieces of state do I need for the interactivity that I want, and where to then place each of these states. Or, in other words, what component should actually own each piece of state? Or what types of state can or should I use? And, in more general terms, how to make my data flow through the application. Now, as you might have noticed, we already started to talk about some of these topics before, but I still wanted to have one section where I really focus on some of these skills so that you can start getting more and more into the React mindset. Now, of course, you will only really master these skills through practice and writing code. And lucky for you, we will do lots of that in this course. But we will also take a bit of a theoretical approach from time to time, just like in this video, because I believe that it's really, really important that I teach you these things besides just the React API itself. And by doing so, I make this course really as good as possible for you. And in my opinion, way better than all the other React courses out there. But anyway, let's now move on to looking at the fundamentals of state management. We learned before that state is the most important concept in React. Therefore, managing state is the most important aspect when it comes to thinking in React. And so, let's now talk about the fundamentals of state management in React. So, as you already know, we can use the useState function to create multiple pieces of state in order to track data that changes over the lifecycle of an application. Here we have many examples of state in the Udemy application that you are familiar with. And if you want, you can pause the video and quickly analyze this. Now, all this looks like a bit of a mess, right? Like, how do we know that we even need all of these pieces of state? And how do we know where exactly to place them inside the code? Well, that's where state management comes into play. Now, state management can be defined in different ways by different people, but I like to think of state management as deciding when we need to create new pieces of state, what types of state we need, where to place each piece of state inside our code base, and also how all that data should flow through the app. And to summarize all this, I like to use the analogy that state management is basically giving each piece of state a home within our code base. Now, up until this point, in our small apps, we never had to worry about state management at all. We simply placed each state in a component that needed it, and that's it. But as an application grows, the need to find the right home for each piece of state starts to become really important, no matter if that home is the component where we first need that state, some parent component, or even global state. And speaking of global state, let's actually analyze the difference between the big two types of state that exist in React: global state and local state. Now, this will only become more important to us later on, but let's still start learning about this inside this thinking about state section. So, in React, each piece of state is either local state or global state. So, local state is state that is only needed in one component or in a few different components, like child or sibling components. We simply create a piece of local state using the useState function inside a certain component, and that piece of state is then only accessible to that exact component and maybe to its child components if we pass the state using props. Now, going back to our Udemy app, an example of local state might be the input text in the search bar. So probably only that component needs to know about this data, and therefore this is local state. So state local to that search bar component. Now, about global state, this is state that many different components in the app might need access to. Therefore, when we define state as being global, that piece of state will become accessible to every single component in the entire app. It's shared between all components, and therefore we can also call this shared state. In practice, we can define global state using React's context API or also an external global state management library like Redux that you might have heard of. Now, in this Udemy app, one piece of global state is the shopping cart. So that piece of data is used all over the place here. So all these components need access to the shopping cart state, and therefore it makes sense that this is global state. Now, this distinction between local and global state will matter more in large applications. So in the app we're building right now, we won't have any truly global state. And we're actually going to keep using just local state doing parts 1 and 2 of this course. And in fact, one important guideline in state management is to always start with local state and only move to global state if you really truly need it. And we will learn all about this in part 3 and 4 of the course. But for now, let's take a look at how to decide when we actually need state and where we should place it. So this slide will basically be a flowchart that will help you take those decisions. So again, about when to create state and where to place it. So it all starts with you realizing that you need to store some data. Now, when this happens, the first question to ask is, will this data change at some point in time? And if the answer is no, then all you need is a regular variable, so probably a const variable. However, if the data does need to change in the future, the next question is, it is possible to compute or to calculate this new data from an existing piece of state or props? If that's the case, then you should derive the state. So basically calculate it based on an already existing state or prop. And this is a pretty important concept, so there is a separate lecture on derived state later in this section. However, most of the time you cannot derive state. And so in that case, you need to ask yourself whether updating the state should re-render the component. Now, we have already learned before that updating state always re-renders a component. But there is actually something called a ref, which persists data over time like regular state, but does not re-render a component. So it's basically a special type of state that we will look at later. Now, most of the time, you actually do want state to re-render the component. And so what you do is to create a new piece of state using the useState function. And you then place that new piece of state into the component that you are currently building. And so that's the always start with local state guideline that we talked about in the previous slide. And with this, we have completed the decision process of when to create state. So again, most of the time, you will just create a new piece of state using the useState hook. But there are also all these other cases. And so it's important that you are aware of when to create each of them. But anyway, let's now focus on where to place each new piece of state. So if the state variable that we just created is only used by the current component, then simply leave it in that component and you're done. So that's the end of the process right there. However, the state variable might also be necessary for a child component. And in that case, simply pass the state down into the child component by using props. So easy enough, right? Now, if the state variable is also necessary for one or a few sibling components, or even for a parent component of your current component, it's time to move that state to the first common parent component. And in React, this is what we call lifting state up. And this is another one of those super important topics, which we will actually start using in practice in the next video. Now finally, the state variable might be needed in even more than just a few siblings. So it might be necessary all over the place in the component tree. And what does that sound like to you? Well, that's right. That sounds just like global state. But since we won't need global state for some time, we will complete this diagram once we reach the global state management lectures. All right, so I hope that this diagram will be useful once you start building your own small apps or even throughout the rest of the course. Now, I know that this might look super confusing and like a lot of work for now, but it will become really intuitive over time. So at some point, you will just automatically and intuitively know when to create a piece of state, you will know when to derive state from existing state, and you will intuitively know when to lift state up. But this flowchart can still be quite helpful in the beginning. Welcome back to the faraway application that we started building in the previous section. And now let's add some important state to the app and then also lift that state up. But before we start doing that, let's recap where we left off at the end of the previous section. So remember how we made our form here with these two controlled elements. So the state of these two elements is controlled here inside the form component with the description and the quantity state. Then, whenever this form here is submitted, the submit event will fire off. And so then we are handling that submit event here using the onSubmit prop with the handleSubmit function. So this function right here. Then, if there is a description, we create this new item object, which right now we are only logging to the console. So let's try that. And so you see, we got an object with a description, the quantity, the packed status set to false by default, and some random ID right here. Okay, but again, right now we are only logging this piece of information, so this new object here, to the console. But now let's do actually something else. So we want to store this information somewhere. And to help us with that, we can actually use the flowchart that we just looked at in the previous lecture. So we already know that we want to store some piece of information. Now, will that data, so that information, change at some point in the future? Well, yes, it definitely will each time that we add a new item to the items list. Now, can that data be computed from existing state or props? Well, no, it cannot. So therefore, we cannot derive state. Then the next question in our flowchart is whether this new data should actually re-render the component whenever it is updated. And the answer to that question is a resounding yes. And so therefore, as we already expected, the result of this first part of the flowchart is that we need to create a new piece of state in the component that we are currently building. And so with this, we finish the first half here of the flowchart, which is about when to create a new piece of state. Now back here in our code, let's actually do that. So let's create a new state variable called items. And then as always, we have our setter function, in this case called setItems. And so then use state. And now what do you think will be the default value for this state variable? Well, remember that these items here are basically the packing items that are displayed here in the UI. And so this, remember, is an array. And therefore, our initial state for the items is just an empty array. So when we open up a new packing list, so when we open up this app for the first time, of course, we don't want to have any items. And so that's what the empty array here basically is. Okay, and so now let's actually use the setItems function here to add our new items to the items array. And actually, let's do that in a separate function. And let's call that handle add items. And this function will receive a new item object, which it will then add to the items array. So let's actually immediately call the function here. So here we will call handle add items and then with the new item that we just create. So for example, with an item that looks just like this. So that's what we pass in here. And now, again, it's time to use setItems to update our items array. And this new items array will basically be the current items array plus the new item added to the end. And so what this means is that the new state depends on the current state. And therefore, here we now need to pass in a callback function. So not just a single value. So let's call the current state here in this callback items. And then here, let's see what we need to do. So remember that in React, we are not allowed to mutate state. So we cannot do this. So we can not simply push the new item into the items array, because with that, we would be mutating. So we would be changing this items array right here. And again, that's really not allowed in React. So React is all about immutability. And so the solution here is to create a brand new array, which contains all the current items plus the new one. So let's return a new array. And then in there, we simply spread the current items. And then we add another item, which is simply called item. So the item that we are receiving here. Now, if this looks strange to you, then please go back to the review of Essential JavaScript section, where I have a couple of videos on how to work with arrays in an immutable way. So basically how to add new items, how to update, and how to delete items from an array without mutating the original. So in React, that's something that we need to do all the time. And so again, if you're not sure how that works, then please go back to that section, because from now on, I will simply assume that you know how to do this. Okay, so this is already done. So we now have a way of adding new items to the state. And so let's immediately test that here. So let's use now 10 test items. And so we are still logging them to the console, but now I want to draw your attention here again to the DevTools. And in particular, of course, to the form component that we are working with now. And so down here, we already have our state, which already has this new item that we just created. Nice. So let's do another one for like boarding passes. And you see, immediately it got also added to our items array. So our updating logic here is working just fine. But of course, this state is now nowhere being displayed in the UI yet, right? So we are not using this items variable anywhere in our JSX yet. And the reason for that is that actually we do not need these items in this current component. The only goal of the form component is to add new items to this array, but not to render it. Instead, remember that who renders these items is actually the packing list component. So that's this one here, right? But with this, we now created ourselves a problem. So let's take a closer look here at the component tree. So right now, our item state is here inside the form component, right? And so this is where we update the state. However, we need the state itself. So we need this item state variable here in the packing list, because again, this is where it should actually be rendered onto the UI. And so now, how do we get this state from the form to the packing list? Well, we cannot pass it as a prop, because the form is not a parent component of packing list. It is simply a sibling component. But data can only flow down the tree. It cannot flow up the tree or sideways. So therefore, we cannot simply pass these items to the packing list via props. Instead, we now need to use a technique that I mentioned before, which is to lift up state. So what we're going to do now is to take this state here, so this line of code, and we will move it to the closest common parent component. So which one is that? Well, it's simply the app component, right? So this component is both a parent of the form and of the packing list, which are the two components which need this state. So again, let's grab this and let's move to our app and add the state right there. And then of course we get these errors here because setItems is no longer defined in the form. So let's fix that in a minute, but I want to start by now passing the items here into the packing list. So we define a new prop called items into which we pass the items array. All right, then let's come to the packing list and accept that prop there. So remember, we can immediately destructure the props object here. And then instead of the initial items, we will now finally render the actual items. And with this, we have now used the item state in our JSX, right? And now let's take care here of this handle at items function. So actually, I will grab this entire function and move it here. And so now all we have to do in order to enable the form to update the state is to pass in this handle at items function. So let's do that. Let's create a new prop, and kind of a convention is to call this now on at items handle at items. So we could of course call it the exact same prop name here. So we could create a prop called handle at items and then pass it a function with the same name, but it's kind of a convention for it to be like this. So it then becomes a bit more readable, like on at items, call handle at items. So if that makes sense. And then here, let's accept that on at items. And finally, here we now need to call, of course, the function with this prop. So with this prop name. On at items. And with this, we fixed all the errors that we had, but probably what we just did here is quite a bit confusing. So let me first now add a new item here, just to see if it works, and then I will explain what's actually happening a bit better. So let's see, and there it is. So we created a new item here. It was then added into the item state, which now lives in the app. Let's check that. Yep, that's right. Here it is. And so then that state got passed down here into the packing list, which received it as a props. And we can see that right here also in the DevTools. So here we now have the items as a prop, and then of course that gets rendered to the UI. Let's try another one. And immediately it got added here to the to this state right here, which was then passed down into the packing list. And now about updating the state, this is what happened. So we now have our handle at items function right here in the app, which is exactly where the piece of state also lives. So where we have the home of the items state. And so all the logic about updating that state is here in the same component. However, it is the form that is actually responsible for creating new items. And so therefore, we need to give this component, so this form component here, access to a function that can update the state. And so that function is handle at items. So as I mentioned before, we can actually pass anything as a prop. And so that includes functions. So here we pass in handle at items as a prop, and we call that prop on at items, which of course, again, could also be called handle at items, which some people prefer, but many times you will see this convention. So then we come here, destructure the props, and then we call that function whenever the form is submitted. And that's it. So this is how we lift up state. So basically what that means is that whenever multiple sibling components need access to the same state, we move that piece of state up to the first common parent component, which again in our case here was the app component. All right, and we will actually review this one more time in the next lecture. But for now, let's move back to our flowchart and quickly complete it. So basically, we will just review what we just did and then see how we would have arrived at that solution here with the flowchart. So the new state that we created, was it only used in the initial component, so only used in the form? No, it was not. So then we move here and we ask ourselves, is the state also needed by a child component? And again, the answer is no, because instead it was needed by a sibling component. And so therefore, that is how we lifted state up to the first common parent. All right, so make sure to take another look at the code that we just wrote, and then in the next video, we will take an even closer look at this concept of lifting up state. So we just created an important piece of state and lifted it up to a parent component that is common to both components that need to use or to update that state, right? However, this whole idea might still be a bit confusing because, in fact, it can seem quite counterintuitive. And so let's now look at another example and some diagrams to really understand how lifting up state works and why it's so important. And as an example, let's use the checkout part of the Udemy interface that we have seen in a previous lecture. And let's say that we started by building this promotions component where the user can input coupon codes that will then be added to a list of applied coupons. So that sounds like we need a piece of state called coupons right here, right? So that coupon state is now local to the promotions component along with a setCoupons function coming from useState. Now next, we set out to build the total component. But here, we quickly realize that the total component also needs access to the coupon state. Otherwise, without knowing which coupons have been applied, how would the total component know what discounts to apply and what price to display? And so here we encounter a problem. How do we give the total component access to the coupon state? Because in React, we have one-way data flow. So data can only flow down from parents to children, but not sideways to sibling components. Therefore, we cannot simply pass the coupons data as props to the total component. That's just not possible. And so we need a way of sharing state with other components that are further up or sideways in the component tree. But luckily for us, we already did exactly that in the last lecture with the item state by lifting it up. And so we already know that lifting up state is the technique that will solve this problem. But what does that mean and how exactly does it work? Well, lifting state up simply means to place some state in a component that is a parent of both components that need the piece of state in question. So in this example, we would remove the coupon state from promotions and place it in the checkout component. And just like this, we have lifted state up to the closest common parent of both total and promotions. And now giving both these components access to the state is as easy as passing it down using props. And that's it. So by lifting state up, we have just successfully shared one piece of state with multiple components in different positions in the component tree, which is something that we need to do all the time in React apps. And so it's really important that you get used to this pattern. And remember that we need this pattern in the first place as a direct consequence of React's one-way data flow. But anyway, all this now seems to be working just fine at this point. But now, what happens when we want to add a new coupon to the coupon state? Or in other words, what happens when the user inputs a new coupon and clicks on the apply button? Well, we want to update the coupon state, right? But how do we do that now? Because after lifting the state up, it now lives in the parent component, so not in the promotions component anymore. Promotions only receive this data via props, but as you know, we cannot mutate props. So that's one of the hard rules of React. So what we're asking here is, if we have one-way data flow, so if data can only flow from parents to children, then how can the child component promotions update the state that lives in the parent component checkout? Well, actually, the solution is quite simple. All we have to do is to also pass the setCoupons function down as a prop to the components who need to update the state. And so now that we have the setCoupons function in promotions, once a new coupon is added, we can simply use setCoupons to update the state that lives in the parent component. And this is actually exactly what we also did in the previous lecture, with the difference that we didn't directly pass setItems, but a function that uses setItems to update the items, which is essentially the same thing. But anyway, we can call this technique of passing down a setter function child-to-parent communication, or also inverse data flow. Inverse because usually data only flows down, but here we basically have a trick that allows us to basically have the data flowing up as well. Now, of course, this is not truly flowing up, but this workaround of passing down the setter function and use it to update the parent state is pretty close to actually having data flowing up the tree. Now, when I first learned about this technique years ago, it actually took me quite some time to wrap my head around this whole idea, because this can actually be quite confusing. And so that's why I created an extra lecture with all these diagrams for you, hoping that you will have an easier time understanding child-to-parent communication. But that's enough talk. Let's now go back to our code and use this in practice a few more times. So we just learned what child-to-parent communication means, and so let's now do some more of it in order to delete items from our list. So the idea here is that whenever we click on one of these crosses here next to an item, it will then delete the item from the state and therefore from the user interface. Now, since this click here will happen inside the item component, so remember, each of them is actually an item component, and so the click to delete, so on each of these crosses, will happen inside of the item, but the state actually lives in the app, so in the parent component. And therefore, this is another case of child-to-parent communication. So let's now go back here to our app, which is where our state lives, and then all we're going to do is to create a new function right here called handle delete item. Now, in order to delete an item, we need to know which item it actually is that should be deleted. So, in order to do that, so to tell this function which item it is, we will pass in the ID whenever we later call this function. So remember that each of these items here has an ID, and so we can then use that ID to remove the corresponding object from the items array. Now, about the delete operation itself, we will, of course, delete the item from the user interface by updating state. So we call setItems, and now here in setItems, we need the new array after the item has been deleted. Now, once again, this new items array will be based on the current one. And so we need a callback function which receives the current item as its input. And so now let's say items.filter, which will loop over the array, and in each iteration it will get access to the items object. And so now basically all we want to do is to filter out the item that has the ID that we got here, right? So item.id is different from the ID, so the ID that we pass in. So whenever this condition here is true, the item will end up in the new array, so of the array of the items that have not been deleted. But when this is false, so when item.id is equal the ID, then that element will no longer be part of the final array. And so that's how we remove, so how we delete elements from arrays. And once again, if this is strange, please go back to the section where I review essential JavaScript concepts. So there I teach in detail about how this works. And now all we have to do is to call this function whenever the click here happens. So how do we get that there? Well, we now need to pass the function as a prop also into the packing list. So into the packing list, because the items are called inside the packing list. So on delete item, and so I'm using the same naming convention as before, where I call the prop on delete item and then pass in the function handle delete item. And so now let's receive this prop here inside the packing list. So we already have items. So let's add this one here to the list. And again, this is so helpful because now we know immediately what props the packing list will receive. And then remember that the click actually happens here on this button. So inside the item component. And so here we also will need access to this prop. Therefore, we now need to pass it in along the item right here. So on delete item equals on delete item. And so we're basically passing now this prop through the packing list into the item. So it moves here from app to packing list and then to each of these items. So packing list itself doesn't really need it, but of course this is the only place where we can receive it because we cannot pass it directly from app to item. Right? So that would not be possible. Okay, and now here we use the onClick prop and then we specify our handler function. Now, if we do just this, on delete item, then this is not going to work. So let's see why. So let's test this here. And so you see that nothing happens. So we can see that here also in app when we try to log the ID. And so now you will see that, well, nothing happens because what we get in here instead of an ID is this event. So what's going on here? Well, when we simply specify the function here like this, then React will call the function as the event happens, and it does so by passing in the event object. So we actually used this to our advantage in the form. So right here, where we then received the event. But right now, we do not want to receive the event, but instead the ID of the current item. And so we need to create a new function here, and then we pass in the current ID. So item.id. And once more, it's really important that you don't forget this, because otherwise React will just immediately call the function, which is not what we want. We want a function here really so that React can then call this function only when the event happens. And this is actually it. So this should do the job. Let's see. And beautiful. So that's gone. You see here also the ID that we logged to the console. And so it was based on that ID that the new items array was set. So the state was updated, which forced React to re-render the component, or in other words, to re-render the component's view. So to be a bit more specific. So let's try that again. And yeah, then we cleaned everything. Now, let's also, since we're already here, get rid of these initial items, because now we are getting this ESLint warning that this is never used. So again, really helpful here from ESLint. And yeah, just by the way, we could of course also have used these initial items here as our initial state. And so then whenever we would reload, well, not this. So whenever we would reload here, then we would get these three as a default. So they would then get added into our state, and then everything would work the same. So we could also delete them here. And as we reload it, then they would be back. But that's not what we want. So let's just get rid of all this. Beautiful. And now all we have to do here for the final operation is to implement this functionality. So where we click here, and then it will mark the item as packed. So that's going to be our topic for the next lecture. Next up, let's take care of updating items by toggling their packed status. So basically, that's the functionality that I showed you by the end of the previous lecture, right? So this is what we want to implement in our app now. And so to start, we actually need to create those checkboxes there. So right now we don't even have that checkbox. And so let's go here to our item. And before the span, let's now add an input of the type. And here we want a string. So of the type checkbox. So that's something. So we can actually already toggle this one here on and off now, but of course it's not going to do anything. So basically we want to also transform this element right here into a controlled element. And remember, a controlled element means that the element has the value defined by some state, and it also has an event handler which listens for the change and updates the state accordingly. So let's do those two things. And first, the value will be given by the item.checked status. And so this checked here is always a true or false value. And so that is exactly the type of value that we need to pass into the value of a checkbox. And actually here it should be packed and not checked, which maybe you had already noticed. But anyway, now let's keep going here. And so now next up, we need to add onChange handler. So we need to listen for the change event, which basically happens each time that we click here on the checkbox. Now here, for now, let's actually specify just an empty function. So a function that doesn't do anything. And here we're missing this. All right. And so the reason for that is that, of course, this function here that we are eventually going to specify here is going to change the packed value of the item state, right? And so that function will once again be placed where the state actually lives, so inside of app. And then we will pass it down using a prop, just like we did with onDeleteItem. So this is something similar. So instead of deleting an item, we will simply now update one item. And so again, that update happens each time that we click here on the checkbox. So let's now write that function here. So function, and again, starting with the handle keyword, and then toggle item. And that's because here we will only toggle the packed property. So not allow anyone to update the entire object, but only really to change the value of that packed property. So in order to know which object we actually need to change, we need to again pass in the ID. And so then let's again set the items, and then we need to pass in a new array, which just like before will depend on the current array. So we have our callback function here. And so now in order to update one of the objects in the array, we will simply loop over the entire items array using the map property, which will then in the end return a brand new array with the same length of the initial items array. But one of the objects will then of course have been updated. So in the iteration, each of the elements is called an item. And then here is what we're going to do. So whenever the item has the ID that is equal to the ID that we passed in, so which means that this is the object that we want to actually update, then we create a brand new object based on the current item, and then we set packed to the opposite of packed, so of item.packed. And that's it. And if else, so for all the other objects, we will simply return the current item. And just once again, I want to emphasize that I covered exactly that this is how we update an object in an array in great depth in the section where we review essential JavaScript for React. So please go there in case that this looks strange. But for everyone else, let's just keep going here. And now also add this function here into the packing list so that the packing list can then add it into the item. So we use once again the props basically as a communication channel here. So on toggle items, handle toggle item. So on toggle item right here. And now let's just copy this, add it here to the list of props, exactly like this. And then we pass it into the item itself. Let's do that here. All right, and finally we receive it here. So again, we need to use the packing list here as an intermediary step in order to reach the item itself. And so now here we can then replace this empty function with calling on toggle item with, just like before, the current ID, so that we actually know which is the object that we need to change. All right, and that's actually it, or at least it should be. So let's see if that works. So 1 socks, let's say 1 shirt and 1 charger. And now, as we click here, yeah, beautiful. So it updates our checkbox, and you see that it also updates here the strike through. So that's coming exactly here from when the item is packed. And the same, of course, works for all the other ones, because if we click on this one, then the item.id will be another one. And so therefore then this function here receives another value, which will then update another object. And deleting here, of course, also works. And so, yeah, we are done with building these two operations that we can perform on items. So toggling their packed status and deleting them. Now, before moving on, please just make sure to review the code that we wrote here. So just to make sure that you understand basically everything that's happening here, why we are doing it this way, and the way we then pass in these functions as props all the way down until the components that actually need them. So this is again child to parent communication, which is something that we're going to use all the time. And so make sure that you really understand this concept as well as lifting up state until you move on to the next lecture, which is going to be about derived state. Another aspect that I mentioned in the state management lecture was derived state. Sounds complicated, but it's actually pretty straightforward. So essentially, derived state is simply state that is computed from another existing piece of state, or also from props. But let's look at some actual code. So here we have 3 pieces of state, as we can see by the 3 useState function calls. However, if we analyze these states, it actually doesn't make much sense that all of them exist, because num items and total price depend entirely on the cart. So num items is simply the number of items in the cart, and total price is the sum of all the prices in the cart. And so all the data for these 2 pieces of state is actually already in the cart. So there's no need to create these additional state variables. And doing so is actually quite problematic. First, because now we have to keep all these states in sync. So we need to be careful to always update them together. So in this situation, whenever we update the cart, we would also need to manually update the number of items and the total price. Otherwise, our states would get out of sync. But updating these 3 states separately creates a second problem, because that will then re-render the component 3 times, which is absolutely unnecessary in this example. Instead, we can simply derive the num items and total price state from the cart and therefore solve all these problems, because the cart already contains all the data that we need. So here we simply calculate num items as the cart length and total price as the sum of all prices and store them in regular variables. There is no useState required here, which will cause no unnecessary re-renders. The cart state acts as a single source of truth for these related pieces of state, making sure that everything will always stay in sync. And this works because updating the cart will re-render the component which means that the function is called again. And so then, as all the code is executed again, num items and total price will also automatically get recalculated. Now, of course, most of the time we cannot derive state, but whenever you have a situation like this one, where one state can easily be computed from another, always prefer derived state. So don't create two state variables if you actually only need one. That's a very common beginner mistake, but now you will be able to avoid it. Of course, let's now use the idea of derived state in practice. And in particular, we now want to calculate our statistics here. So calculating the number of items on the list, how many we already have packed, and then the percentage of that. Now, if we think about these numbers, for example, the number of items in the list, that number can be directly computed from the items array itself, right? And so derived state is perfect for this. But before we use derived state, I will show you how not to do this. So the way we should not do it is to use state. So let's say we created a piece of state called num items and then set num items. And by the way, you don't need to write this code right here. All right. So this is just to show you how not to do it. So initially we start with 0 items. Now the problem with this is, as I said before, is that we now have to also update this piece of state. So whenever, for example, one new item is added, besides setting the items, we also need to make sure to increase this number here. So set num items, and then the number, and then num plus 1. So with this, we would ensure that these two pieces of state stay in sync. But that's of course a lot of additional work that we might forget to do, and also it can cause multiple re-renders, where at least one of them here is unnecessary. Now in React 18, these should be batched, so these two should happen at the same time, but more about that later. But in any case, this is a terrible idea. So instead, we can just define a new variable called also num items, but we can simply derive it. So we can calculate it based on the items array. So that's simply items dot length. And so this works because as soon as the items are updated, so as soon as this piece of state is updated, the component will re-render. And when the component re-renders, that means that the function here is called again. And therefore, then this piece of code here will run again. And so if a new item has been added, then now the item state, so this array is different, and therefore the length will also be different. Now this num items variable, we actually don't need it right here in the app component, but in the stats component. So this one right here. So we have two options now. The first one is to keep num items here and pass it as a prop into stats. But I think what makes more sense is to actually calculate this state here, so this derived state, inside the stats itself. Also because we will actually calculate 3 values, and so if we were to calculate them here, then we would have to pass 3 props, which doesn't make a lot of sense. So let's just cut that from here and paste it here into the items. Well, actually, no, that's not correct. Want to paste it right here. But now as soon as I save this, we will get an error, right? And so the reason for that is that now, of course, we don't know. So this stats component doesn't know anything about what this items is. So we now have another component that needs the item state. So we just pass it down as a prop. Just like we passed it also into the packing list. Now, of course, we need to accept that prop down here. And so this solves the problem. And so here we can now already use that value. So you have num items on your list. And so yeah, indeed right now that's 0, but if I add some socks here and maybe a shirt, then you see as soon as we add new items here, the array grows. And so then this number here also gets updated. So watch what happens when I hit enter, and immediately this changed from 2 to 3. Let's just quickly remove those console.logs there. So that's much better. And so now let's derive our other pieces of state. So of course, this one here, so the ones that are already packed and the percentage both depend on the items themselves. So number of packed is simply the items array filtered by the items that are already packed. So item.packed. So that's a new array, and so then we can take the length of that one. So you have already packed number of packed, and so that immediately becomes 0. But then when we mark one of them as packed, beautiful. So 2, and then all of them. Great. And now finally, just the percentage, which should be pretty easy. So that's just the number of packed divided by the number of items times 100. And then let's grab all of that and round it. So math.round. And so here then we can replace that. Nice. That also works. And now it hits 100%. And in that case, so whenever we have 100%, I would like to display an entirely different message here. So telling them basically that they are done. So watch what happens here in the demo. Yeah, that's it. So let's write that here. And so for that, we need some more conditional rendering. So actually, we will just conditionally define what is here inside this M element. So let's enter our JavaScript mode and say that whenever the percentage is equal to 100, then the content should be this string right here. You got everything ready to go. Now let's add a plain emoji here as well. And now else. And so let's move that here. And so now instead of this text that we had here, we now need a string. And so let's make a template literal here. And then we need to add, of course, these. And in case we didn't want to create this template literal, we could, of course, also have simply rendered one EM for each of these cases. Now this looks not correct. Maybe it's because of this right here. Yeah, but it looks as though it works, even though we are in the wrong app. But here we already have our correct message. Let's uncheck one of those. And now you have 3 items on your list. Great. Now let's remove this one and this one as well. And so now we have already packed 0. And also in this case, I want to display something else as well. So also another message. So if this is the case, if there are not even any items in the array, then it's not even necessary actually to perform all these calculations, because they will just be 0 anyway. So what I want to do now here is to show you a good use case of an early return as conditional rendering. So what we're going to do is to say if there is no items.length, then simply return, so let's return a paragraph with the class of footer, and then here also an EM, and then start adding some items to your packing list. And again, some nice emoji here, like this rocket. And so now let's reload this here so that we then have no items. And so yeah, here we go. Now here, the class name is not footer, but stats. So basically the same as here. And so yeah, then we got this. So this text that we defined right here, so this paragraph. And again, that's because in this case, it doesn't even make sense to then do these calculations. So if there are no elements anyway in the array, then don't even bother with all of this here. Now, in this case, of course, it would have been no problem to still do these calculations as they are not a lot of work. And we could then have some conditional rendering in here. But this was just to show you that the option of an early return is sometimes also nice. So it's also quite legible here, if you ask me. So when you arrive at this component, maybe you have never seen it before because one of your coworkers wrote it, then you can right away see that if there are no items, well, then just return this. And in all other cases, then perform the rest of the logic of the component. Great. So hopefully that made sense. And so next up, let's see another use case of derived state, which will be to implement this sorting functionality here. So that will make this application look even more real life. And so I think this is going to be really fun. Let's add a new feature to our application, which is to allow users to sort the items by 3 different criteria. So basically, we will build this select box right here, and then from there, the user can choose which of these criteria they want to sort the list by. So something that's very common in most web applications. And so let's now build a very simple version of that. So we will do this here right in the packing list component, because if we were to create a new component just for this, then we would add a little bit of extra work with lifting some more state up. And I want to keep it simple here and not to confuse you even further. And so, yeah, it's no problem to just do it right here in the packing list right after this div right here. Or actually, let's do it right here after this unordered list. So let's create a div with the class name that I already created called actions, because here we will have that select element and later also a button to clear the entire list. So inside the select element, as always, we need the option element, which should have different values. And so then later, based on these values here, we will calculate the ordered list. So the first one is based on input. And so these are just some strings that we are making up here. So input is basically by the input order. Then, well, let's write that here first. So sort by the input order. So by the order in which these items were actually placed into the list. Next up, we want to sort by description. So sort by description. So basically alphabetically. And then finally, let's also do, which is very nice, by the packed status. So sort by packed status. Nice. So there it is. Looks great. And so now let's see how we can actually implement this. So first of all, of course, we need to know inside the component, so inside our React application, what the currently selected element here is. And so for that, we will once again transform this here into a controlled element. So for that, we need our 3 steps. So first of all, we create a new piece of state. Let's call this one sort by and set sort by. Use state. And now our default will be the very first one here. So we want that by default, they are sorted by input. And so this input here is exactly this string that we defined here. But it could also be description or packed. And so now let's use that state here as the value. So sort by. And if here I used packed instead, then we should already see that reflected in the UI. So you see that here we now have by default sort by packed status, because now I used this string. Now React is complaining, and that's because we are missing the third part, which is to now attach the onChange event handler so that we can then set the state based on whatever the user selected there. So onChange, and this function here will automatically receive the event, and then we can set sort by using event.target.value. So at some point you will get really used to writing this kind of thing here, and it will become second nature. So this is like a recipe that we always need to follow, and it always works in the exact same way, really. So let's see. And yeah, that works nice. And if we check out our component here, then we first of all need more space. And then you see down here, we now have the sort by status inside our state inside our component. Great. And so now we can work with this. So how do we now get React? So how do we get our application to display the items here sorted by whatever criteria we selected? Well, basically we will just create a new items which is then sorted by that criteria. So we are not going to manipulate the original items array. That state should stay unchanged. Instead, we will now use again derived state, because sorting one array can of course be computed based on that initial array. That makes total sense, right? So once again, we will not create a new state variable here, because that's totally unnecessary. We will simply create a new variable, and here actually a let variable. So sorted items. And we're using a let so that now we can simply do a couple of simple if statements. So if sort by is equal to input, then this is the default, right? And so then in this case, we can simply say that sorted items should be just equal to the original items. So this is wrong here, of course. So again, in this case, the sorted items are just equal to the items themselves. So the ones that we receive as a prop here. And so now, of course, in the end, we need to use these sorted items. And that's right here. So from now on, instead of rendering the original items array, we will always render the sorted items. All right. And let's just put some here, socks, a charger. So these are quite easy to write. Yeah, right now only this one here works. So if I do this now, then we get an error, because sorted items is then just this empty variable that React doesn't know how to render. So, well, now I will have to write everything again here. So socks, a shirt, and a charger. All right. And now let's write one if for the other two cases. So if our sort by change is, that's a description, then we will want to sort our items. Actually, so sorted items will then become items. And now first we use slice, because with this, we basically take a copy of the array. And that's very important because the sort method is a mutating method. And so if we didn't do this, then the items would actually get sorted as well. So we don't want that. So we use slice dot sort. And now here, I will just write the code because, again, I already explained exactly how this method works in the review of JavaScript section. Now, in this case, since we want to sort alphabetically, we can use the local compare method. So we want to take A, which is basically one object of the array, and then we want to take the description of that, which is one of the properties of each object. And then, since this is a string, we can call local compare, and then here we simply pass in another string, which is b.description. All right, So this is going to work. Hopefully, at least. And then finally, let's also add the code for our last case, which is by packed. And so something very similar here. Sorted items is going to be equal to items, taking a copy, dot sort, and then A and B, which are basically two objects of the array, which are being compared. And then since we want to order by the packed status, which is a Boolean, we need to first convert that to a number. So A.packed minus number B.packed. And that's it. So let's try this out. So by description, you see that now it's alphabetically. So CSS. And finally, by the packed status. So right now, all of them are unpacked. So let's click, and you see that then it moves to the end. And the same thing right here. Then if I remove it, it will move back here. Great. And of course, we also have our default, which is the input order, which is also the same. That happens whenever we are in the packed status and we have none of them packed in. Great. So that's just amazing. We just implemented this simple feature, but also a very common feature, simply by using the power of derived state. So again, we didn't create any new piece of state for the sorted items. The only state that we need is the sort by state, so that React actually has at all times the value of this input field right here. And then based on that, we simply create this derived state of sorted items, which then in the end is what we render onto the user interface. And with this, the only thing that we have left to do is to add this button here to clear the list. And so that's the task of the next video. Let's now make our application feature complete by adding a button to clear up the entire list at once. And so to do that, let's come down here, and after the select, we're going to add a simple button. So not like that, but button clear list. So there it is. And now, as always, we need to add the onClick event handler, and then we need a function that basically deletes all of these elements here at once. Now, I think that this might be a nice challenge for you. So creating that function that deletes everything, and then passing that function down to this component and adding it here onto the button. So that shouldn't be all too hard. And so please go ahead and pause the video right now. So try this on your own really, as this is a really nice learning experience. And then I see you back here in a minute or 5 once you are finished with that task. Okay. So I will create a function close to all the other functions. So we have handle add items, delete, and toggle. And so we simply add just another one. So handle clear list, which doesn't need anything really. And then all we need to do here is to simply say set items back to the original value, which was of course this empty array. And that's it. So that's almost too simple, but now we just need to connect this function to the button. So that button is in the packing list, so that's where we pass this into a prop. So on clear list will be handle clear list. And so now let's get that. So this packing list really receives a lot of props. And so then here, the onClick prop. And here we don't even need to create a new function. All we have to do is to pass this one in. So on clear list. Give it a save, and that should be it. So clear list, and yes, everything is gone. Great. So I'm hoping that you did this as well. And now just one more thing here is that here in this demo app is that here we prevent the user from accidentally deleting everything. So here, when they click on clear list, first we get if we want to delete all the items. And only then if we click on OK, everything will get deleted. So you see, now it is empty. So let's quickly do the same thing here. And that's pretty easy because that's just a standard DOM function. So that's a function that's not really part of JavaScript, but it's part of the web API. But anyway, here we can create some variable, let's say confirmed, and then that confirmed will be defined by window.confirm. So here we can then pass in any string. So that's going to be the message that the user will see. So are you sure you want to delete all items? And then when the user clicks on OK, confirmed will become true. And in the case they click cancel, then it will be false. And so now we can do this conditionally. So we just say if confirmed, then set items to the empty array. Just to make sure, let's reload and shorts and a charger. And now when I clear the list, then yes, we get the confirm and it works beautifully. Now, maybe you got a little bit annoyed at all the scrolling that we had to do here now lately because our components were getting bigger and bigger. So whenever we wanted like to pass in something here, then we had to scroll all the way down here to then accept, for example, these props right here. And so that's why I said in the very beginning that in real world applications, we usually have one component per file. And so in the next lecture, I will show you a trick of how we can basically divide this one file into multiple files. So one file per component. So let's now split up our app.js file into multiple component files. And this will just be a very simple exercise of taking each of these components and placing them into their own file. So you can even do that on your own if you want. But anyway, let's just grab this code here, cut it, and then create a new file inside source. So inside this source folder, create logo.js, which is the name of this component, right? All right. But now, of course, we also have to export this function from here. And remember that in JavaScript, we can export in two ways. So we can have named exports, which would simply be this. So with this, we would create an export called logo, which we would then have to import with exactly that name into the other file. So into the file where we need it. But usually in React apps, what we do is to use a default export. So export default, just like this. And then of course, now if we try to reload this, we will get an error that, well, not this one, yeah, right here. So we see that the logo is not defined. And so of course, that's because now we have to import it right here. So import, and here actually we can use any name that we want. So because we used a default export. But of course, we will still call it logo here. So import logo from, and then simply the path to that file. And yes. And again, we could indeed change the name here to X, for example, and then here as well. Give it a save, and you see that it still works. But again, this is of course not advisable. This is just to show you how named and how default exports work. All right. Now let's take the next one. And by the way, the first one here will of course stay in this file because it is called app. And this file is also already called app.js. So let's grab the next one here. Okay, cut it. New file, form.js. Paste it here. And then again, export default. Coming back here, then we need to import form from just like this. Now here we will still get an error because we haven't imported useState in that other component. So let's quickly grab this line of code here, move into the form, which is where we are using useState, and then we also need to import that hook, so this useState function, here into this file. Of course, because this file here does use that function. So it's not enough to just include it one time anywhere in the code. You really have to include the parts of React that you need in each single component file. So let's close this one and this one. And now that we have done it 2 times manually, it's actually time to do it automatically. So let's again select all of this. We can even click this triangle here to collapse the function. And so then we can select all of it and then right click here and then click on refactor. And so now here, this gives us the option to move this function into a new file. So let's click that. And you see that a brand new file with the name of packing list was created. So VS Code automatically took this function here and then created a new file with this exact same name. And it also automatically imported all the parts that we need inside this function. So we have useState and we also have item. Well, this actually doesn't make a lot of sense at this point because the item is still here. So that's actually not ideal, but we will fix that in a moment. So what matters here for now is that VS Code automatically created this new file, placed this new component here, and also exported it. Now it's actually using a named export. So you can see here that it's importing it in this other way. So this is how you do a named import. But again, we usually in React development do default exports. But of course, the other way is also perfectly fine. So I will just change it here. Export default. And then here I need to change the way I import it. So getting rid of these curly braces. And now let's also create a new component for this item here. So let's just remove this export. Select everything, refactor, and move to a new file. So again, item was created. And here we need to actually write export default, give it a save. And now we need to change that in the packing list because now this component is no longer in app, but inside of item.js. And it's again a default export. So we need to import it basically as a default import. All right, so this small thing here happened because we first exported the packing list which depended on the item. But yeah, in any case, usually we do this immediately. So usually when we build some app, we do immediately create a new file for when we need a new component. So let's do that one final time. So stats, let's change it again to export default just to stay consistent. And then fix it here as well. And with this, we now have one component per file, which makes our component here a little bit easier to manage. So then there's not so much scrolling up and down, but instead, well, we can develop basically each component in isolation in its separate file. Now, taking it one step further, we can also move each of the components into a new components folder. So components, and then let's select all of them actually. So everything except for index.js, which is not a component, and our CSS file. Grab them here. And now we only have one problem, which is the app file cannot be found here in index.js. So here we need to now fix this path to components/app. And with this, we are finished. So all the other files still work the same, or actually this one here. So here the imports still work because all the components are still in the same folder as app.js. And with this, we actually finished this project. So once again, congratulations for finishing your first, a bit more real React project. So a project that actually does something. So I think this was a really great practice project, quite straightforward, but it had all the most important fundamentals that you needed to know at this stage. Now, of course, this is not a real-world application, but in large-scale apps, you actually have many smaller parts in which you will need exactly these skills. And so everything that you are learning here is really, really important. It will lay the foundation so that later you can build those large and real-world applications. Now, next up in the section, we have a nice exercise where together we're going to build an accordion component. And then I just want to show you one other very important part of React. So that's going to be the children prop. And so, yeah, stay tuned for that. It's now time for another exercise so that together we can practice state management and thinking in React in general a little bit more. So together we will build this very simple accordion component where we can open and close each of these items of the accordion here. So when it's closed and we click, it opens, and when it's open and we click, it basically closes again. And each of these items has the title, or actually the number here, the title, and then the text itself. So this is here a question, and this is an answer, basically. And so we have some starter files again, which I have linked in this lecture, and the starter files are this array of frequently asked questions, and then also this CSS styles right here. So as always, you have two options. You can do it in your own VS Code. So then just go here and copy all the relevant starter data. Or of course you can fork now this code sandbox. So basically in order to create your own one. And so now I have created a new one out of the other one. And so I can safely change this one. So let's go back here to see what we have to build. And basically the entire thing here is the accordion component. And then each of them is one accordion item. And so let's start by actually building these items themselves. And remember that each one gets a number, a title, and some text. So the accordion component has actually already been created. And so now, next, let's create the accordion item. Okay. So remember that each item gets a number, it gets the title, and the text. And so let's immediately write that here basically as the props that we will receive. And so then we can immediately build with these. So just like before, we will start by building a static version of the app. So in this case of these two components. And then later we add state to the mix in order to actually make the component dynamic. So here we will return a div element. And this div has the class name that's coming from the CSS that I provided of item. Then we can immediately close that. And so then we have one paragraph for the number. So that's class name number. And then here, let's actually immediately use, again, this prop that we will receive as soon as we start including this component here anywhere. But we can already use that prop as if it already existed. So class name, then let's say text. And again here, the same thing. Let's immediately use the prop. And then finally, this one here for the icon. And by icon, I mean this minus and plus right here. So see how it toggles between plus and minus. And for now, let's start with a minus there, but we will change that later. And finally, we then have a div which will contain the content itself. So basically the text. So here the class name is content box. And then this, again, is where the actual text goes. And I see that here I have a mistake because this is actually for the title. So I'm not sure why I called that text, so the class, but yeah, never mind. Okay, and now here in this accordion, all we need to do is to loop over this array of objects like we always do. And then for each of the objects, we want to render one of these items. And actually, to make this a bit more reusable, let's accept some generic data here, basically. And so then here we pass that data in. And as the data, we use the FAQs. And so then we could reuse this same accordion with different arrays. Okay, this one here should have the class name of accordion. And then here is where the mapping will happen. So that's data.map. And then for each of these elements, and we could also call them frequently asked question, but let's just go for the generic element. And so, as we said before, we want to render one accordion item for each of them. And what do we want to pass in there? Well, the title will be at element.title. So that's this one here. And then also the text coming from that same object. So element.text. And now we also want the number. So this one here should automatically be number 1, 2, and 3. So we can do that very easily by using the index that is also passed in the map. And that's very easy to do because the callback here in the map actually also gets passed the current index. So besides the current element, it also gets the current index. So as a second argument, so let's call that I. And so then we can pass in as num simply I. And that's it. All right, so we have something here. Let's just make this a bit smaller. Well, not all of it. Let's maybe close down the sidebar. Yeah, that's a lot better. Can make it a bit smaller even. And so let's compare. So here we actually have like 0, 1. And then also the text here looks a bit different. So let's see. But yeah, the class names all look correct. But now let's just quickly take care of the numbers here. So here we want to have 0, 1, 0, 2, and 0, 3. So let's do some magic here. Let's say if the number is less than 9, then here please place a 0 and then the number plus 1. But if not, so right here, then it's just number plus 1. Okay, that looks much better. And then here, let's just change this one to title. So that should work. And yeah. And with this, let's go back to the original, because now we need to start thinking about state. So remember how we can open and close each of these boxes here individually, which basically means that each of these boxes holds their own state. So whenever we click here, you see that the UI changes. So that's the most fundamental thing that we need to think about. Whenever the UI changes, so whenever there is some update here happening in the UI, it means that we need a piece of state. Now, each of these items here operates completely independently from the other ones. So if I open this one here, nothing happens to the other two. So I can open all of them at the same time, or I can have all of them close, meaning that, again, each of them really operates in an independent way, which means that each of them must hold their own state. So again, that's because this one can be open, but this one as well. And so what that means is that we should now define a state variable in each of these items. So that's right here. And so then we use our friend useState. So let's call our state variable isOpen and set isOpen. So useState, which was then automatically imported. So this one right here, make sure you have that. And then by default, it will be false. So by default, we want each box to be closed. So we declared our state variable, and now let's use it. So that's the same three-step process as always. We define it, we use it, and then we update it. So basically what we want to do when isOpen is false, so when this is closed, is to not display this content box down here. Or in other words, we want some conditional rendering of this part. So let's place it into the JavaScript mode, and then let's say isOpen, and then conditional rendering like this. Now in this case, here also this should be a plus, not a minus. And so let's also come here and say isOpen, then show the minus, and if not, then please show the plus. Close the JavaScript mode, and so with this we have the pluses showing. All right, now all we need to happen is that, of course, when we click here, the box should actually open. So you see that with the CSS style, I applied this hand cursor here to the entire div, so to the entire element. And so this is where we then want to listen for the click event. So right here on this div. So let's say on click, and then here we will pass in a function called handle toggle. And so let's go define that function. So just like before, we just define an outside function with the keyword of handle here, which is totally optional, but it makes it easy to understand that this is a function that will be used as an event handler. And so now here let's use set isOpen, and then we take the current one. So we can just call it current if we want. Of course, we can also call it isOpen. Yeah, anything works. And then we just want to do the opposite. All right. So that didn't work yet. Maybe let's just reload here. That is sometimes necessary. And yes, that works. And if I close again, it closes. Beautiful. Now here we have some errors, and that's just because of the key prop. So here we need to pass in a unique key prop, and we could now actually use I, which is unique actually. So it's this 0, 1, and 2 coming from the array iteration, but it's better to not rely on that and instead use something that's truly unique. So that's, for example, the title of each element. Close this one here. And indeed, it works on all of them. There's just one small detail missing, which is that when this is open, we get this green border here, and all the text becomes green. So that's just one special class that gets added to the item whenever it is open. So on the item, that's right here. So again, we want to add a second class here in case that it is open. And so for that, we need some more conditional rendering, basically, in this case of classes. So here we now need to construct a template string or a template literal, which already has the item string. And then here, based on a condition, so based on isOpen, we either want to add open or nothing. And that's it. And that works. Well, this kind of didn't become green for some reason. Let's check out our CSS here maybe. maybe there's something that I didn't do right. Yeah, so here it should be title. Yes, beautiful. And with this, we actually finished this accordion, at least for now. So later in this section, there is the second part of this exercise where we will make it a bit more realistic, where only one of these three can be opened at the same time. So moving on now, it's time to learn about yet another fundamental concept that we use all the time in React development, and that is the children prop. So we have finished this project right here, and so we can basically finish this with Control C. And so now if we reload, you immediately see that the connection has been lost, or you could also simply have closed this VS Code window right here. Okay. And now what I want to do in this lecture and the next one, as I introduce you to the children prop, is to use the steps component that we built before. So let's go back to the steps folder and open it up in VS Code. And again, you can do that in any way that you wish. Now I will now actually duplicate this file. So this app.js in which we are working, I will copy and then paste so that we can keep the first version of the code that we wrote. So calling this one app version 1. And so now we can continue the work here in this file. All right. So let's here come to the terminal and then write npm start so that our project opens up again here in the browser. All right. Yeah, remember how we had actually included the steps component here twice. So let's remove or comment out one of them. And so yeah, it's gone. And as always, it's important to keep the console open and maybe also the components tree. But for now, let's stay on the console. Okay, so the idea of this lecture is to create a reusable button that we can use instead of these two ones here. And I want to add an emoji to these buttons here as well. So let's take a look at where they are. Yeah, so these two buttons here. Again, I now want to create a reusable button that we use instead of these two. So let's do that. And we start by using the knowledge that we already have. So let's say function button. And then all this will do is to return a button element, which should also have this style here and an on-click event handler. So let's just copy these two here. And also let's place some text here for now. And so now the idea is that we can pass in the background color, the color, this on-click handler here, and the text as props. So basically we want to accept some props here for the text color. So let's actually call that text color. So text color, background color, the on-click handler, and also the text. And so then here, let's use that button actually. So before we keep working on the button, let's include it here immediately. Let's right away delete this one. And so we use our component that we are building right now. So let's say text color should be this one here. Or actually that's the background color, of course. So BG color, then the text color. This one should be FFF for white, and then also the on-click prop. And here we want to specify the handle previous function. All right, then we close. And also the text. So here, this one said previous. And so now let's come to our button down here, and let's use these values here instead of the hard-coded values. So here, background color should be the BG prop that we received, and this one should be the text color that we receive as a prop. Then here we want on click, and here, instead of just this generic text, we want, again, the text that we receive as a prop. So let's give it a save, maybe reload even, and you see, as we use this button, it still works and looks exactly the same as before. So let's then do the same thing with this one here. So that's just copy and pasting this one and then changing the on-click handler to handle next, and here next. Let's delete this button. And so now with this, we have exactly the same functionality as we had before, but we extracted these buttons that we had here into a reusable button component, which right now accepts the text color, the background, the on-click handler, and the text. So passing all these data here as props into this component should be pretty clear at this point. So hopefully you understood exactly how that works in previous lectures. But anyway, let's now say that we also want to add an emoji. So that's easy enough. We just accept that here as a prop. So emoji, and then let's add that here before the text. And let's actually create a span element for this emoji. So we create a span, and then in there, we put our emoji and then the text. Okay, and then let's actually pass that emoji in. And then let's here maybe search for finger, because I want this one here for previous. And then one finger pointing in the opposite direction for next. So that's this one. Okay, give it a save. And yeah, that worked nice. So we have our emojis and our text, and it works exactly as we specified our button down here. But now let's say that I wanted this emoji here to be on this left side, but the other emoji on the right side, so that it would say next, and then pointing right to the right side. So with this, we kind of have a problem, because we already have so many props. And so do you think that we should add yet another prop basically for this direction? Well, maybe not. Maybe it's getting a little bit too crazy here with all these props, and we could keep adding more and more to customize this button even more. But I think at this point we should not add, for example, this one here, like for the direction or for the side of the emoji, and instead make use of the children prop that I mentioned at the beginning of the video. So instead of passing in this side here, this emoji and the text, which are basically the content here of this button element, what if we could simply pass the content right into the button as well? Or in other words, what if we could pass simply some JSX into the component, and then the component could use that JSX and simply display it? Well, we can actually do that in React. So let's come up here and notice how up until this point, all our components have always been self-closing. So we never had like this, and then any content, and then closed the element. So we never had this before, but in fact, we can do exactly this. So just like we do with HTML elements, where we have an opening tag, then some content, and then a closing tag, we can do exactly the same with React components. So here, of course, I don't want that gibberish. Let's just put it back for now. But basically what we want is to now here write that span with the emoji. So this one, and then previous. So this is exactly what we want as the content of this button. And if we were writing the button as a simple HTML button, this is what we would write. So that's actually exactly what we did right down here inside this button. And so again, we can do exactly the same thing with our React components. So then we no longer need this and this. And let's then do the same thing here. And so now comes that part where we can very easily change the direction or the side of the emoji, because we can simply write next, and then we put our emoji in the JSX on the right side. So easy, right? Well, I forgot to close our button here. Okay, and now of course you don't see any content here anymore because we no longer are passing in the text and the emoji. And so now it's time to fix this. So basically now it is time to give the button element access to whatever content we wrote into the opening tag and the closing tag. And so that's where finally the children prop comes into play. So the children prop is a prop that each React component automatically receives. And the value of the children prop is exactly what is between the opening and the closing tag of the component. So let's remove all of this. And then we simply need to write children. And so this really is a predefined keyword inside React. And so, as a final step, we can remove all of this and simply use the children here. Give it a save, and there we go. Beautiful. So we have exactly what we set out to build. We have the emoji here on the left side and here on the right side. And of course, we could do anything here. So we could have even more emojis, even more elements. And yeah, we could do really whatever we wanted. Because this content here of this element would simply be passed as the children prop into the button. And then here we use that children prop and display all that content right here inside this HTML button. And with this, we just gained a brand new and really, really important tool that is used all the time in React. It's actually one of its most useful features, I would say. And the reason for that is that it allows us to make our components truly reusable. So with this children prop, I am now able to pass whatever content I want into this button element. And the button component doesn't even need to know what content this is going to be. All it does is to take the children, so all the content and all the JSX that we just passed in, and will simply then render it inside this button component. And so because of that, we can think of the children prop as a hole that can be filled by us passing in the content into that component. And if for some reason this seems strange, don't worry, we will use this children prop all the time, all the way until the end of the course. And now, just to finish, let's quickly recap what we just did here. So, by using the children prop in the button component, we basically left an empty hole right in the component that we could then fill with any JSX markup that the component receives as children. But then the question is, how do we pass in these children? Well, when we include the button component in some JSX, instead of immediately closing the element, we can write some more JSX into that element. So just like we can write any HTML markup inside other HTML elements, right? So just like in HTML, we can write anything that we want between the opening and the closing tag of the component that we are using. So in this example, this piece of JSX creates the elements that are then the children of the button component, and they will then be accessible inside that button as props.children. So that's why we say it is the children prop. So basically, by defining child elements like this, we are passing them into the button just like we can pass in any other prop. The difference is in the way in which we specify other props, so the more regular props, and this one. So by passing in content between the opening and the closing tag of an element, we basically fill the hole that we left in the component by using props.children in the JSX of that button, so of that button component. So if we think about this, the children prop is really an ideal way of making reusable and configurable components, especially when it comes to the content of the component. So for example, let's say that we wanted to create a second similar button, but with some other emojis and text. Well, now that we know about the children prop, that is really easy. All we have to do is to pass in some different JSX, and then the button gets completely different content. And this technique is really useful for building generic components that do not know about their content before actually being used. Like, for example, a modal window, a generic slider, or simply a generic button like the one that we just built. So again, this button component had absolutely no idea about the content that it was receiving, and therefore about the content that it was displaying. And so this is really amazing to create generic and reusable components. So using the children prop like this is really an extremely powerful technique that you will need to master as you learn React. But we will use this over and over again, and so there will be plenty of time to practice. And actually starting right in the next video. Let's now build another reusable component by leveraging the children prop once again. And this time, let's say that we wanted a component to display a message. And so that message will always be this paragraph element. It will also always contain this step here, for example, in an H3 element. And then it will contain in an H3 element, so like this. And then it will contain something that we pass in. So some content such as this message right here. So let's once again use the children prop in order to create such a component. So this component I'm going to call the step message. So step message. And then I will for now just copy this. So copy all of this. And so, as I said, we want basically always to display the current step and then here whatever content that we get. So we need to receive two props here. First is this step. And then again, the children prop, which each component, remember, automatically receives as soon as we pass in some content between the opening and the closing tag when we call, so when we use the component. So now we got the step, and then right after that step, let's simply display whatever children that we receive. So this part here is then that empty hole that we talked about in the last lecture. And this empty hole can then of course be filled with whatever we pass in. And again, whatever we pass in between the opening and the closing tag of step message. So here in the button, that hole was basically all the content of the button. So the button here only displays exactly what was passed in. But here we will also, in addition, always display this part. So the H3 with the step itself. Okay, and now let's, where is that? Yeah, so let's now replace this message right here with the step message. Now the step, of course, we have to pass in just like any other prop. Not span, step. Okay, and now here between the opening and closing tag, we basically define the children prop. So this here will then become the children prop. And if you get rid of all this, then let's see what happens. Well, nothing really happened. Of course. I mean, we didn't really return anything here. So we just wrote some JSX, but we didn't return it. We also get some warning here that the h3 cannot be inside of a p. So let's then replace this p just with a div. Give it a save, and there it is. Beautiful. So it always displays the current step and of course the message that we had before, because we passed that in right here, and so that is exactly what we had before as well. And now of course we could reuse this anywhere we wanted. So let's say that here, after the steps, we wanted somewhere else in the app also to have a step message. Let's say step number 1. And then here maybe the content is pass in content. Let's do another paragraph with some emoji here. It does not matter at all what we have here. And so then here we have step 1 like this, and we can do as many as we want. So let's copy paste that. Let's say, for example, step 2, read children prop, and then maybe some other emoji. Give it a save. And so now we have, again, created a reusable component here that we can use anywhere in our application and give it any content that we want. And it will always, as you see, display this step here with the number that we gave it, and then whatever content that we passed into it. So into the component itself. Let's come back here. And here I just thought that maybe we could use our button again. So why not? And then it makes even more sense to have these different props, because now we can basically customize them in a different way. So let's say here we wanted a different background color and a different text color. These should be strings like this. And we're missing the onClick event handler. And so here, let's just define an inline function. And the emphasis is again on defining a function. So here we need to pass in a function, not call a function. Let's just alert something here. It doesn't really matter. So let's say learn how to, and then we can just use this here, just so that it's related to each of the steps. So we opened the button, then we have the closing tag, and now we can pass whatever we want in here. And of course, this thing that we pass can also just be regular text. So I'll give it a save, and there is our button. It still works, so we are successfully passing in the onClick handler and then using it. The styling looks a little bit off, but I guess that's because I styled those one here. Well, let's see actually, just to make sure there's nothing wrong. Yeah, in fact, these buttons get these styles because they are a children of some element with the buttons class. All right, but that doesn't really matter. We could, of course, wrap this in a div with the class of buttons. That might work, or maybe that will then mess up some other styling. Well, that doesn't really work, but also because it's buttons. Yeah, nice. That looks better actually. And so with this, we can see that we were really able to customize once again our button here. Some parts with normal props like these 3, and then the content itself here with the children prop. So if we always just want to pass in a string, this could of course also be a normal prop. But since sometimes we want some other content, like here with some actual JSX, like this span element here, well then we should really take advantage of the children prop. And now to really drive this message home so that you really understand how to work with this important children prop, let's go back to our accordion component exercise and use it there as well. Let's now take everything that we learned throughout this section in order to make the accordion that we started building earlier a bit better and a bit more real world. And here it is. So just like before, when I click on one of the items, then it will open. But when I click on another one, then only this one stays open and all the other ones are closed. So basically what this means is that now each of the items no longer controls whether they are open or not. Instead, it is now the accordion who knows which of the items are opened, and then only that item basically is allowed to be open. So for example, if item number 3 is the one that's currently opened, then number 1, 2, and 23 need to be closed. So again, all of these items here need to know which is the currently open item. And so that means that we now need to move our state from the item onto here the accordion. Now I still have the code here from the part 1 of the exercise, and to let me now fork this so I can basically leave the other part unchanged. But you can totally also work on top of version 1. So then you only have that one. So let's now remove this piece of state, because again, now each item no longer controls whether it is open or not. And then we get a bunch of errors, but that's not a problem. For now, at least. So here, let's now create that piece of state I was talking about, which will be current open. And so here we will store the number of the item that is currently open. Set is open use state, and we will start with null. So then none of them will be open in the beginning. So again, this cur open state variable will basically hold the number, so this number right here, of the item that is currently open. And so then we pass that cur open into the accordion item, and then from there it can calculate whether it is currently open or not. So let's do that. Let's pass cur open in. So we use a prop called cur open to pass that in, and then we also need to pass this setter function in, so that then down here in the item we can set the current item to the one that has been clicked. And here let's use the convention we used before, which is to start with the on prefix. So let's say on open set is open. And now here let's then receive those props. So cur open and on open. Here let's for now just comment this out to get rid of this error right there. And then here, as I was saying, we can basically calculate whether this item is currently opened or not. So we can say again is open, so bringing back the variable name from before, and then if the number of this item is equal to the currently open one. So in that case, is open will be true, and then it will be, well, displayed as open. So let's change this here from null to 1, and so that works. So remember that these one add 1, and so this is 0, 1, and 2. So if I set 2, then that one is open, and then with 0, the first one is open. Great. So we created a state variable, we used it in the UI, this time by passing it into the item, and then using it to compute whether the item is currently the open one or if it's not. All right, let's set this back to null, because of course now we want to update the state by clicking on each of these. So that's right here. So let's get rid of all that, and then let's use our onOpen function. And here it's very simple. All we want to do is to pass in the number. So for example, if we are here in item number 1, then when we click, onOpen will run with number 1. And remember that onOpen is basically setIsOpen, which should be called setCurrentOpen. All right, so we run it with number 1, and so then the state curOpen becomes 1. And then what happens down here again is that 1 is equal to 1. And so then that item will become open, and all the other ones will stay closed. For example, this one here, item 0, well, item 0 is different than 1. So isOpen is false. And that works beautifully. Great. And I know this can be pretty confusing because we're passing state up and down, but this is basically just the idea of lifting up state. So before we had the state right here in each item, but then suddenly all of them need to know about the current state. And so therefore we can say that we lifted state up to the closest parent. All right, so after this exercise is done, please take some time to analyze the data flow here in great detail. I'm just moving a bit faster here because we already learned about all of this, and this is just an exercise. Okay, now next up what I want to do is to use our knowledge about the children prop. So instead of passing the text in here like this, it's actually a lot nicer to define the text basically as content. So let's pass that text in here. So l.text, and let's close this. And indeed, now the text is temporarily gone. So we no longer need this prop here, but we need the children prop, which I like to add either to the end or to the beginning of this list. And then here, that's no longer text, but children. Yeah, that works great. And with this, we are a lot more flexible when it comes to the kind of content that should be displayed in each of the items. So let's add one manually here. And so that's where that 23 comes from in the demo that I showed you earlier. So outside this loop, let's now create just one test one here. Test 1. And this should actually be a string, I guess. The number, let's say 22. Here, let's again repeat the title. And as for the content, let's just come here and copy this. You can write it by hand if you want, or you can just write really whatever you want. So just wrapping this here in a P. This one in a UL. And each of these here simply one LI. So just, I mean, this is not really necessary. This is just to show you. Okay. And so if we click here now, you see that we are able to pass in this entire JSX as the content. And so that's again, thanks to the children prop. So here, of course, we only have text, but yeah, here we have this entire piece of HTML, basically. And of course, our entire functionality here of the accordion still works just like before. So we can only have one of them open at the same time. Now there's just one small thing missing, which is that when we click here on an opened one, it doesn't close, right? So probably you can see that for yourself. And so what we need to do now is to basically set the state to null whenever it is opened already. So when we click here and it is already open, then the new state, so the new current open, should become null. And only otherwise it should be the number. And so that will fix it, indeed. Great. So that exercise is finished as well, and I hope you found it useful. And now, as I said before, please take some time to analyze the code and the data flow right here in this component. And then once you're done, you are ready for the mandatory coding challenge in this section. Let's once again finish a section with a nice coding challenge so that we can practice everything that we learned in this section. And I can't stress enough how important these challenges are. So please don't skip this video right now. So we are going to build this very simple tip calculator. So here you can input how much the bill was. So let's say $100. And then you can say how satisfied or dissatisfied you were with the service and your friend. So let's say that 2 people were out for dinner, and then basically together you decide how much the tip should be. So for example, if you say it was good, that can be 10%, but your friend says 0%. And so then the average between the two of you is 5%, which is indeed these $5 here. And so the final bill is $105, which is 100 plus the $5 tip. And of course, if your friend found it absolutely amazing, then here the average between the two of you is 15, and therefore it is a $15 tip. And as you change the value here, of course, it keeps updating down here. You also have this reset button that you can click, which will set everything back to the initial values. Now, as you build this, I want you to create one separate component for each of these pieces. So this one here should be one component. For example, it can be called the bill input. Then you should have one component for this, for example, called select percentage, and then reuse that component here again. So with some different text, but it should be the same component. Then here you have some output component for displaying this text, and then a reset component just for this button. Okay? Now these 3 inputs here, they are of course controlled elements, and so you can start by adding their state value into the component itself, but you will soon notice that you actually need this state in the parent component, because you will need it to calculate this output right here. So then you will have to use the technique of lifting state up. And so hopefully you remember all the logic of how that works and why we have to do that. And in case there is still some doubt, you can always go back and check out the lectures where we talked about lifting up state. And of course, all the other things that you need here in this challenge. So I'm aware that this challenge is not super easy, but that's what many students actually want. So last time I asked, the large majority wanted really hard challenges. So this is not really hard, I think, but it can be a bit challenging. So it's not just 100% straightforward. Therefore, if you run into any issues, that's no problem at all. So just write the part that you can, and then the rest watch my solution. That's 100% fine. The most important part is that you start writing at least some code and that you try it on your own. And that's enough talk. I see you here in 5 or 10 or whatever time that you need. All right, so we have a lot of code to write, so let's get straight into it. So I will start with the function called tip calculator, which we will then call basically right here. So we need no styles for this app at all. So that's why I didn't provide any CSS starter files. Okay, let's close down the sidebar here. And then let's start by writing out all our components. So the next one is called bill input. Then let's create select percentage. And of course, your component names here can be completely different. Then we have function output. And finally, for reset. All right, now let's build them out one by one. And we can actually start here in the tip calculator, because all that's going to happen here is that I will basically include all the other ones. So let's just create a div here. Then I will want the bill input. I will want 2 select percentages. And of course, we will later on then pass the props into. Here I'm just, again, building the static parts without any data at all. So then we will have the output and we will have our reset button. Okay, let's start with this one. Okay. Then I will place this one into a label. How much was the bill? And then finally we have our first input of the type text. And let's add a placeholder as well, which is always nice. And so, yeah, here we got already some, something on the UI. I was just thinking of getting rid of this class. And so then we get rid of basically all the styling altogether. Can just come here to the CSS if we want. And just like this, just to make the font family a bit nicer on the eyes. But anyway, here let's again return a div. And then we have a select element. And as you already know, then inside the select, we have our different options. So 0 is for dissatisfied, which is 0%. Then let's just copy this over a few times. 5, 10, and 20. It was okay is 5%. Then it was good is 10%. And then 20% is for absolutely amazing. Now, we also want some text here, and so we could pass that here in as a prop, but I believe it's a lot nicer to write it right here directly. So, how did you like the service? Then close that. And so basically including the content between the opening and the closing tag. How did your friend like the service? All right. And now I hope you remember how we get this text here, so this content, into select percentage. And that's right. It gets automatically passed in here as the children prop. And so let's create a paragraph or maybe a label with exactly that. There you go. That looks a lot better. So let's move on here. Return. And here we will have an H3. You pay X, which is some dollars, let's say A plus B for the tip. So just some placeholders here for now, because we are building still the static version. And now finally here, a button that says reset. Okay. So that took us some time just to build the static part, and now let's add some state. And the best way to start is to create one piece of state for each of these 3 controlled elements that we need here. Now, as I started by saying in the very beginning, you could have started by creating local state right here in the component. So basically like we learned before. However, you would then quickly discover that you need this input value here, for example, right here in the tip calculator component, because it's here where you will later calculate this tip value right here, so that you can then display it, so you can pass it into output and then render it there. Therefore, I will actually basically immediately lift that state up and not even write it in the bill input. So bill and setBill are equal to use state, and for some reason, sometimes this doesn't really work with the importing. So then let's do it manually. Use state from React. Nice. And actually here, let's start with an empty string. Okay. And then we need to pass both of them in, because of course we will want to update that state each time that the change event is fired here on the input. Remember that? So that's just how controlled elements work. It's always the same recipe, always the same thing, no matter if the state lives right in this component or in another parent component. But the idea is the same, as you will see again in a minute. So let's pass in a prop called bill with the value of bill, and then let's again use our on prefix. So on set bill will be set bill. But of course, it would be just as valid to pass in a prop with exactly this name. So here we receive bill and on set bill. And let's then use these values here. So the value of this input field should be bill, and when it changes, then we want to basically set the bill based on e.target.value, and we need to convert that whole thing to a number. Okay, now unfortunately the dev tools don't work as we experienced a few times already, but in order to see it, we can actually pass it in here into the output. So bill is bill, because remember how we actually display that bill value right here. So that's exactly this 80 right there. So let's then receive it here. So that's this first value right here. So let's see. And yeah, that works beautifully. So just like any normal controlled component or controlled element, with the difference that the state doesn't live in the component itself, but in the parent component. And now let's use the exact same logic for these select percentage components. So let's create two pieces of state, one for each of them. So that's going to be %1 and set %1. And the default here is 0. And then let's just copy paste. And so this one here will take the value of %1. So the percentage prop that this one will receive will be equal to the %1 state, while this other one, so this one also gets a percentage prop, of course, but here the value will be given by this other state. And so with this, we can use the same component to set these two different state values. Okay, and now also the onSelect handler, and this one will be set %1 while again, here on select will be set %2. All right, then down here we can receive them besides the children. So the percentage and on select. And so now all we have to do is value is equal to the percentage that we receive, and then on change, and then on select. So we can immediately convert to a number, e.target.value. It's always the same recipe. So now we will not be able to immediately see it here, but it seems to be working. Both of them. All right, and so now we have all our state that we need. And so based on this, we now can already calculate the tip. So how do we do that? Should we create a new piece of state for the tip here? Well, there is actually no need, and it makes no sense to do so, because the tip can be completely calculated from the bill and the percentages. And so we are in the presence of derived state. So the tip is simply the bill times the average of the two percentages. So that's %1 plus %2 divided by 2, and then the whole thing divided by 100. Because here the percentages are these actual values, so between 0 and 100, but then we need to calculate them between 0 and 1, because, well, that's how we calculate percentages. And here, I don't really agree with this parenthesis here. Let's place that right here. So with this, we calculate the average percentage and convert it to a number between 0 and 1. And then simply by multiplying it with the bill, we get the amount of the tip. And so now we are ready to also pass that here into the output. I mean, here we receive it. To pass it, it's actually here. So tip equal tip. And so we can already display that here. And then here, it's as simple as adding the two together. So let's say 100 and one was dissatisfied, the other one was amazing. And so the average is 10%, which is exactly those $10. Yep, then it becomes 20, which together makes 120. Just make the dollar sign there. And so, yeah, this seems to be working just fine. All we have to do now is to make this reset button work. But that is fortunately very simple. So function handle reset. And here all we need to do is really to set all of the values back to those initial states. So set %1 back to 0. And here the same thing. And then we just pass it right here. So on reset should become handle reset. Like this. And then, of course, the on click event handler on reset. And let's see. And beautiful. So everything back to normal. And now what we should do is to not display the button and this output whenever there is actually no tip. So then it makes no sense to display that, right? So these two things right here. So let's wrap them into the JavaScript mode. And then let's say bill greater than 0 and end. And now here we get a problem because we have one piece of JSX which has basically two top-level elements, which is not allowed. So there can only be one parent element. And so, once again, our fragment here is a very nice option. We don't need these. Give it a save, and yeah, now they're gone. And as soon as we start writing here, we have a tip value, and then we can see the output there, enter button. Great, and that's actually it. So I believe the hard part here was to have all the state living in the tip calculator, but then having these two components here needing that state and also updating that state. So there's a lot of state passing around here with all of these props. Yeah, and then also here the tip itself. So realizing that this indeed needs to be derived state, because otherwise you would have to calculate this tip all over the place in order to keep it in sync with the bill and these both percentages. So that would be a lot of work. And instead, by having it as derived state, each time that the component re-renders as the state is updated, this value will be calculated again and can then also be rendered here onto the UI. Great, but that's enough talk. The video is running long enough already. And so, yeah, I just hope that you did at least part of this coding challenge. And any questions that you have, just post them in the Q&A along with your solution if you'd like. So it's always nice to see different approaches resulting in the same working application. And with this, we then actually reach the end of the section, but also of part 1, basically. All we have to do, if you want, is now a complete practice project that is coming up next. So it's a really cool project once again, and so I highly encourage you to not skip it and meet me there as soon as possible. To finish part 1 of this course, so the React fundamentals, we'll review everything we have learned up until this point by building this brand new project called Eat and Split. Now, since this is a bonus practice project, it doesn't introduce any new concepts, and so you can safely skip it if you're pressed for time. However, in my experience, practicing these fundamentals of state, props, and events is absolutely crucial for your progress, and also to understand all the content that follows in the rest of the course. So if you can, make sure to build this project together with me now, or you can even try it completely on your own. So as always, let's start by setting up a new project and by taking a look at the final version of the app that we're going to build. So let's fire up our terminal or the command prompt in Windows, and then, as always, we navigate to the folder where we want the project to live. So for me, that's the desktop. For you, it can be any other folder on your system. And so now, as always, let's type npx create react app version 5, and then here the name of the project is Eat and Split. So basically Eat and Split, but for short. And the name of the app is Eat and Split because this is the application that we are going to build. So it's an application where you can basically go out with a friend to have dinner or lunch, and then you can split the bill using this application. So here we have our list of friends, and we can also add some other friends down here. Let's say Jane, and then the friend will get a random image exactly like this. But as I said, the main functionality of this app is that you can share a meal with a friend, and then you can select that friend and share the bill with that friend. So for example, let's split a bill with Anthony. So let's say in total we spent 100 euros or $100, and let's say my part of the bill was 40. So I consumed food worth 40 euros, and so then that means that Anthony spend the other 60 euros. Then down here we can select who is paying the bill. So let's say that I am spending the bill, so that's you, but it could also be Anthony. So if I pay the bill, then after splitting the bill, Anthony should owe me 60 euros, right? So right now it says here that we are even, but now as I split the bill, Anthony owes me 60 euros, right? And it could also be the other way around. So let's just reload here to reset. So again, let's say the bill was 100 euro, of which I spent 40. And so now if Anthony pays the entire bill, I will owe him 40 euros, just as it says here. And of course, this logic will become more clear as we start building this functionality. But before we go do that, let's again split this UI into components, which is the first step of the thinking in React process. So here is the entire UI at once, which makes it a bit easier to split the UI into the components that we need to implement. Now, splitting a UI into different components can be a pretty subjective process, but we will learn some techniques about how to do this in the next section. But for now, in this case, I think that it's actually pretty obvious. So we have our list of friends here at the left side, and then in there we have a few friends themselves. So just like we did many times before, we have basically one component for the list of friends, and then we have one component for each friend itself. Then down here we have this form where we add new friends, and then here on the right side we have the form where we input the bill data and how it should be split. So pretty straightforward, and so let's now move on and start implementing some of these components statically, so without any state yet. Okay, so let's begin by rendering the list of friends. And to start, let's again come here to our starter files, and then inside the eat and split folder, let's get app.js and index.css. So both of them, copy them, and I will just, as always, change the name here. And then inside the source, let's paste them. And so here we need to replace both of them because they already existed. And then let's delete all the junk files. So all of these, so that we end up only with app.js, index.css, and index.js. And so now let's get started by opening up this folder in VS Code. So index.js, here we need to, as always, clean up a little bit. And then also remove these files that no longer exist. Yeah, and that's it. So we have our index.css file, which as always, please feel free to explore it. But our main work is going to happen in app.js. And in fact, let's start by creating the app component, which is as always our main parent component. And here, this one, we need to export default because this is the component that index.js imports. Okay, so let's just return some div here. Hello, give it a save, and then let's open up the integrated terminal so that we can start up this app. Just make sure that you are in the correct folder here, and then just type npm start, which should then open a new tab over here. So let's wait for that. And indeed, here it is. And yeah, we got our hello, which is nicely centered. And that is because of the CSS that I provided, and which is, as always, automatically included right here already. So index.js is importing our index.css. And so that's why these styles are now automatically applied. Now back here in our code, we see that we have this initial friends array, which as always is simply an array of objects, and in this case of some friends, where each of them has an ID, a name, an image, which is coming from this URL here, and then the balance that we saw before. And more about what these numbers here mean in a minute. But for now, let's then start building that list of friends component. And here let's again build all the components right into just one file, so that we don't have to jump around all the time. So friends, list, and then here let's return a list, which for now will only contain list. And so now we will then include this component right here in the app. So friends, list, and no props. And here we will now place this into this div with a class name of app, which has been provided in the CSS file. And then also this should be inside a sidebar. So another div, class name sidebar. Okay. As always, it's a good idea to have the terminal open. And for now, all I'm doing here is to inspect the layout, basically. So here is that div with the app, which you can see is a grid container. And then we have the sidebar. And in there we have the UL, which you can also see is automatically a flex container. So all this layout stuff, of course, I already did it in advance, so that we can focus exclusively on React. But when you build your own applications in the future, then, of course, you will have to do all of that as well. But since this is not a CSS course, well, I already wrote it beforehand so that this is a lot faster. But anyway, let's now here actually render these friends that are in this array right here. So let's, for now, create a variable called friends, which we will simply set to the initial friends. And later on, we will then change this here. But for now, this is the array that we want to render. So let's say friends.map. And by now, you should be pretty familiar with this syntax. So each of the objects is a friend. And then for now, let's just render a list element. And then simply here with friend.name. And indeed, immediately we get Clark, Sarah, and Anthony. So those are our 3 friends. At least the ones that we want to share a meal with here in this example. Now, we could, of course, write the JSX right here inside this loop, but since we will have a lot of code for each of the friends, we should actually move that into a separate component. And so let's do that and simply call it friend. Well, not like this. And so this friend should then probably receive the current friend object, right? And so therefore we accept that here as a prop. Okay, and now basically we can move that here. And then here what we want to render is that friend. And into that friend we pass the friend prop with the value of friend. Close it down, and then we should also, of course, specify the key prop. So this unique value that each of the elements in a list needs to have. And so for that, we actually have friend.id. And so as we reload, it looks exactly the same as before, but we have each friend inside its own component. And so then we start seeing here our component tree. Here we still have the error from before, but now it's gone. So we already have a small component tree with app, friends list, and then in there each friend with their unique key. But now let's keep moving here and let's actually build this list item here. So to make it a bit more complete. So first we have the image of the friend, which is at friend.image. And then we should also not forget the alt tag. So here let's just use the name of the friend. Okay, then we're using an h3 element for the name of the friend. And so that's looking already close to the demo right here. The only thing that's missing is this button and then this text here. Let me actually just reload this so that you can see that we have basically these three colors here. So whenever you owe your friend, then the text will be red. If they owe you, it will be green. And if you are even, then there is no styling applied. So let's implement that here. And so let's see what these numbers here actually mean. So here we have this balance property. And if that's a negative value, that means that you owe your friend. So in this case, you owe Clark 7. But if the balance between the two friends is positive like here, then that means that the friend owes you. And so let's now use that knowledge here to do this conditional styling and also this conditional text, because they are in fact different. So let's do friend.balance. So if that is negative, then let's render a paragraph with the class name of red, saying you owe, and then the name of the friend, dot name, and then friend dot balance, and then 0, which I don't really know how to type on the US keyboard that I'm using. And so let's just copy it from here. Or of course, you can also use the $sign like this. So that doesn't really matter. But what matters is that now we have this text here. Here we just want to remove that negative sign. So let's actually do math.abs, which stands for absolute, and that's a bit nicer. Okay, and now let's copy this 3 times. And so here I decided to basically use 3 times the AND operator for conditional rendering instead of a nested ternary. So we could also have done this condition right here with a ternary operator, and then in the else branch, we could have another ternary operator for these 2 cases here. So friend's balance greater than 0 or equal 0. But since these 3 cases are mutually exclusive, it's easier to simply have 3 times this AND. And so then only one of these will apply. But anyway, here it is green, and here we have no class at all. So no special styling. And here let's say you and your friend are even. Okay, and now here we need to also change the text to your friend owes you 20 euros. And so that's in fact exactly what we have here. Now all we are missing is the button here on the right side, and that's easy enough. Just button with the class name of button, and then select. And there we go. That's our list of friends. So we already built 2 of the 4 components that we identified. And so next, let's build the 2 forms. So that's this form right here, and then the main bill splitting form. But we will start with this small and easy one down here. So back to our app. Let's create the next component, which is called form add friend. So here let's return a form element with the class name of form add friend. So just the same as the component name itself. let's have one label which says friend name. Then let's here add one emoji with like 2 people, for example here, like this, and then the actual input field of the type text, and that's it. So again, we are just building the static part, so we have no state here. And so for now, this element here is of course not a controlled element yet. So here, next up, let's have the image URL. And again, I will use some emoji here. Let's go for this one. And then here, basically, we can just duplicate this line of text for now. So giving that a save. And finally, we need a button again. So that's this button element with the class name of button. So now we could just copy this here and paste it here, this class name button. So now we could just copy this here and paste it down here. But since we need a button like this multiple times throughout the user interface, we can just actually place this here into its own component. So we need to reuse this code right here. And so we just identified a new component that we need. All right. And here, let's do exactly what we did before. So we will specify the children prop, because that content of the button will come into the button via this children prop. So then we just display it here. So remember that the children prop here will be whatever is between the opening tag and the closing tag of calling the component. So now we say button, and then here, just as before, we say select. And so this here is then the children of this button, basically. So the children props right here will be select in this case. And so indeed, everything works just as before. And now we can then use the same button here, but this time the text will be add. All right, and we can't see the result of this yet, because we of course need to include it also here in the app in the sidebar. So form, add friend, and there it is. So all we're missing now here is some button. So you see that here we have this button which says add friend. And so whenever we click this button, then the form will open. But again, for now, our app is not dynamic like this, but we still want the add friend button there. So right here between these two. And so we use again our button component. And so you see that this is a lot more comfortable than always having to use the normal button element with the button class attached to it. So here we used that class once right here, and then we can reuse that button with the class over and over again. Add friend. Well, that looks a bit weird. I believe that the button actually should be after. All right. So in fact, this is what we get here when we click. So the button changed the text to close, and it is below. All right, let's just give ourselves a bit more space. And then let's move on to building this other main form over here. So that one is called the form split bill. Form split bill. And then let's again return a form element with the class name equal to the component name. So form split bill, but not in camel case, but in this other case that's more common in CSS. So first we have the title split a bill with, and then here actually the name of the friend, which means that we will at some point need to pass in the friend object here into this component. But for now, we can't really do that because we don't have a way yet of selecting one of the friends and then passing that friend object into the form. So that is what we will do later. But for now, let's just place some placeholder here. Okay, and then before we keep going, let's include that form into the app, and that's outside the sidebar here. So just here inside app, form split bill. And there it is. So let's move back down here and then write the actual content of this form. And actually this is pretty similar to what we have here. So I'll just grab this part and paste that here. And then all we need to do is to change the text here. So first we have the bill value. Then use some money emoji here. Of course, here the text is also different. It's split bill. And then let's copy just this part, paste it here twice. So your expenses or expense. Yet another emoji. And of course, you can split those if you don't want. And now here the expense of your friend. So I'll again just use X for now. And then we want that emoji of two people that we had before to symbolize that this is the friend. Okay, nice. Let's see. And in fact, the only thing that we are missing is now this select here. And also this input right here should be disabled. So when we add something here, for example, our expense is 40, then we should not be allowed to change Clark's expense, because otherwise these two values wouldn't add up to the total bill value. So let's do that. So here we can simply use the disabled attribute. So that's very simple. And you saw that it became grayed out there. And now let's then write that select. So here another money emoji for specifying who is paying the bill. And then here we have a very simple select element with only two options. So option 1 is you. And here let's actually specify the value also as user, and then in this other one as the friend. And then here we again want the friend name, so let's use X. And nice. Yep, that works. And so with this, we actually finished building the static part of the application. And so next up, we are finally ready to start adding some dynamics. So to add some state here. Let's now conditionally display and hide the new friend form. So basically the functionality that we're looking for is clicking on this button will display the form and change the text to close. And then when we click again, it will just hide the form again. So let's think about this. Something should change in the UI as we click this button, right? Or in other words, the UI needs to be re-rendered as a result of the event of clicking that button. And so that is a very good sign that we need a new state variable. So let's go back here and then let's think about where we actually need that state variable. Well, basically we want to display and hide this form here based on that state variable. And where do we do that? So where do we display the form? Well, it is right here. So right here in the app component. And so this is where we now place our new piece of state. So let's call it show, add friend, and set show add friend. We could, of course, have used some shorter variable names here, but you shouldn't be afraid of making your variables pretty descriptive. So use state, and by default, the form should be hidden. And so we set this to false. And once again, it's important that VS Code automatically imported useState from React. So make sure you have that line right there. So we have the first step of creating the state variable with the useState hook. Next up, let's use it. And we will use it to conditionally render this piece of JSX. So just this one component here. And for that, we can again use the AND operator with short circuiting. So show add friend and form add friend. And so now it is gone. So that's no longer here, but if it was true, then it should show up. And indeed, there it is. Okay. And with that in place, let's now go to the third step, which is updating the state. So when do we update the state? Well, it is when we click here on the button. So that's this button right here. And so let's again specify the onClick handler. Now, of course, this button component here doesn't have the onClick property, right? Only the native HTML elements, so for example, this div here, or the actual button does have the onClick property. So let's actually cut it from here and place it a bit closer to the app because, or actually even before, because this is our only reusable component. So let's place it a bit separately. But anyway, as I was saying, this button here can of course accept the onClick prop because it is an HTML element basically. Not technically, but we can think of it as that. So here we can say onClick, but again, our custom button component doesn't have that prop. However, of course, we still want to specify onClick here. Right? And so what we can do is simply, well, accept that here as a prop. And this is actually exactly what we did when we built our first reusable button in the steps component. Remember that? But anyway, now here it's as simple as then passing that onClick right here. And now all we have to do is to pass in the function that we want to be executed when the click happens. So we will create a new function called handle show add friend. So let's copy that. And then, as always, let's create a new event handler function right here. So what should happen here? Well, we want to change the show add friend state, and for that we use the setter function. And what we want to do is to always set the show add friend to the opposite as it is right now. Or in other words, the new state will depend on the current state. And so, as always, or not always, but as many times, we use a callback which gets as an input the current state, and I will just call it show here. And then the new state will be the opposite of that. Again, any name here would work, but, well, we don't have to write the entire thing here. Let's just go for something short. And if I click here, beautiful. So that works perfectly. And now all we have to change is the text here when we click. So now when the form is open, it should say close. And so that's just some more conditional rendering right here in the button actually. So let's wrap this here into JavaScript mode and then let's say show add friend. If so if it is currently true, then we want to display close. And otherwise, then this other string here, which says add friend. Give it a save, and yes, it says close. and now back to the original add friend. Nice. So we are now able to display and hide the form, but of course the form doesn't work yet. And so let's take care of that in the next video. Let's now implement the first feature of our app, which is the ability to add new friends to the list. So let's come here to the form add friend component, which is where that is going to happen. So the first thing is that we need to get the value of these input fields into our application. So right here into this component. And how do we do that? Well, as we already know, we use controlled elements, where we will have one piece of state for each of the inputs, and then as the user types something here, that value here of the input field will be synced with that state. So let's do that, and let's write name and set name. And then, as always, we call our useState. And let's immediately do the same thing also for the image. And now all we have to do is to wire up these states to our input fields. And we have done this many times at this point, so this is hopefully nothing new for you. So again, we first define the state, then we set the value to that state, so basically controlling that input field, and then we listen to the change event with the onChange listener. And what we do is to take the event and then update the state using that event dot target dot value. All right. And let's see. That should already be working. Let's come here to the to the form itself, and then we should see the state down there. Well, somehow that doesn't really work. Let's try that again. And well, yeah, here it is. So that's the state, simply my name written wrong. But yeah, let's now do the same thing here in this other input field. So value, image, and then on change, e set image to e.target.value. All right, then we get some error here for some reason. So let's just reload, get some more space here. And then we should, of course, see this state already in the component. And there it is. Nice. Now, actually here, I want some default already. So let me show you what exactly that is. So by default, we already want this part here of the image URL. So let's copy that. And then let's come down here. And so by default, this will be our image. And then when we actually create the new friend, we will add something to it in order to make it unique. But anyway, now the next step is here to listen for the onSubmit event. So again, just like we have been doing before. So this submit event will get fired whenever we submit the form by clicking there on that button or hitting enter while we are in one of these fields. And so then that submit event gets fired off, and then we call the function which will be handle submit. So then let's create that function, handle submit. And remember that this function here gets called by React with the event object. And so then the first thing that we have to do is to prevent the default action, which would be to reload the entire page, which is not what we want in a single page application like we are building. And so the event handler function for a form, so on an onSubmit, always needs the event.preventDefault. And now let's create a new friend object so that we can then add that to our array. So that should have name, image, and the balance should start at 0, of course. So no one owes anyone anything. We also want an ID. And let's create the ID using the built-in browser crypto.randomuuid. And so this is a very good way of generating random IDs right in the browser. So this is not an external packages, but it won't work in older browsers. But here we don't care about that. We just want to make this work. And so with this, we have a new friend. Let's log it to the console here for now, just to see that everything is working correctly. Give it a save. Let's reload here. And now in the console, we should see that object. And indeed, there it is. So balance. And here, I didn't call the function. I just passed in the function, which of course is not correct. Let's try that again. And now here it is. So this is the random ID that was generated. Here is the image and the name and the balance. Now, as I was saying, I actually want to now add something to this image. So to this string that we already have as a default. So let's create a template literal here. And so now I want to do equal and then the ID. Well, yeah, of course we cannot do that. So let's create this here outside as another variable. So const ID equals this, and then down here, just like this. So the way that this works, and the reason why we are adding this ID here, is that this string here, this URL, if we open it, it will basically give us a small image with the size of 48. But when we reload, it will each time give us a different image. But of course we don't want that. So we want each image to be fixed basically to the person. And the way we can do that is to attach something here. So it doesn't matter what string, but now each time that we open this URL, we will always get the exact same image. So it will always be this one here. And as I reload, we should get exactly the same. Well, that didn't work actually, but maybe that's just because someone else has already used this. But yeah, this here should be pretty unique, and then we should always get the same image. Now there's just some small changes that we should do here. Of course not here, but here. So first, after we submit the form, then we should go back here to the defaults. So let's do that. So set the name back to empty and set the image back to, well, to just this here. Because of course the user could want to input some other URL here. It doesn't have to be this one. It's just the default that we're using so that we don't have to write this manually each time. So if we try this again, then you see that it gets empty. And here it should then also go back to the default. Now, if we submit this right now without anything, then of course something will still get logged to the console. So all of this here, all this code is still executed, but we actually don't want that. So let's add some guard clause here saying that if we have no name or we have no image, then return immediately. And so in this case, nothing is going to happen. So with this, nothing happens, but if we have a name, then of course the code works. Okay, so the form now works, but now comes the harder part. So how do we now actually get this object that we logged here onto our friends list? Well, let's think about it. So each time that we add a new friend, we want that friend immediately added here to the list. So to that UI right here. So we want something to happen in the UI, or in other words, we want the UI to render. And so once again, that's a clear sign that we need some state. So that is pretty clear, but now we need to figure out where to place that piece of state. And for that, let's take a look at our component tree here once again. Yeah, let's see all of it. So our friends list component here is the one that is going to display the friends, right? However, it is the form @friend where we want to update that list of friends because, well, of course, this is where we add a new friend. So the update happens here, but the state itself is needed here in this sibling component. So what does that sound like? Well, it sounds as though we have to lift the friends state up here into the app, right? Because this way, both of these components, or actually all of them, can get access to that friends state. So let's do that. And first of all, let's go to the friends list itself, where right now we have this friends here set to initial friends. And so now let's get rid of this part. And instead, let's create a lifted up state variable in the parent component, which is in this case just app. So friends and set friends and then use state. And what should the initial value be now? Well, not just an empty array, because we actually want these 3 friends here to be visible at the very beginning. I mean, it probably doesn't make a lot of sense for all the users to have these 3 friends, but let's just say that this is how it works. So let's just say that these friends are basically the default friends of everyone, because this is just a demo anyway. Now here then, of course, immediately get the problem that inside the friends list, friends is no longer defined. So we need to fix that by now passing in friends as a prop. So giving this component access to the state by passing it down as a prop. And so here we receive that, and then the component will be happy. So it's back to having this array, and then everything works again. Great. So that's one part. And now we need to give this form here the ability to add new friends. So to update that friends array. And we could do that in 2 ways. So we could directly pass the setFriends function into the, where is it? Yeah, here. So right here into this form. But let's keep all the event handler functions right here. And so let's instead create a function called handle add friend. And then this function here will use that setFriends function. And then we pass this one here down instead. Okay, so let's use setFriends. And of course, this function here then needs to receive a friend object. So that's the new friend that we created down there in that component. And then here, all we do is to take the current friends, which again could be called anything here in this new function. And then we create a brand new array, spread the current friends in there, and add the new one at the end. So again, we do it like this, basically creating a brand new array instead of using like the push function, because that would mutate the original array. So it wouldn't create a new one, and so React in that case would not re-render. I mean, sometimes it might actually work, but it's not supposed to, because in many situations it will actually not work. So don't do that. Don't mutate original arrays, because React is all about immutability. That's also the reason why we are not allowed to mutate props. Remember that? So always creating new arrays here. And the way we do that for adding a new element to an array is by creating a brand new one like this, spreading all the current elements, and then adding the new one to the end, like this. So just like we have been doing. And now let's pass that in here. So on add friend, like this, we pass in handle add friend. So again, we are using this on prefix here, just like React does it for the events, like on click, on change, on mouse over. And so here we create our own, basically like on add friend. So as if this was also an event. Okay, let's copy this. So this should already be working now. And so then let's come down here, pass that in, and instead of logging it to the console, we now want to call this function with the new friend. And this should now work, actually. So we have wired up everything correctly. So we have our shared state here, so our lifted up state, which is now available to the friends list. And we then update that state down here in this component. Well, not this one, but it's not in the tree, of course. But now it will be in the tree. So this was actually a good learning moment. So basically seeing that the component that was not in the UI is of course also not in the component tree here. Right? So now it is, but when I close it, you see that it disappears from here. Okay, but now it is back. And so again, this is where we will update the friend's state and in a way do some child to parent communication. So the parent being the app component. And so then as soon as that state is updated, it's again passed down into the list, which will then re-render. So let's try. And there it is. You and Jonas are even. So this should now create some image there. It always takes some time for some reason. But yeah, that worked beautifully. And we can keep adding more and more. And then this updates the state exactly in the way that I have explained before. Here we update, then that propagates the update basically to the app component, which will then pass it down in the list, which will re-render as a result. Nice. There's just one small thing that we want to do, which is each time that we add a new friend, so that this form is submitted, we then want to immediately close that form, so make it disappear again. So that's easy enough, but let's think about it a little bit. So do you think that we should do that here? So in this component here, is this where we should close the form after we're done? Well, not really, because this part here, this form, is actually not responsible for showing itself or not. So as long as this component is actually included in the component tree, it will be visible. Right? So instead, who controls whether this component is visible or not is the app component by using this state. Right? And so we can use this handler function to not only set the new friend state, but also to hide the form again. So all we have to do is set show add friend and set that to false. So here the state doesn't depend on the previous state. So here we simply want to always set it to false. And yeah, we got the new friend and the form is hidden. And so this actually completes this feature. So just make sure that you take now a minute to review the code that we wrote here. So in particular, the lifting up state and how we then wired everything together. And then once that's done, we will start working on actually making this main part of the application work as well. Now, in order to make our form work, the first thing that we need to do is to add the ability of the user selecting a friend. So whenever we click here on select, it will then open up the form with the information about this user. So here is the name of the user. And yeah, well, that's really all that we need. And then here you also see that the selected friend is marked here with this orange background and the button text changes to close. And then if we click on another one, then the information of this friend is passed in here. So basically what we want is that whenever we click select on one of the friends here in this list component, we want that information to pass here into this form component. So how do we do that? Well, basically we want this component right here. So this friend component, we want it to communicate with this form component. right? So to basically pass it some data. But as we can see here in our own component tree, those are actually sibling components. And actually even worse than sibling components, because the friends are inside the friend list, and friend list itself is then a sibling component of the form. But in any case, since these two now need to share some state, so basically they need to share this friend object that was selected here, we need again some lifted up state. And so the first common parent is again the app component. And so let's in here create a new piece of state called selected friend. And then set selected friend. And here by default, we will have null. So basically no object at all, which means that no friend is selected. And now let's start using this new piece of state here, because when there's no friend selected, which is currently the case, since this is null, then we don't even want this form here to show up, right? So let's go here into our JSX and let's conditionally render this form. So based off the state, let's say selected friend and then the form. So right now selected friend is null, and so the end operator will short circuit and will not display anything. And so then it's gone. Great. So we created the state, we used it already a little bit, and now we need a way of updating it. And so that, of course, is going to happen whenever this button here is clicked. So let's actually create a handler function, again, right here in the component that actually owns that state. So a function that we will then pass down via props, as we have been doing also with the other functions. So let's call this one handle the selection. And so this one should receive a friend object. So all this will do is to set the selected friend to the friend object that it will receive. All right. And so this is the function that will get called whenever we click on this button. And so then whatever button is clicked, the associated friend object will be set as the currently selected friend. All right, so let's pass that down. And here this is getting a bit confusing. Let's just add some spacing between all of these. And so let's pass, let's say on selection will be handled with handle selection. Okay. And now in the friends list, we need to receive that. So on selection, but it is actually not even this component that needs this, but the friend itself. So here we can just pass it through this component by saying on selection as a new prop here should then be passed here into the friend. All right. And so now this is where we will use this function. So that's right here on this button. So on click, and then let's specify our function here because we want to call now, well, not this. So we want to call on selection and pass in the current friend. And that's it. So whatever button here is now going to be clicked, it will take the current friend and it will save it into the selected friend state. So that's the same logic as before with some lifted up state. Then we create a handler function which updates that state, and then we pass that handler function down via props. And so now when we click here, that should actually immediately open up the form. And indeed it does. All right. Now there's still some things missing, but this is already great. Now what we need to do next is to then actually pass that selected friend object here into the form, so that then here we can display the correct name. So that doesn't sound too difficult. And so it's right here. So selected friend should be equal to selected friend. Then let's come down here. Let's receive that selected friend, and then we can use that here. So selected friend dot name, and immediately you see Sarah there. So that's great. Let's just use it here in the other places. So that's right here and right here. Nice. And if we click another one, watch what happens. Yes, it changes to Anthony or to Clark or whatever other friends that we have in our list. Beautiful. So that's working already really nice. Now the next step is to then basically mark this one here also as selected and change the button text here to close. So just as we have here. So you see that here we have this nice background, and yeah, the text has changed as well. So how do we know inside of each friend if it is currently selected? Well, first of all, we will have to pass in the currently selected friend. And so then we can compare that with each friend. So with the friend itself. But that's easier to understand in code. So, as I said, let's come here into the app and let's pass the currently selected friend in as well. So selected friend equals selected friend. And now as we save, Prettier puts each of these props into its own line. So this makes it a lot easier to see what's going on here. But anyway, the friends list now receives the selected friend. So let's add that here. And then once again, we don't need that directly here in the list, but we will need it inside the friend. So we just pass that through here. Selected friend equals selected friend. And by the way, whenever this happens, so whenever we have a component that doesn't actually need the prop, but all it does with the prop is to pass it down into one of its children, we say that we are prop drilling. So in this case, that's not a big problem, but sometimes we need to pass some prop through like 5 or 6 levels. And so then it becomes really problematic, and we then need to solve that problem. But here, that's no issue. I just wanted to already prepare you for what's ahead, basically. So at some point, we will talk about that in detail. But anyway, now here we can compare that selected friend with the current friend, basically. So let's say is selected. And so here we want a Boolean. And so we can simply do selected friend dot id equal to friend dot id. And that's it. So now we can use this to conditionally define a class name here. And here, let's now use JavaScript mode again so that we can say is selected, then add the class of selected, and if not, then no class at all. All right, and you see, well, actually, you don't see. This is the demo app, but you see it here. So this already got now the nice background color. And if we select this one, then it changes here to this other friend. And so that's simply because this ID here of this friend is now exactly the same ID of the one that we have selected. And now all we need to do is to change that text there for closing. And so that's down here. So is selected, and if so, it should be close, and otherwise select. And yeah, there it is. Great. So that's working, but what's not working is that when we click here again, is that this is not closed. And that makes sense because nowhere we are saying that when we click here again, that the state should be back to null. And so that's what we need to do next. So here where we handle the selection, basically when there is already a friend selected, so which means that this here is open, then when we click here again, we want to change the selected friend back to null. So back to the initial state, basically. And so here now we need to do something else. Let's just comment it out. And so now this will actually depend on the current state. So let's just call this the selected. So the currently selected here in this callback is just called selected so that we don't have to write so much. Then here we can say if the selected.id is equal the friend.id that we're passing in, then let's set it back to null. And otherwise, then set it to the passed in friend. All right, so whenever the currently selected, let's actually change this here to cur, which stands for current. So if the currently selected.id is equal to the friend.id, so the friend that is passed in, then that means that it is actually open. So that right now the form is being displayed. So in that case, we want to actually close it. And so then we set it back to null. Right? So let's try that. And, well, we got a bug. So let's see what that is. And yes, this is what I was expecting. So we cannot read the properties of null right here in the friend. So right here. And so that is because right now the selected friend is null, isn't it? And so on null, we do not have the ID property. And so therefore, then this breaks. But fortunately for us, in modern JavaScript, we have optional chaining. And so this is very easy to solve. And if you're not familiar with the syntax, then just go back to the section where I review essential JavaScript. Now here, this friend will always exist. And so here we don't need optional chaining. So we will never run into problems there. But let's do the same up here as well. Because again, the currently selected does not always exist. I mean, sometimes it's null, and then this doesn't work. Okay, so we select it, then we select this, and if I click again, which is what we just implemented, then beautiful. The form disappeared, we have no bugs here, and everything is back to normal. Great. And now, just to finish, let's handle one small edge case. So let's say that we decided to add a friend, but then for some reason we don't. We're not interested anymore in this. And then we click here to open up this form. So then we have both of them open at the same time, which looks a bit weird. And so let's automatically close this form here whenever we open this one. And so this will then again show you the huge power of state. So all we need is one line of code right here where we handle this click. So all we have to do here in handle selection is to select the friend first, and then we set show at friend always to false. So let's reload that. So I open the form, then I select Anthony, and so that closes this one and opens the one that we're interested in. Great. And with this, we are now ready to actually make this form here dynamic right in the next video. The next step to making our form work is to take the input elements that we already have and make them controlled elements. So elements that are entirely controlled by React components. And since we already know how that works, as we have done it so many times already, let's get right to it. So the first one is for the bill itself. So set bill, and we use state with an empty string. And we are using an empty string because these are input text elements. And so this is how it needs to work. Next up, we have one for the expense paid by the user. So let's call this one paid by user, and then set paid by user, use state, again empty, and then also one for the select here. So const who is paying and set who is paying. Use state, and here we start with the default of user, which is one of the values that we have here in our two options, right? Now it would be a bit more elegant to use a true false value here. For example, we could call it is paid by user, and then that could be either true or false. But that's a little bit difficult to implement with the values coming from here. So we can't really pass true or false here. That doesn't really work. So we just do it like this. Okay, and now once again, we will wire everything up. So I will do it here as fast as I can. And you could even pause the video if you wanted. And just do it yourself. So e.target.value. Okay, and now why not just copy and paste this here? So value is now paid by user, and then set paid by user, and the same thing, well, not here, but here. So here it's who is paying, and then set who is paying. All right. So let's write something here. And then we should see it here in our component tree that the state is exactly what we expected. Or actually, we should convert these two here to numbers. So let's select this one and actually also the next one. So we can do everything at the same time. And if I then reload here, then, yeah. Oh, well, only this one has been converted. And, oh, okay. I did a mistake here. So, just to see that it's normal that this happens. So I selected the wrong one there. So let's try that one more time, because of course this is really important that we get numbers here and not strings. And yeah, that's correct. And if I select this one, then it is the friend. But now what about this one here? So why is there no value here? Well, here we actually don't need a state because we cannot write anything here into this field. Also, this expense of the friend can actually easily be computed from the bill value minus the expense of the user himself. So that sounds like derived state, right? And I'm placing it right here after paid by user, just so they are in the same order as in the UI. So paid by friend is simply the bill value minus what has been paid by user. But actually we should be careful with this because in the beginning the bill is just a string. So this doesn't really work. So let's first ask if there is a bill. Well, then the result of the operation should be this. And if not, then let's also make it an empty string. And now we just need to go down here and use it. Well, right here. So here we will only specify the value, but not the handler. So paid by friend. And nice, there is our 150. And if we change this, let's say to 150, then of course each time that the state is updated, so each time that we write something new, the state is updated and then the component re-renders. So this function will get executed again, and then this derived state, so this variable here, will be reset as well. So it will take these values here again, calculate its thing, and then store the value in this variable. So then that gets displayed here. But now there's just one problem with this, because let's say we write 1500. So that's not really correct, because then here Clark's expense is negative. So basically we need to ensure that our expense is at most equal to the bill value itself, but never greater than it. So let's come down here and do that right here. So we could actually extract this into its own function, but let's just do it all in line here. So we have the number here, so the paid value basically. Let's copy this because we will need it again. But for now, let's test if this value is greater than the bill. So if it is, then we basically don't want to change the state. So we can just use then the current paid by user again. But otherwise, then we actually want the new state to become, well, what we have written there. So that's e.target.value. Okay, so again, we check in the new value that has been written into the field and we compare it with the bill. And if it's larger than the bill, then we will just basically reset the value here to paid by user, which is already the value that was in there before. But if not, so if it's a valid value, then we just use it here. So this will then become the new state. And so now, let's just quickly reload here. Let's say 200. And so now, as I type some other number here, you cannot see it, but I'm typing it, then this value here is not updated. Great. So we converted our form here into a basically controlled form where all the elements are now controlled elements. So what we need to do next is to add the logic of actually splitting the bill and then updating the balance between the two friends. So updating the value that we can see right here. Now that's a bit more work, and so let's actually leave that for the next video. But before we go there, I actually want to quickly show you what happens when we click on one of these other friends. So let's click here, and you see that the state has not been reset, right? So the state that we had here before is exactly the same when we click on other friends. Now, with the knowledge we have at this point, we are not yet ready to fix this and also not really ready to understand it. All I can say for now is that this happens because this component is rendered in exactly the same place in the component tree as before. I mean, when I click here again, then the same component is rendered again in exactly the same position. So the component doesn't disappear in the meantime. And so therefore, it is not really re-rendered. And so that means that the state then stays the same. Of course, if I close this and select the same friend again, then since the component has disappeared and then appeared again, then the state is reset. But again, if I do this and select another one, then the component doesn't really completely re-render, at least not the state in it. So the state is not reset in this case. But don't worry about that for now, as we will fix this later once we have a bit more knowledge about some deep fundamental things that happen inside React. All right, so just wanted to show you this, but now let's move on to the next video and actually finish up this project. Welcome to the last video in this section where we will now finish up the application that we have been building. So in the last lecture, we already made all our elements here controlled elements. And so now all we have to do is to listen for the submit event here on this form and then handle it accordingly. So that's easy enough. It's always in the same way. So on submit, then typically we write a handle submit function right here. So function handle submit, which will receive the event. And then, as always, we need to do prevent default. All right, and let's start by adding some guard clauses here. So basically preventing this form from being submitted if there is no bill or if there is no value paid by the user. So in this case, just return and do nothing. Okay, but if there is a bill or a value paid for the user, well then, now it's time to actually split the bill. Now in practice, that means basically that the balance of the user in question will be updated. So of the friend here in question, I mean. So whenever we split a bill, it means that this value right here will be updated, right? So something is clearly happening on the screen. However, does that mean that we now need a new piece of state? Well, actually no, because we already have these friends here in our state, and all we're doing is to update them, right? So basically, all we will do is to update this balance value that is displayed here. So let's come again to the component where that state is living. So this state right here, and then let's write yet another handler function. So function handle split bill. And this one will simply receive a value. So in this case, there is no need to pass in the entire friend because we already know which friend is going to be updated. And so that's exactly the current friend, right? But for now, let's actually just log this value here to the console. So we will take care of this more complex updating logic at the end. So for now, let's just pass this handle function here into the component. So right into this component here. So on split bill will be handled by handle split bill. Okay. Then let's come down here again. And let's then receive on split bill. And then finally, we can use that here in order to update the state. Well, for now, we will only log something to the console, but we will take care of updating in a minute. For now, we first need to figure out exactly with which value we will update the friend's balance. And this is actually the most confusing part of this whole application. Even more confusing than all the React stuff itself. So remember that the bill can basically be paid either by you, so the user, or by the friend. And so based on that, we now need to set a value. So we will use the ternary operator here for that. And so we say who is paying is equal to the user, which is basically you. So remember that negative numbers in the balance are owned by you, so by the user. And positive numbers means that your friend is owing you. Therefore, if this here is the situation, so if you are paying, then they will be owing you their part. And so therefore, this is a positive number. So the value here will be paid by friend. And in the opposite case, so if your friend is paying, then you will actually own your part. So the paid by user part. And it's going to be a negative value. Again, because the negative values are the ones owned by you. So minus paid by user. And so then inside this function here later, we will add that value that we just returned here onto the balance. So once we're done with all that, I promise this will be a lot easier to understand. But anyway, let's now come here to our console. Let's just quickly reload here, and then let's just try any of these. So let's say the bill is 200 euros, and your part is 50, and Sarah's part is 150, and you are paying the bill. And so the result is then a positive 150, which will be added on top of the balance. So it's plus 150 because it's your friend who is owing you. And so, yeah, those are the positive numbers. If we change this here to Sarah, then it will become minus 50. So that is your part, which you are then owing to your friend. And so then it becomes minus and your part. So minus 50. All right. So our function here is now receiving that value. And so now let's update our friends state. So set friends. And once again, the new array that we will return here will be based on the current friends array. And so here we need that callback. And then what we're going to do is friends.map, because we want to return a new array with the exact same length as the current one. So that's how we always do it when we update an object in an array. So we have done that many, many times before. And so if the code I'm going to write next is a bit strange to you, then just feel free to go back to one of those lectures. But anyway, let's now loop actually over this array in which each of the objects is of course a friend. And so let's then update the friend whenever the current friend.id is equal to the selected friend.id. And so here's what I mentioned earlier, which is that we already know which of the friends is getting updated, right? Because we already hold that in the state. So if this is the case, so if the current friend is the one that we want to update, then, well, here we are going to return an object which will contain all the elements, so all the properties of the current friend, but we want to override the balance property. And we will override it with friend.balance, so the current value plus the value that we received. And that's it. So I just saved here by accident, and so immediately we get an error because we're missing the second part of the ternary operator. So here in the second branch of the ternary operator, in case that the current friend is not the one that we want to update, we simply return that friend unchanged. And with this, we should now have a working application. So let's again use the values that we already know, so that we used before. And let's actually still log the value here to console, just so we can better understand what is happening here. All right. So remember that before Sarah was owing us 20 euros. And so now see what happens. Now she owes us 170. So that's the 150 that we got now on top of the 20 euros that she was already owing us before. And again, that's because I am paying the entire bill here. So it's like I'm lending her. So I'm paying her 150 euros, which is her expense. So her part of the bill. So if we had now a 100 euro bill where my expense is 90 and then she pays it, then she pays my 90 part of the bill. And so then this should become here 100 and, or actually it should become 80. So let's wait for it. And indeed, now it's 80. And the same logic can be applied here. We just need to now reset these values here. So let's say we have a bill of 20. And since Clark is owing me 7, or actually you owe Clark those 7 euros, let's now use that here. So here I'm using 13 so that Clark's expense is 0. And then if I pay, we should be even after this. And indeed, now we are even. Great. So this can be a bit confusing, but this is also not really what matters. What matters is all the knowledge, or at least all the practice that we just gained from building this amazing project. There's just one small thing missing, which is that here the state is not clearing. So we have two options now. It's to clear the state here in the form, but even better, and which is what I actually do here, is after this is done, so after the bill is split, it will automatically close the form again. And so that's very easy to do, right? Let's just get rid of this. And then here, thanks to the power of state, once again, we can just say set the selected friend to null. And that's going to be it. So once again, very, very easy to do with the power of state. Imagine doing this kind of stuff with vanilla JavaScript. you would probably become crazy at some point. So with this, it's super straightforward. Let's just reload here. Now let's use Anthony here. Let's say 150. Our part was like this, and it doesn't really matter. But as I click here, you see that the form disappeared, and this value here, of course, has changed. Great. And with this, our application is feature complete, and you just added one more small React app to your portfolio. So very, very well done. You're doing great progress here. Now, in order to become even better, as we finish this first part of the course, it's very, very important that you build a lot of similar and small projects just like this one. So it can be something like a shopping list, or a simple goal tracker, or something like a conference speaker list where users can select which talks they want to go to. So just some small app like this. It doesn't have to be super fancy or original, of course. All that matters is that you practice the skills by writing the code without following a tutorial. So without following anyone writing the code for you. So I really advise you to not move on to part 2 before having built something small completely on your own. And then, once you are done with that, no matter how long that takes, I hope to see you very soon in that part 2 of this course. Congratulations on finishing part 1. Now, instead of moving on to part 2 right away, it's essential that you go explore the fundamentals that you just learned on your own. So you really need to build a few small projects yourself and try out a few different things. So this self-learning is a crucial part of your journey, and now is the perfect time to do so. But then, once you feel quite comfortable with the basics, a lot of new and interesting topics await you here in this part 2. So, over the next few sections, you'll learn how React actually works behind the scenes and build this really nice Use Popcorn project. This application will teach you all about building UIs and layouts, setting up effects, fetching data, creating custom hooks, and so much more. So things are about to become a lot more real world, and I'm really excited to show it all to you right now. It's time to set up our next project. So we're building a lot of projects here, which is exactly what you need to become the React developer that you want to be. And by now you already know the drill. So just fire up your terminal or your command prompt if you are on Windows, and then simply navigate to the folder that you want to build your next project in. Then type npx create react app at version number 5, please, and then the name of the app, which is Use Popcorn. So, what might that be? That's a bit of a strange name. So, let's actually check it out right now. So, this is the Use Popcorn app, and if you want, you can go explore it right now on your own at usepopcorn.netlify.app. So, it's called Use Popcorn because this application is all about movies. And maybe you see that this prefix here of the name is this keyword of use, and that reminds you maybe of the use state name. So the name of the use state hook. And so that's because we will build this project over this section and even 2 other sections, and it is going to be all about hooks, basically. And so that's a hint to that here right in the name. But anyway, here in the search bar, we can now search for movies. So let's say one of my all-time favorite movies called Inception, and this is now loading these movies here from a real API. So we're doing some real data fetching here. Then we can click on any of these movies, which will then take us to this display overview here. Then we can rate the movie. So you see that we have this nice rating component, and this one is definitely a 10. Then it asks us if we want to add the movie to our watch list, and as we say yes, then you see that the movie has indeed been added to our watch list here. Let's say we also saw this one here, maybe it was a 7, then let's also add it to our list, and you see now we have both of them, and up here we have some statistics about our watch list. We can also delete movies from here, so maybe later I remembered that I didn't actually watch this one, so let's get rid of it. And yeah, so another thing is that when we click here on a movie that we already rated before, then you see that here it no longer displays that rating component, but our actual rating. Then we can always go back by clicking here, or we can also just hit the escape key. So that also works. So that's another small feature right there. And yeah, that's actually it. So a very small application, but again with real data fetching. So that's going to be something really nice that we're going to do for the first time. So this app here might feel already a little bit more real because of that. Now, as I said, we will build this throughout 3 sections. And so in this first section, we will only work with static data yet. So this list of movies here is not yet coming from an API. It's just an array of objects as we have been working with before. The only thing that works here already is at the state here. So we can like collapse these 2 lists here. And we can also already write something here into this search bar. But besides that, in this section, we are more concerned about the component part. So basically creating this layout that we see here, and also talking a bit about component reusability and component composition. And with that being said, let's actually move on to the next lecture where we will learn a bit more about how to think about components. So we're back in a section about thinking in React, which is all about state, data flow, and components. We already talked about state management in detail, and so now it's time to talk more about components. Now, when it comes to components, the important questions that we need to ask ourselves are: how do we split up a UI into components? And when should we actually create new components? So let's try to answer these questions in this video. And one way in which we can start answering those questions is by looking at component size. So we can classify every component based on its size, which means that we can place every component on this axis of component size. On one side, we have really small components, and on the other extreme, we have huge components. And many times, none of these extremes are ideal. So imagine that we wanted to build this simple card. One way of doing it would be to create just one huge component for the entire card. However, that would create a whole set of problems. First, there is way too much stuff going on in this component, so it has way too many responsibilities. So components are just like JavaScript functions, in the sense that if a function does too many different things, we should break it up into multiple functions. And so the same applies to React components. Now, another way in which it becomes apparent that a component is too large is when it needs to receive too many props in order to work properly. So, for example, if we need like 10 or 15 props to properly configure a certain component, that component is probably way too big and should be split up. So, in general, these 2 problems make it very hard to reuse the component, which is one of the big advantages of components in the first place. Also, huge components generally contain a lot of code that might be complex and intertwined, which ultimately makes the whole component hard to understand and to use. Now, does this mean that we should do the opposite and create many small components like this one? Well, most of the time, that would probably be a terrible idea as well. If we would build a UI or an entire app in this way, we would end up with hundreds, if not thousands, of mini components. This, of course, would create a codebase that is super confusing to navigate and to understand, and it would be way too abstracted. And if you're not familiar with the term abstraction, in programming, it basically means to create something new in order to hide the implementation details of that thing. For example, when we create a button component, the user of that component might have no idea how the button actually does what it does, because the implementation details are hidden behind this abstraction, so behind this component. So in a way, each new component that we create is an abstraction. Now, if both ends of the spectrum, so both really small and huge components have these problems, then what should we do? Well, most of the time, the goal is to create components that strike the right balance between being too specific and too broad. Or in other words, between being too small and being too big. Now, these problems that we identified here, like components having too many responsibilities and being hard to reuse, can help us understand how we should actually split a UI into components. So, using the same example as before, first we had this with just one huge component, and then we had a lot of small components. And both these ways of splitting up the UI are far from ideal, for all the reasons that we have talked about. So instead, what we want is something like this. So here we have a more logical separation of the content into different components, and some of these components are probably even going to be reusable, like the heart button or the superhost label. Also, each of these components has a well-defined responsibility, like displaying the price or the rating, and they're also not overly complex. Okay, and so from this, we can now derive a couple of criteria that we can use to split a user interface into components. First, when we decide which components we need to implement a certain UI, it's important that these components create a logical separation of the content or even of the layout of a page. We should also strive to make some of these components reusable and ensure that each component has a single, well-defined responsibility. Finally, there's one even more subjective criterion, which is your personal coding style. So some people work better with smaller components, and some people just prefer larger components. And therefore, you need to create components in a way that works best for you, so that you can stay as productive as possible. Alright, but now let's actually dig a bit deeper into all these different criteria. So what I want to do in this slide is to give you something like a framework that will help you create new components from bigger components. So the idea is that when you're creating a new component and you're in doubt about what the component should include, just start with a relatively big component, but not a huge component, and then split that bigger component into smaller components as it becomes necessary. But naturally, you will now ask, when does it actually become necessary to split big components into multiple small ones? Well, that's where the 4 criteria come into play again. So logical separation of content, reusability, the responsibilities and complexity of the component, and your personal coding style. Now, of course, if you already know that you need a small and reusable component, such as a button, you can just skip all this and simply create a component. But otherwise, you can just start big and don't need to focus on reusability and complexity at the very beginning. At some point, however, you do need to worry about these topics. And so let's analyze them one by one, starting with logical separation. So if after writing your big component, you feel like the component contains some piece of code or of the layout that don't really belong together, then that means that it's probably a good idea to create a new component. Now, about reusability, if it's possible to reuse a part of your big component, And if you actually want or need to reuse that part, then you should take that code and extract it into a new component. Another sign that you should probably extract part of your component into a new one is that your component is doing way too many different things, or that it's relying on too many props. So if your big component has too many pieces of state or effects, or if the code is way too complex or too confusing, it might be, once again, time to create a new, smaller component. And finally, as I said in the previous slide, it's important that you feel productive when working with your components. So if you prefer smaller functions or components, just split up big components into smaller ones. But on the other hand, if you prefer big components, that's also totally fine. It's all up to you. Because remember, in the end, these are all just guidelines and best practices that will become intuitive over time. And by then, building your components will become second nature to you. But as you start out right now, it's great to have guidelines like these to help you out. And speaking of guidelines, I actually have a few more general guidelines for you. So first off, you need to be aware that creating a new component creates a new abstraction. And we talked about abstractions a bit earlier in this lecture, right? Now, abstractions have a cost, because having more abstractions requires more mental energy to think about different components and to switch back and forth between components. So try not to create new components too early if you can avoid it. Next, it's important that you name a component according to what it does or what it displays. And don't be afraid of using long component names. That's completely normal in React development. Now, what's even more important is that you never ever declare a new component inside another component. And we will learn the reason for that in the next section. What you can do instead when you have some related components is to co-locate these related components inside the same file. Finally, and going back to our initial topic of component size, it's completely normal that an application has components of many different sizes, including some very small ones and some huge ones. So even though we said in the beginning that very small components have some problems, of course we always need some small components like these in any application, because they're highly reusable and have very low complexity, which is sometimes exactly what we need. Most apps will also have a few huge components that are not meant to be reused. For example, we might have a huge page component which contains the layout of the entire app or a page. And that might very well be a fairly complex component, which is not meant to be reused. So in situations like this, don't worry about reusability or about needing to split this component up. And speaking of reusability, as you can see from this, we can say that, as a general rule, the reusability range is pretty similar to the size range. So, generally speaking, the smaller components are, the more reusable they will be. And of course, as components get bigger, they will become less reusable. But again, that's no problem at all for some components. So not all components are meant to be reusable. But anyway, finally, we have all these medium-sized components as well, which all have different degrees of size, reusability, responsibility, and complexity. So in the end, our application will have many different components across the entire spectrum, and that's completely normal and natural. And now let's go back to coding and break up a huge component into many small ones, using all the concepts that we have just learned about. So let's now split one huge component into many small ones using the framework that we just learned about. Now, as always, to start, we need to get our starter files here from this folder. So let's grab these two, and then let's move back to our project folder. And as always, I'm renaming it, and then let's paste the new files right in here into the source folder. And then we need to replace these and just get rid of some of this garbage that we have here. All right, so as always, we just end up with index.js, index.css, and app.js. Then we just grab all this and open it in VS Code as always. Close down this one. And yeah, then we need to clean up this file here. And so this is always a little bit of tedious work, but we just have to do it. And actually that's already done. You can take a look here at the CSS if you'd like, because there's actually a lot of it to make this application here work. So to style that application. But what matters most to us is, of course, this app.js. So here we have this array of objects that I talked about in the previous lecture. Here then we have another array of objects, which is for this watched list. And then here we have that huge component that I was talking about. So it has all this JSX inside. So basically all of this, the entire application is now inside of one component. To prove that to you, let's actually start this application here, because this one here is of course still the demo. So let's open up our integrated terminal. That's slightly too big. And then npm start. So that should then open up a new tab in here. And there it is. So make this even smaller. And yeah, so there is the app. And as I was saying in the first lecture, it does work here in terms of collapsing these two lists, also writing something in here. So all of that is working, and it's all working within this one huge component. And so I thought that it was a nice exercise to basically pretend that we're working on some team and that one of our team members created this huge component. And now it's our task to take it and split it up into small components that make it easy to work with and, well, which isn't this huge mess. So let's use the framework that we learned about in the previous lecture to do that. So let's take a look at our JSX here. And if you want, you can of course pause the video and do that on your own, because there is a lot to unpack here. So we have this nav bar here. So this entire thing here is this nav element. And then we have this main part, which is all of this. Then inside the nav, we have this box here for this left side, which contains this list. And then we have another box on the right side, which contains all of this. But we will take care of that later. So for now, let's basically split up all of this here into the nav bar and into this main part. So I think to start, that's the best logical separation of the content, which is, remember, the first criteria that we talked about. So those were logical separation of content, second, reusability, third, responsibilities and complexity, and fourth, the personal coding style. So this navbar here and the main content here, they really don't belong together. And so that's a good idea then to create a component for each of them. So I'm cutting this code here, and I will actually now create these components here on top. Otherwise, I have to scroll too much. So let's write function navbar and then return simply this. Give it a save, and now it's complaining here. So we now need to also move this state here into this other component. So this one here is depending on query and set query, and so therefore we need to move that state right there. And so actually having all the state here was another great indicator that this component here had way too many responsibilities. So we have 5 pieces of state, and then these 3 derived states. So that's way too much. So let's just cut this here, paste that here. And here we also need the movies, but I'll for now just replace this here with an X. Okay, so now the navbar is gone because of course we haven't yet included it here. And so let's do that. And now our app looks just like before. And so now let's then grab all this other code, all of this, cut it, and put it into yet another component. And this one, let's actually call it main. And as we save it, it will now complain that it needs all of these states here. So for now, let's just grab everything and paste that here. All right. And then, well, we just had the app should look just like before. Well, for some reason it isn't, but let's see that in a minute. For now, I will just take this component here actually back to the top. So just here. Now let's open up our console. Maybe we have some errors here that we're not catching, but well, actually no. But I think I know. And the reason is that here we are not returning. So we were not returning any JSX. And so then, of course, we couldn't have any JSX here in the UI. Great. So let's keep going and let's look again at our navbar. So our navbar is now a lot simpler than before, but it's still doing a lot of different things here, I would say. So we are displaying a logo, we have this input field, and we have the number of results here. Now, in a way, all of this does actually belong together because, well, together they form this navbar. So we could definitely argue that this is okay like this. But on the other hand, it still takes some work to actually figure out what this component here is doing. And maybe we even might want to reuse some parts of it. So for example, this search bar, which is basically this, we might want to reuse it all over the place in the application, at least if the app grew a bit bigger in the future. And so let's at least grab this part here and extract it into its own component. So I'm cutting that. And then let's create a function simply called search. Then return that JSX. And of course, we will then need this state. And we will want to include that here. Give it a save. And then it looks exactly like before. Okay. But now something happened here that I personally really don't like, which is to have one piece of JSX which mixes like these native HTML elements with our custom components. So we have this div, we have this p, but then in the middle we have like our own search. So that I think looks really ugly, and I really don't like that. I think it's quite confusing. And so let's actually also extract the logo and the num results. And so then we make this component here really nice and clean and end up with these 3 components here where each of them has its own responsibility. So let's create the logo. So we will end up here with a few small and reusable components if we'd like. So we have our logo and then let's say num results. Function num results. All right, this doesn't look quite correct. And yeah, now all we have to do is to include them here. And then num results. And this looks a lot nicer. So as soon as we look at our navbar component, we can immediately see, it contains a logo, a search, and the num results. And from there, if we were interested, we could then really drill down into each of these components if we needed to. And of course, if we wanted, we could even keep going. So we could now create like one component here for the icon and one for the title, so to say. But that would then be that situation in which we would end up with like hundreds of mini components, which really isn't worth it. So this is more than enough. This logo is doing just one thing. So it has one responsibility already, which is basically to display this logo, which is all this. So there's absolutely no need to break it down even further. So this is perfect like this. So the navbar is now finished, and we are ready to break up the main component, of course, a lot more as well. So looking at our first criterion, which is the logical separation of content, we clearly have no clear separation right now. So we have one component that has all of this. And so the first visual division that I would make here is to create one component for this box and one for the right one here. And so let's do just that. Take this box. And then let's move down here and create the list box. All right, and I'm calling it the list box. And now we can see. So again, I'm calling this component here the list box because in there is where we will have this list of movies here. So let's now grab the state that is missing here. So set open 1 and the movies. So cutting that from here and placing it here. All right. Now, of course, when you build your own apps in the future, then you will not build one huge component like this. This is just an exercise so that we can apply what we learned before. But again, never build such a huge component like this, because there's really no need to then have all the work of splitting that huge component up like we are doing right now. But I think that, yeah, for learning, this is fun and absolutely no problem. So let's grab this other box as well and place it into the watched box. So function watched box. All right. Let's grab all the state that we need here. And let's also already include both the boxes here. So that's the list box and the watched box. So basically exactly the code that we had here before, now split up into these two components. Placing the state there, and it's not appearing, but that's because, once again, I forgot to return here. Nice. So let's keep going, because I still think that this is way too big. So just looking at this code, it looks quite confusing. You cannot immediately understand what this component here is doing. It has like this button here, which does something, and then we have all of this code down here. And so now what I want to do is to extract this code here into its own list component, which will then have only one responsibility, which is to simply display, well, the list of movies. So let's grab this, cut it from here, and place it right here. So movie list. And I keep forgetting to return. And then here we also need that movies state. And yeah, here then all we need to do is to include that movie list. Nice. And this is still working. Yes, and so we're doing a great job here. So this component is now a lot easier to understand here, if you ask me. So we have one button, and then if that button is open, we show the movie list. Nice. So getting better and better. And I just want to mention that in the real world, we would probably have one file for each of these components. So something I said already many times ago, or many times before, but I still wanted to just mention that here. So we now have this movie list component right here. And for many people, this would now be enough. But if it comes down to my personal coding style or my personal preference, I would actually like to still extract this list element here into its own movie. And we have actually done that many times before already in this application, where we had one component for the list, which would then simply loop over some array and then display one component for each element. And so now I will do exactly the same here. So again, this is now a bit more of my personal preference, but I think that it's actually quite a sensible thing to do, because then here we have the mapping over the array here isolated in this one component, and have then one component which is really only about the movie and nothing else. And again, keep forgetting to return here. And yeah, let's then use that movie here. And what will happen is that we will pass the current movie, so this one here that's coming from the map, as a prop into that component. We will also need this key, no longer here, but now here, and finally accept that prop right here. We give it a save, we have no error, and so let's keep going. So I think we are quite finished here with this left part, and so let's go over here. Now here we can already see that it's a bit more complex, because here we have not only the list, but also like this summary of the list. But let's see what we actually have there. So it's inside this watched box. And of course, we can also start seeing our components tree right here, which is always nice. So I always like to do that, actually. And so it's coming together here quite nicely. Maybe it doesn't even have to be this big, then we can see a bit better. And so, yeah, this is exactly what we have been building. And now all we have to do is to also break up this watched box a bit better. So let's take care of that. And first up, I will do that division that I just mentioned earlier. So we have this list here and also this summary. So let's grab that summary here. And so that's basically this div with the class name of summary. So I'm cutting that. And then let's just create function watched summary. And then returning this. So now this code here actually depends on a few things. So all of these variables. So let's see what they are. So that's these variables right here plus the watched. Now we could pass all of these three here individually, or actually the four of them. So watched plus these three here. So we could pass them into the watched box component that we just created. But actually, if we take a look at them, all of them simply depend on the watched state. And so what we're going to do is to grab this and pass this watched list, so that array, right here as a prop. Okay, moving there, pasting that here. And of course, we need to accept that prop then here. And now React is happy again. So again, what we did is that these three pieces here are derived state, and they are derived from this watched array right here. And so we simply passed the watched array into this component, and then, yeah, just moved these three here, of course, also into this component. And so we did that instead of leaving this here in the parent component and passing all of them one by one. But this code here clearly belongs in this component. So it's clearly part of the responsibility of watched summary to calculate its own statistics. And if all it needs to do that is this watched array, well, then we are happy to provide it with exactly that array. But moving on, let's now create another list, which is here for this watched. So this watched movies list. So cut that as well. So let's call this one here the watch list. And of course, we could have also called it the watched movie list. And let's actually do that. So remember how I said that we should not be afraid of long component names. And so I think that this is a bit better actually. Now here we will need that watched array, so that piece of state that we have up here. Right, but let's first give it a save and then see that error. And, well, nothing really happened here. Well, first of all, we have a bug here, and it's a big one, which is that we are here including the same component inside itself. So we are including watched box inside watched box. So this was by mistake. Probably you have noticed this as I was typing. So here, of course, it needs to be the watched summary, which is the component that we were talking about before. But still, nothing is happening. So let's try to reload here. But now we have like this infinite loop. So maybe we have some errors, but yeah, I think the best thing to do is to actually quit the application altogether and then just try to restart. So let's wait for it. And yeah, let's close the old one. And now we get that error that we had before. So before I fix that, or actually let's pass it in already here, but I still wanted to say that it's really, really important that you do not call the component inside of itself. So again, I was calling watched box in here, and so the problem was that this then created an infinite loop of the component calling itself. And so that's why when I was reloading the application, React here wasn't really reacting. So the application wasn't really able to then render itself. And again, because of that infinite loop. So never do what I just did here by mistake. But anyway, we now passed the watched array here into this watched movies list. And so here we just need to receive that, give it a save, and then we are back to normal. Let's quickly get our console back. And yeah, so this is the list that we have. And now just one more component where, just like before, I will extract the list item into its own component. So grabbing all of this, let's create the watched movie. Here we already know that we need to accept the movie. And here, remember, it's very important that we place the prop name into these curly braces, because we are, in fact, just destructuring the props object. Right? And so then here, all we have to do is to write watched movie, pass in the movie prop. And yeah, we also need this key right here. And with this, we should be done. And we are indeed. So the app works and looks just like before. But we now divided this application into its logical components. So components that have a logical separation of the content, that might be reusable, and that have the right number of. Now that we have created a few different components, let's quickly talk about different component categories that naturally emerge in most React code bases. So most of your components will naturally fall into one of three categories: stateless or presentational components, stateful components, or structural components. And I say naturally because we shouldn't force our components into one of these categories. Now, these are all still normal React components in our code, so just like the ones that we have been writing, but we can categorize them in this way when we think about components. There are also other categories that could be used, but I think that these make the most sense. So, starting with stateless or presentational components, as the name says, these don't have any state. Usually, they are components that receive some props, and then they simply present that data or even some other content, and therefore the name presentational. Many times these are quite small components, such as the logo, num results, and movie components in our current app. Next, stateful components are simply components that do have state. Now, just because these components have state, that doesn't mean that they can't be highly reusable. For example, the search component that we built does have state, and we could reuse this input as many times as we wanted throughout the app. Now, finally, you can think of structural components as pages, layouts, or screens of the application, which are oftentimes the result of composing many smaller components together. And more about composition later in this section. So, these structural components can be large and non-reusable components, but they don't have to. Structural components are sometimes quite small too. What matters is that they are responsible for providing some sort of structure to applications, such as pages or layouts. Therefore, these components might not be present in really small apps, but you will definitely have a few structural components as your app grows bigger and bigger. Now, we left a small problem in one of the components that we just created earlier. And so let's now go fix that problem and, in the process, discover the problem of prop drilling. But before we go do that, I just want to very quickly review the previous lecture by classifying each of our components into one of the categories that we just looked at. So I think that clearly both the app and the navbar component here are structural components. So they're only responsible for the structure or for the layout of the application. And the same can also be said of this main component here. So those are for providing structure. Then the logo here is clearly a presentational component, so it doesn't have any state, and so therefore it's stateless, and it simply presents some content here. Then the search is of course a stateful component. Then num results is just a presentational component here. Main we already talked about. Then we have the list box, which clearly is a stateful component. And the same for the movie list and for the watched box. So those are all stateful components, while the movie simply receives this prop right here and then presents that data in the user interface. And so movie here is just a stateless or presentational component. Then we have this one here, which is also a presentational component. And the same for this one. So watched movies list and watched movie. All right, and that's actually it. I just wanted to quickly categorize each of them. But now let's move on to that problem that I mentioned in the very beginning. And that is that right now, here we are not dynamically calculating the number of results. So we are not basically taking the list of movies and reading how many there are and then displaying it here. So that's what we want to do. But yeah, now we only have this X. So what we need basically is to get access to the movies state right here in num results. Now, where does that state live right now? Well, it's here inside of movies list. So right here. So again, it's here, but we also need it here in num results. So what's the solution to that? And I really hope you already know at this point. Well, the solution is to lift the state up to the closest parent component. And what parent is that? Well, it's the app component, right? So it's not the navbar, because of course that's not a parent of movie list, and so it is really the app component. So what we need to do is to cut this from here and place it right back into the app component. All right, and now we need to pass it down as a prop to where we need it. And so this is where the problem of prop drilling will come into play. So again, we need now this state in order to make this work again inside of the movie list. But this movie list is really deeply nested inside this component tree, right? So it has these two parent components, which now will also need to receive that state as a prop. But instead of talking, let's actually do this. So movies equals movies. So now we have the movies array inside main. So let's go there. And we need to receive it here. And then we need to pass it here right into the watched box, or actually into the list box. So movies equal movies. Or actually here, yeah, it's not main, of course, it's movies. Okay, so now we got it inside the main, and now we got it inside the list box. So let's come here and do it all again. So accepting it here, and then passing it here. So movies equal movies. And so what we are doing right now is what we call prop drilling. So now we finally accept it here, and then it works again. So basically prop drilling means that we need to pass some prop through several nested child components in order to get that data into some deeply nested component, which in this case is this one. So we had to pass this movies prop here first into the main, then, well, from the main into the list box, and then from the list box into the movie list. And so all these components, they didn't actually even need this prop. All they needed this for was to then pass it down even further the tree. And so we end up with a lot of props that are really not needed at all. All they are needed for is to pass the data down even further into our component tree. So this is what prop drilling is. And you saw that it is not a lot of fun, and it could be even worse, of course, if the data was nested even deeper into the tree. So this was just like 3 levels deep, but it could be like 5 or 10 levels. And so then it would become a little bit out of control. So we will look at ways of fixing prop drilling a bit later in this section, but for now, let's finally also make this prop, so this movies data, available right here where we also need it. So right here. So movies equal movies. And so now we have to do some prop drilling again, because here we need to again accept this prop, but we don't need it here. All we need it for is to pass it down again. But here it's not so bad because it's really just one level. Okay, and now finally movies dot length. And so, ta-da, we got 3 results. Nice. So this works, and what we just did here is a perfectly valid solution to make the application work, of course. But as I mentioned, what we did was some so-called prop drilling, which is not always the best solution, especially if we need to pass that prop down really, really deep into the tree. And so in the next lecture, we will take a look at one of the possible solutions to this problem, which is component composition. As we keep learning about components in this section, there is one essential principle that we really need to focus on now, which is component composition. Now, in order to talk about component composition, we first need to take a look at what happens when we simply use or include a component in another component in JSX. So let's say that we have this modal component that we want to reuse, and also this success component, which simply renders the message well done. And then we just use the success component inside the modal component like this. And this sort of thing is exactly what we have been doing with our components most of the time, right? So we just use them inside of other components. However, when it comes to reusability, this creates a big problem. That's because right now, the success component really is inside of modal. They are deeply linked together in the JSX right now. And therefore, we cannot reuse this modal component to display some other message inside of it. For example, an error message. But as you can imagine, in order to solve this, we now bring in the technique of component composition, where we can compose the modal and success components together. So here we have our modal component again, but with a fundamental difference. So this component does not include a predefined component, but instead it accepts children with the children prop. So just like we have learned before. So if we get our success component again, we can now basically just pass it into the modal by placing it between the opening and closing tags when we use modal. And if you need a minute to analyze this code a bit better, feel free to just pause the video right now. Because I want you to really grasp the fundamental difference here. So in the first example, the success component is really tied to the modal. And so that modal might as well be called a success modal, because we can't use it for anything else anymore. But with component composition, we simply passed the success component right into the modal and composed them together in this way. And again, this works thanks to the children prop. Now, of course, we could have passed in any other component, which makes the modal component highly reusable. So essentially, when we do component composition, we leave this hole or this empty slot in the component, ready to be filled with any other component that we want. So let's say that later we needed another modal window somewhere else in the app, but one that renders this error message. Well, that's pretty easy now. We just use the modal component again, but this time we pass in the error component as a children. And with this, we have also successfully composed these two components together as well. So formally, component composition is the technique of combining different components by using the children prop or by explicitly defining components as props. Now, we use composition for two big reasons, or in two important situations. First, when we want to create highly reusable and flexible components, such as the modal window, or really a million other reusable components that we can think of. And we do this really all the time. Now, the second situation in which we can use composition is in order to fix a prop drilling problem like the one that we found in the previous video. And this is actually great for creating layouts, as we will do in the next video. Just keep in mind, once again, that this is only possible because components do not need to know their children in advance, which allows us to leave these empty slots inside of them in the form of the children prop. And with that being said, let's return to our project. So let's now use component composition in order to fix the prop drilling problem that we have just encountered before. And in the process, we will also find a way better solution to building layouts in React applications. And let's start by fixing the easy prop drilling problem, which is the one where we pass the movies prop into the navbar, and then from the navbar, we pass it here into the num results. So here we only have one level of prop drilling. Now, you might be wondering, how can we use component composition in order to solve this problem? Well, what if we could use the num results component right here in the app component instead of in the navbar? Then we wouldn't have to pass in this movies prop into the navbar, right? Which would then fix that prop drilling problem. So we can actually do that with component composition. So let me show you how. So here, instead of accepting the movies, let's accept children. And so this is then that empty slot that we talked about in the previous lecture. And so now here in the navbar, instead of closing it right here, let's have a opening tag and a closing tag. And then between these two, we can just grab this, place that here, and then just include those children. And that's it, actually. So give it a save. The app looks exactly the same as before, but we have eliminated the prop drilling problem, right? Because now we are using num results right here in the component where the state actually lives. So the movie's state in this case. And so then we can pass it directly into the component right here, which is the one that actually needs it. So num results is not an intermediary component, just like navbar was before. And so of course then here we can finally and terminally remove it. And so this then really shows that the prop drilling has been eliminated. And all by using component composition, where we now basically composed the navbar together with these three other components here. So these three is what are becoming the children of the navbar. And so here, again, we then accept those children and simply display them here. We could also say, for example, that we do not need to display or to include the logo right here. So we could, for example, cut it here and place it here. And then it works just exactly the same as before. So this logo here is just completely stateless anyway, and it's not really relevant to the app. And so we could say that it should always be a part of the navbar. But maybe these two here can be optional. So with this, we can very easily later say that, well, maybe we don't need a search here. So remove it, and there you go. We didn't even have to touch the navbar at all. All we had to do was to come into our application, where we now have an easier way of seeing basically the overall layout of the application. Let's of course put it back, and then let's fix the worst problem of prop drilling that we also have, which is here for this movies list. So let's do the same with the main component here. And here remember that we actually need to pass the movies prop through several layers. So we pass it from app into main into here the list box. And so we can remove, again, all these intermediary steps. So here in the main, let's no longer accept the movies and instead accept children. So then let's remove the watch box from here, or actually the list box, or actually why not both of them? So let's cut them from here, say children, and then we can do the same thing as before. So here now we get rid of this. Let's close it. And then just place these two here. And we can then no longer pass the movies into the main element or the main component, because that one no longer needs it. I mean, as you know, it never even needed it in the first place. It only needed it to pass it further down the tree. But now the tree is basically built in a different way. And so then, again, this component no longer needs that prop. Nice. And so, actually, we can keep going. So we can just do exactly the same thing here to the list box, because that list box also doesn't need the movies, really. It's also just passing it down. And so, let's remove it. So, let's grab this, cut it from here. So this will now become the empty slot here inside this list box component. So remove that. Do the same thing as before. Of course, we need to close it here. And well, that's taking a bit too long. Let's manually reload here. And still that's not working. But yeah, the code should be correct. Let me just remove this from here now. And I will simply close the app and run it again. So it's the second time we needed to do this in this section so far, but sometimes that can happen. Well, apparently this is not the solution this time, so let's see if we have some error here. And actually, yeah, sometimes it's a good idea, as I said right in the beginning of the course, to actually read the errors here. So it says objects are not valid as a React child. So let's go back to our movie list, or to the list box, actually, which is the one that we just did something in. And yeah, the problem is actually right here. So here we were basically creating a new object, which is not necessary. All we need to do here is to really conditionally render this children prop. So give it a save, and there we go. Just reload again to get rid of the errors, and that's it. So now we are essentially directly passing the movies prop right here into the movies list from the app component. So as I just said, we are in the app component, and now, thanks to all this composition here, we can pass the movies directly into the movies list, which is in fact the only component that does actually need it. Not this one, but only this one. And of course, also this one. Great. So this is actually a really, really nice way of building layouts in React applications. So just by looking at the return JSX from the app component, we can nicely see the entire layout and also basically the entire component tree. So what we have here is indeed very similar to what we can observe right here. So we have the app, which has the navbar, which in turn has the search and num results, and we have the main, which has the list box, it has the watched box, and then that one also has some stuff in it. So here we didn't do the component composition yet, but we will do very soon. For now, I want to take a break here, and I want you to analyze this code on your own for a few minutes. So really understand the deep difference between the code that we had before and the code that we have right now. And if necessary, you can also re-watch the previous lecture in which I explained exactly what is happening as well. So again, please take now 5 or 10 minutes to do that, and then let's move on to the next video. So we used composition in order to solve a prop drilling problem and to build our layout in a way nicer way. And so now let's use it to build a reusable box component. So we already converted the list box component here to use the children prop in order to then basically fill that slot, so that hole, with this component that we pass in as a child component. And so now we could go ahead and do the exact same thing with the watched box. So let's actually go there. So watch box, and it's right here. However, if we take a look at this component right here, it is very, very similar to that other box. So to that list box. So basically both of them have this state here of is open, then they have a div with the class of box, and then they have this button, which is also exactly the same. And in the end, they will render their children conditionally, so based on the is open state. So again, if we go here, we will see that it is basically exactly the same. This one here has this watched state, but we can easily move that somewhere else. So what I'm saying is that both the watched box and the movie box have this same state here. Basically, they have this same class name, this same button, and then they render something conditionally based on the open state. And so this is an amazing candidate to create a reusable component. So let's do that. And let's do it separately, actually, of the other ones. And I will simply call it box. Let me, just to make this a bit easier, cut this one and paste it close to the other one. And then we can see how similar they actually are. And you know what? I will actually not create a new one, but I will immediately convert this one here, because the list box is basically already what we want. So let's just recall it box. Then here we no longer need like this name here of isOpen1 and set isOpen1. Let's change that here, and here, and that's already it. So we no longer need this watched box. So let's completely comment that one out. And so let's now use this box here inside of this list box that we're using. So box right here. Let's remove that one for now. And box here as well. And well, for some, I had the wrong one here open still. So just to make sure, let's reload. And so this part still looks exactly the same as before. And so now we can use this reusable box and simply pass in that content that we passed before into the watched box, which is basically this, right? So copy that and let's paste that here. And now we get the problem, which I was saying before, which is that this watched array here now needs to be moved onto this component. So this state that we had before can no longer live here, but it couldn't anyway, as we will see in a future section. So we would have to place this here anyway. And so yeah, this fixes the problem. And we shouldn't even need this right here. And so there we go. We just created ourselves a reusable box component, and the state now works, of course, still in both. And so we didn't have to rewrite that same state logic and the same button here in both of these lists, because again, they were basically exactly the same. And so what we did, again, was to create this reusable box and in there allow for any children to be passed in. So we created like this empty hole here, ready to receive any components that we want, which in this case is the movies list, and in this case, it's the watched summary and the watched list. So here we have just one children component, and here we have two. But no matter what, our box always works for all of these situations. And so again, all of this logic here, so this button here with setting the open state could just be reused in this way. And on top of that, as a bonus, we made our application tree here even more explicit in the app component. So now it really is very clear what exactly is happening in the application just by looking at this one component. We can immediately see the entire structure of the application, which is really, really helpful. So this is really great, and we're moving into some more intermediate React territory. But that makes complete sense because we are already in part 2, which is exactly for intermediate React. So it's great that at this point we are already able to do something like this, which is already way closer to how real-world React applications look like. So really, really keep this technique of component composition in mind, both for building better layouts, for solving prop drilling, and also for creating reusable components like this one. So hopefully you saw how powerful this is. And so as you start writing your own code, be on the watch out for whenever you can do this. So whenever you can create some reusable components in your own code using this amazing technique. In the lecture about component composition, I said that we can use the children prop for composition or an explicitly defined prop. And so let's now quickly explore that second option. So instead of using the children prop in a component and then passing in a component like this, we can use an explicit prop as an alternative. So let me show you what I mean by first commenting out all of this. And then we can go to the box component. So down here. And now, instead of accepting children here, let's say we accept something called element. And it can really be called anything. So just L or really whatever. And so now we can go back up here and include the box in the old way. So closing it immediately, but then we can specify the element prop. And now here we can then do exactly what we had here. So let's copy that and paste it, give it a save, and that worked. So now we have our movie list like here, and it was passed into the box component as an explicit prop. In this case, a prop called element. So before, what we had here is that we were basically implicitly passing in this component into the box, and then we read it there with the children prop. But here we now basically pass it in more explicitly. So we really say that we have an element prop, and then we place whatever we want to pass in right here. So right into the element prop. And this pattern is used in some library, for example, in React Router. And so this is why I thought it might be interesting to show this to you right now. And of course, we can do the same with the other box here. So simply saying element and then this. Now here, basically, we are passing in a brand new piece of JSX. And so here, we now actually need a fragment. Give it a save, and there we go. So the app now looks exactly the same as before, but we basically passed in an element or multiple elements here instead of using the children prop. But the result is exactly the same. And under the hood, inside React, it should also be basically exactly the same. So this can be a viable pattern in case you need to pass in multiple elements and give them separate names. So that would be a perfectly fine use case for using something like an element prop or really any other prop with any other name instead of the implicit children prop. But in our case, let's go back to what we had before, because I think it looks a lot nicer actually, and it's also clearly the preferred way of doing this inside React. So this was really just to show you. So I will just delete this entire code and put this one here back. And then let's go to the box and fix it there as well. And by the way, let me show you a very nice trick in VS Code, which is that if you hover over any component here and then hit Command on the Mac or Control on Windows, we can actually go right to the definition of the function. So in this case, of the component. So I'm hovering box here, then I hit the Command key, click, and then I immediately move there. And what's even nicer is that if we do the same down here, so again, hitting the Command or the Control key, then we go right back up. Well, in this case, somehow it doesn't work, but usually it should. But yeah, what matters is that we can move from where the component is called into the place where it is actually defined. And so now let's change element back to children, and then we have just what we had before. So this was really just to show you an alternative way of using component composition without the children prop. But again, using children is by far the preferred way of doing things. Let's now take a break from building our project and build a small, reusable, and flexible star rating component. So what we want to build is a component like this one. So it displays multiple stars, and then as we hover over them, it displays the currently selected rating here on the right side. So as you see, as we hover over the stars, it always shows the currently selected number of stars, and if we click here, then that number stays fixed. And if we then click again, because this movie is definitely a 10, then of course we can also change that rating. Okay, now we will develop this component here in complete isolation, so outside of this current application, so that we could reuse it anywhere we wanted and also make it really flexible by allowing for different props. For example, here we can rate between 0 and 10 right now. but we will make it so that the user of the component can choose what number of stars they want to display. And that's just one of the things that we will do. But anyway, let's now come here to our project, and then let's create a brand new component file here. So star rating, and then export default function, and then the name of the component. So star rating. And for now, we won't accept any props here. We will leave that for later. And now let's just return something here. And now what I want to do is to actually come to the index.js file and then no longer import the app here for now, and also not the CSS file. Because again, this component should be completely reusable, and so it shouldn't depend on any external CSS files. So instead, what I want to do now is to import that star rating. And you see that VS Code automatically wrote our import statement here. And if for some reason your VS Code didn't help you with this autocomplete, then just make sure to type exactly this. Then finally, we also need to remove this one here temporarily and instead include our star rating here. And I'm doing it like this just so that we don't have to create a brand new project just for building this one component. So for now, we will just use this project that we already have instead of creating a new Create React app. But anyway, let's give it a save now. And now here you see that hello that's coming from here, so from the star rating. So let's close the app and this sidebar, and then let's get started. So starting with the JSX here, so just with the structure, we see that we have basically two main elements. So we have one container for all these stars, and we have then like this message here, so the current rating on the right side. So inside our div, let's place another div for those stars, and then one paragraph for that message. So for now, let me just place a number here, and here for the stars, we want to dynamically generate these star elements. So instead of writing them by hand one by one, because that's the only way in which we could sometimes have 5 stars, in other situations 10 stars, or really any other number. So let's use the technique that we used before in the far away app. So entering JavaScript mode, and then we can write array.from. And here we can then specify an object with the length property. And let's set it here to 5 initially. And so this then creates an empty array with 5 elements that we can then immediately loop over by passing in a function, so like a map function, here as the second argument. So in this function, we are not interested in the elements themselves. So let's just use a placeholder variable, but we are interested here in the number. All right, and now here we can just render anything. Let's just do a span element for now, but later we will place the stars in here. So let's just write S for star, and then here the number. And actually this should be S plus 1, because I, of course, is 0 based here. Okay, and this should already be something. And indeed, we see star 1, 2, 3, 4, and 5, which of course, again, are just placeholders for now. Here we have some error, which probably, yeah, it's because of that key prop. So let's add that key here. Well, actually we don't, because this is just temporary anyway. Okay, so now let's define some styles here. And remember how I said initially that we cannot depend on any external CSS file or CSS classes. And therefore, we need to define all our styles inline. So let's do that, starting here with the parent element. And so here we now need to specify an object. And why not actually do that here as a separate object outside? So let's write container style. Then let's set the display property to flex. So to place the two elements side by side. Then align items. Let's set that one to center, which will align the items vertically. And then let's also specify a gap of 16 pixels. Okay, and now here we can just specify that. Give it a save, and that looks already a bit better. And now we can do even better, which is to take this entire object, which will never change, and it doesn't depend on anything that is here in the component, and we can place it completely outside of the component. And by doing so, this object here will not have to be regenerated by JavaScript each time that this component here re-renders. Because otherwise, each time that the component does re-render, this function will get called again, and so then this object would also get regenerated again. And so that's not necessary, and so we can just place it outside here. Now next, let's also create some styles for the other container. So this container here with the stars. So let's say star container style. So let's also do display flex and then give it a gap here of just 4 pixels for now. All right. And finally, just some styling here for the text. So text style, let's say line height. Yeah, I was trying to write some actual CSS, but in JSX, remember, we need to write our property names camel cased. So not line dash height, but line height like this. Let's also specify a margin of 0. And here let's actually say 1. So this probably won't change a lot yet, but it's going to be important later. So style. Okay, and now to finish, let's do what I said right in the very beginning, which is to basically allow the user of this component to set the maximum amount of stars. So the maximum rating. So coming back here, let's say that as the user of this component, I wanted to pass in the max rating, for example, as 5. Now then, maybe I wanted to use this component at some other place in my application, but here I wanted 10 stars. But now as we reload, of course, both of these components will only have 5 stars because we hard-coded that value here in our rating. So what we need to do is to now accept that prop here, max rating, and then use that right here. And so this is why we had to use this trick here instead of manually writing the number of stars. So instead of writing one element here per star. And so if I save this now, you see that indeed we get now 10 stars here. Great. But now, what if someone used this component without specifying the max rating property? So since we're building a highly reusable component, we need to account for all these situations, because we will never know who is actually going to use this component and what props they will specify. So we need to account that this might happen. So in this case, we have a problem, because then, well, we have exactly no stars. So what we need to do is to set a default value for the rating. So how do we do that? Well, we can actually leverage the power of destructuring in JavaScript, because whenever we destructure an object, we can actually set a default value as we do so. And so here we are actually destructuring the props object. And so if max rating doesn't exist, we can set a default simply by writing this. And so if we save this now, then we are back to having our 5 stars by default. And so this is a very common way of setting default props in React applications. We will do this all the time as we go through the course. Next up, let's actually create the stars and make the component dynamic by reacting to a click event. So let's create a brand new component here. So function star, because the JSX code here is actually going to be a bit complex. But for now, we will want to return just the icon itself. So I actually already included that icon hidden here in the CSS file. So if you scroll all the way down here, you will find some code. Here it is. And so let's grab all of this comment. So all the way until the end, cut it from here and paste it down here. Then we can close the sidebar and this one. And so here we have the star icon as an SVG. So let's start here with the full star. So just this SVG, copy that and paste it here. And then let's use that star here. So instead of this, we will simply include the star. And then let's also define the key prop and let's simply use I. So the current index, which is not ideal, but at least then React doesn't complain anymore. Give it a save and nothing is happening here. Let's try that again. And let's inspect what we have here. So I was not expecting this. So we have indeed our stars here, but they appear to not have any height. And so let's try to fix that right here. So I will just wrap this SVG into a span element. Let's cut that from here, place it at the end. And then I will again define some style object out here. So let's say const star style equals, so width, let's say 48 pixels. And let's do the same for the height. Let's give it a display of block property as well, and setting the cursor to a pointer so that they behave a bit like a button. And so then we should also define the role property here for accessibility. So this is just HTML for accessibility. It has nothing to do with React. Okay, and then our star style. And there we go. So now we have our nice stars. Now they might be a bit too big here, but we will later allow the user to set the size. I'm just noticing that we have maybe enough space between them, and so let's remove this gap right here. Great. Now let's actually make our component dynamic, meaning that whenever we click on one of these stars, we then want to display the current rating here in this paragraph element. So, since we now want the UI to re-render based on an event, so we want something to happen on the screen, we need state. So let's create a new state variable called rating, of course, by using useState. And by default, let's set it to 0. Okay, next, let's use that state. So as a second step, we include the rating prop right here. And so then we see 0. While that's maybe not so ideal, because if the rating is still 0, that simply doesn't mean that the user hasn't basically rated yet. So they haven't done anything. And so here, let's say that we either want the rating or an empty string. And so thanks to short circuiting, we will then move here to the second part of the operator whenever this is a falsy value. But of course, if we had 1 here, then we would see that 1. Now maybe just to clear the confusion a bit, let's remove these other 2 star ratings here. So working with just 1. And so where do we now need to listen for the click events? So basically, when the user clicks here, then the rating should become 1. If they click here, then it should become 2, 3, 4, and 5. So what this means is that we need to listen for the click event on each of these stars. So let's start by defining a onClick prop here, which we will then later receive inside the star. So here we will now define a function which will actually set the rating. So let's say set rating, and then whatever the current index is plus 1. Because remember that array indexes start at 0, but our rating should start at 1. Okay. So now, of course, nothing will happen right now because we actually need to listen for that event on an HTML element. So like an JSX element. So what that means is that here we need to now accept that onClick handler. So this function that we defined right here. And then use the onClick prop right here to then actually listen for the event and react to it. And if this is a bit confusing, then let's maybe change the name here from onClick to onRate. And so then it becomes really obvious that this is actually our own prop. So this is our own handler function. And we could, of course, even have created that separately. So onClick should be onRate. And so this is basically what we have been doing all the time, which is to pass an event handler function from the component that owns the state, so this one, right into a component that wants to actually update that state. So in this case, that's star. So we can make that even more explicit if we want. So we can say function handle rate or handle rating maybe. And then here we accept a rating, and all we do is then set rating, well, to that rating that we receive. And then here we can use that handle rating function. And so with this, we created a similar pattern to what we have done all the time. So creating a handler function in the component that owns the state, and then passing that handler function into some other child component which will actually update the state. Now here we are actually passing this function here, so not just this one, because here we need to fix the value of the rating that we want to be set for each star. Okay, that was a lot of explanation. Let's just reload here. And now as I click, you see that the state does indeed update. All right, so that's already working. And yeah, if this was a bit difficult for you to understand, then you can, as always, just pause the video here and analyze the code on your own. So what we did here is actually a bit similar to what we did in previous exercises. For example, I think in the accordion exercise, we did something very similar. Okay, and now to finish, what I want to do is to display only the amount of stars equal to the rating in full and all the other stars empty. So just like here. So here, if I click on the 5, then you see that 5 stars are full and the other ones are empty. And so here, let's now quickly do exactly the same thing. So we already have that other empty star right here. And so now we want to basically conditionally render either the full or the empty star. So let's grab this here. Let's cut it actually. And then here, let's enter JavaScript mode. So we will want to have a prop here for the star that says if this star is full. So we will take care of that later, but for now let's just say, if the star is full, then render this part, so that SVG element, and if not, then render this one. All right, and so now of course full is undefined because we are not passing it in, and therefore all of the stars are empty right now. So how do we define whether a star is full or not? Well, it's actually pretty simple. So full should basically be a true or false value, right? That's why this conditional rendering here works. So again, when full is true, then this one will be rendered, and if it's false, then the empty star. So here we just want to now write a condition basically that will always be either true or false. So all we have to do is to say, is the current rating greater or equal I plus 1, which is always the rating for the currently generated star. And you see that immediately that worked here. Great. So let's again see why this actually works. So it all starts with this I variable right here. And so this comes from the index of the empty array that we create here with the length of max rating. So we create that array and then we immediately loop over it. And so then the first star that we create has the number 0. So this one is star 0, 1, 2, 3, and 4. We then use that index in order to handle our rating. So if we click on the very first star here, it will be 0 plus 1, and so it becomes 1. If we click on the third star here, well, then here the index is 2, and then 2 plus 1 makes 3. And so then the rating, as we see, is set to 3. And then, in order to determine whether a star is full or not, all we need to do is to compare the currently set rating to the index of the current star. So here the index is 0 plus 1, so here it's 1, here it's 2, here it's 3, 4, and 5. And so right now our rating is 3. And so here, of course, that 3 is greater than 1, here it's greater than 2, here it's greater or equal 3, and so it's still true, but then here it's of course false. So 3 is not greater or equal 4, and therefore this one here is then not full. So this condition will return false, which will then make the star being rendered as empty. Okay, so hopefully that made sense. And indeed, our component is now already almost working. All that is missing is this functionality of hovering the stars. And so let's take care of that in the next lecture. Let's now handle the event of users hovering over our stars. So basically the functionality that we're looking for is this one. So whenever we hover over these stars, we get like a temporary rating here exactly with the number of stars that are currently being hovered. So here we have 9, here we have 3, but it is completely independent from the rating that is actually set right now. So the rating is set to 5, but again, whenever we hover over some other number of stars, then that temporarily changes to that rating. All right, so what that means is that now we need a brand new piece of state to basically store that temporary rating. And again, that makes sense because something should happen on the screen, so the component should re-render whenever there is some hover event. That's how we then get that new rating in there. So let's say, for example, temp rating, which stands for temporary, and then set temp rating. And we start at 0, and of course the rating itself should also start at 0. All right. Now in order to actually handle that hover event, let's go down here onto our star. so into our start component, and then where we handle the click is where we also handle the hover. Now there's not really a hover event, but instead we have on mouse enter. So let's just do some console.log here for now. So that's one of them. And then we have mouse leave. So we basically need to handle these two separately. Okay, just so that we can quickly see. So I entered basically this element, and then it said enter. And immediately afterwards, it said leave. So let's see again. And indeed, each time that we enter or leave, well, we get our log down there. And so now all we have to do is to update that temp rating state that we just created in each of these situations. So let's pass in then two handler functions here into the star, just like we did for the onRate. So let's call this one here on hover in, and the prop name here is different again from the event name, just to avoid some confusion here. So we could also call this prop on mouse enter again, but then it might be a bit confusing, and you might think that the event is actually handled right here on the star component, which of course is not possible. So the event always needs to be handled on a JSX element itself. So like an HTML element, such as a span. Okay, and now all we have to do here is to basically set the temp rating to the rating of the current star. So that's again I plus 1, right? And then on hover out, we set it back to the initial value. So temp rating back to 0. So here we need to change the name. So of course this is with an uppercase R. And now all we need to do is to accept these two props here and wire everything together. So on hover in, on hover out. All right. And so then here we of course want to now call these functions. And here on hover out. And now finally we need to actually display this rating in the UI. So you see here right now that it's still yellow, which means that we haven't used it anywhere. So let's for now replace this rating with the temp rating. And then let's see. And yeah, that's already working. So see how that value was there. Shortly we had the 3, then here the 4, the 5, and so on and so forth. So that's working great. The only part that is not working is that the stars are not getting full. And so let's quickly fix that here inside this condition here. So here we can say that if there is a temp rating, so if there is a temporary rating, then do the same thing, but with that temp rating. So then temp rating greater or equal I plus 1. But if not, well, then we just do what we had before. And so this should fix that. And yeah, beautiful. So that works great. And if we click here, well, then the number disappears, but the stars stay the same. And so that's because now we have the rating set. And then so here in this full prop, we enter the second branch, which then, just like before, sets these 4 stars here to full. Now all we have to do here is to place another OR here and say, basically, if there is no temp rating, then display the current rating. And if that also doesn't exist, well, then we get the empty string. So indeed, we now get 4. if we click again, we get 5, but as we hover, we get the temporary rating. So just like we wanted, and just like this component here works as well. So this looks really nice, really real world, actually, and it wasn't that much work. All we had to do is some tricks with these two rating states and then handling all of these different events. So basically handling the click, the mouse enter, and the mouse leave. And the result, if you ask me, is even a bit magical here. So I really, really like this effect that we created here. Okay, and so that's the main functionality already implemented, but now let's make the component really, really flexible by allowing a couple of props. So we will learn all about that in the next lecture, and then we will come back here and create the API, basically, of this component. When we build a reusable component like the one we are currently building, we should carefully think about what props the component needs. So let's now shortly look at how to think about props. So first of all, as we start working on our components, we should get into the mindset that any component is always created by someone and always consumed by someone. Now, when you're working on your own, the component creator and consumer is of course the same person. But if you're on a team, those might very well be different developers. But in any case, it's always a good idea to think in terms of there being a creator and a consumer of a component. So different entities, even if it's just yourself. So basically, the creator is the person building a component and defining what props the component can accept, while the consumer uses the component somewhere in the application by specifying values for the props. Now, the reason for the separation between creator and consumer, even if you're just working on your own, is that if we have this mindset, we can think of the component's props as the public API of the component. So, as a component creator, when we choose what props the consumer is allowed to pass in, we are essentially defining the public interface of our component. And at the same time, we are choosing how much complexity of the component we want to expose to the consumer of the API. Because in the end, a component is basically just an abstraction. So we are encapsulating a part of the UI and the associated logic into a component and allow consumers to interact with that component via props. And that's it. That's basically what creating a new component is. But anyway, when we decide about what props to allow in a component, we need to find a good balance on how strict we want to be. So about how many props we want to enable for configuration. For example, let's say we're building a weather component. So a component that simply displays the weather. We could make it extremely simple. For example, only allowing one prop, so for the location for which the consumer wants the weather. Now, this might be perfectly fine, but it might also make the component not flexible enough, or maybe even straight out useless for the consumer. On the other hand, we could allow props for the URL of the weather data, the number of days, whether it should be daily or hourly, how many days, which temperature to unit, what data should be displayed, and so on. I could think of really 20 other props here, but the point is that exposing so many props might make the component way too hard to use for the consumer because we're exposing too much complexity. And speaking of complexity, you will end up with very complex code if you want to allow so many props. So, when deciding on the right API for your components, try to strike the right balance between too little and too many props, and a balance that works well for both the creator and the consumer of the component, based on the project's needs. Now, if for some reason you really need to expose so many props, make sure to at least provide some good default values for many of them. Okay, and as always, this will come to you with practice, but I thought that it was quite important to get you into this mindset of distinguishing between component creators and consumers. And so with that, we're ready to put this into practice. Okay, so let's now make our component really flexible and reusable by defining a nice public API for consumers to use it. So right now, our component is quite unflexible and therefore not really reusable. So it might maybe be useful in one very specific case where we want the component to look and behave exactly like this, but it won't be useful for many other consumers. So if we imagine that we want to reuse this component in many other applications, or maybe even publish it to NPM to share it with all React developers around the world, then they will probably not find this component very useful right now. So those developers, or in other words, those consumers, they will probably want to define things like the colors of the stars, or maybe the sizes of the stars and the text, in order to basically make this component fit into their own applications. And so what we're going to do now is to try to define a good public API for this component, just as we learned before. And so by doing that, we will try to find that balance of using too few props and using too little props, so that the component also doesn't get way too complex. So let's get to work, and let's actually start with those two simple things that I just mentioned. So the color and the size. So let's just write that here, color and size. And as I mentioned also in the last lecture, it's a good idea to provide default values. So we already learned that we can do that by providing the default values during destructuring. So just like we did with the max rating. And so let's say that our default color will be this yellow of FCC419. And the default size, let's make it the number of 48. Okay. And now let's use these props in our component. So to basically accept the color and then change the stars and the text to fit that color. And the same for the size. So I want to start with the text. And so now I actually need to take this object here back into the component, because now we will specify some properties which will depend on the props. And so the props are of course only accessible inside the component. So then this object will have to live inside the component as well. So the color property will be set to color. And so we can actually just do it like this. And if we give this a save, then you see the text does indeed turn yellow. Now it might be a bit small. And so let's now also use the size. And so let's use a template literal and then use the size that we received as a prop and set the pixels to that. Well, that's maybe a bit too large. Let's try to divide this, for example, by 1.5, and that looks a bit nicer. All right, and now we should also use these values here, of course, for the stars themselves. So to do that, we will also now place this style object inside the star, and then we need these values also here. So the color and the size. And so of course, then we need to pass them in here as props. So color and size and size. And so then here we can again create a template literal, get the size, and then pixels. Let's do the same for the height. And here nothing changed because we already had 48 here. And now finally the color is actually defined right in the SVG elements. So here we have the fill and the stroke of black, which is the reason why these are currently black. But if we change that here, like this, so color, then you see that they just turned yellow. Now, of course, this other one isn't yellow yet because, well, it is still at black. So let's change that here as well. Okay, beautiful. So that's already a lot nicer than before. Let's just call another component here. And let's define some other size here. Let's say 24. And so here we have a much smaller component, but which still works in the same way. And of course, we can also specify the color, let's say red. And so with this, we just made our component a lot more flexible. So if someone wants to use this component in an application where the main color is red, then they can now easily change all of this to red. Now, sometimes consumers or users of the component want to have even more control over the styling. So sometimes it's a good idea to allow users to pass in a class name. So for example, a class name with the name of test, just in this case, which will then come from some CSS file in the application where this component is being used. So right now we don't have any class like this, but this is just really for testing purposes. So then here we need to accept the class name. And by default, it will just be an empty class name. And then we just add it here to the overall container. So class name, and then class name like this. So for example, if the user wants to somehow change the font style, they can do that right inside this class name that they pass in. And so that class name will then be added here and will then change the font family of our component. Now, another thing that I sometimes see on the web when we have a component like this is that instead of just displaying the rating number, is that they display like some message according to the rating. So in order to do that, we could pass in an array, and let's actually do that here. So we could pass in an array of messages, for example, saying that the first value is terrible, the second one is bad, then we have okay, good, well, as a string, and then amazing. And so now we can display these 5 values here, so these strings, instead of the numbers. So that's another nice touch that we can give our component here. So then we accept that prop here. And by default, let's make it an empty array. So really, really important to always give default values. And so now here we can use those values. However, we want, of course, to only use that messages array in case that there actually are some elements in there. And also, the number of elements should be correct. So for example, if we allow for a rating between 1 and 5, but then we only have 3 elements in the array, then that doesn't make a lot of sense. So this wouldn't work. And so here, what we can do is to just check if messages.length is equal to the max rating. And if that is the case, then that means that a messages array was passed in. And if not, then we just do exactly what we had before. But in this case, let's then just display the messages at position rating -1 in order to convert back to zero-based index. And of course, we should also consider the temporary rating. So let's actually just copy what we have here, or maybe not. Okay, it's not that similar. So let's come here and say, if there is a temp rating, then use temp rating -1. And if not, then just use the regular rating -1. So again, if this looks confusing, then just make sure to pause the video and analyze that code. But this is just normal JavaScript at this point. But anyway, as you see, this works great now. So 1 star means terrible, bad, then it starts to become okay, good, and finally amazing. And of course, it also works with the not temporary rating, so with the fixed rating. While here, this other component where the messages array is empty, so that's the default here. So here it's empty, and so therefore we are still displaying just the number. Great. And let's keep going, because there is still at least one important thing missing, and that is to allow the consumer to set a default rating. Okay, so that's not very hard. So let's say, for example, that the user wants to start with a default of 3. Default rating should be 3. So the consumer might want to specify a prop like this. And so let's now then add that prop here and give it a default value. Now by default, the rating should be 0, which is exactly why that's what we put here, right? And so the default rating should be just that, 0. But of course, now we need to use this default rating, and we will use it right here instead of that 0. So basically, we will initialize our rating state with whatever default rating comes into the prop. And if that prop is not specified, then that's simply exactly the 0 that we had before. Now, maybe you heard or read that we should never initialize state from props. However, this is only true if you want the state variable to stay in sync with that passed in props. Or in other words, if you want the state value to update in case that the prop value is also updated. However, that is clearly not the case here. So we are really only using this default rating here basically as seed data. So really just as the initial state. And we don't care whether this value here maybe changes somewhere else in the application, so outside this component. And therefore, this is perfectly fine and normal to do. All right? So it's really no problem to initialize your state based on a prop. So I just wanted to address this point because I could already hear some people complaining about this. So this was more relevant in the old days of React before we had hooks, but now that's really no longer a problem. But anyway, as we save this now, you see that immediately we see the 3 ratings or the 3 stars as the default here. And of course, if this was 1 or 2, then that's what we will see there. And so again, that's just because we are now using this number 2 as the initial state value of our rating. All right. And now we could keep going here, of course, and add a lot more different props. So allowing for a lot more configuration. For example, we could say that we want the colors here to change according to the rating, or we could allow for some different spacing between the stars. We could also allow the consumer to specify on which side this text label here appears. So maybe they want it on the left or at the top or at the bottom here. But that might be going a bit too far here and maybe specifying too many props and adding too much complexity. So I think that what we have here right now is more than enough, except for one important thing that we are still missing right now. And that thing is the fact that the consumer might actually need this rating state outside of this component. And to exemplify this, let's come again back here And what I want to do now, just temporarily, is to create a new component right here. Let's call it test. And so this component is then the one that will include the star rating. And let's say the color in this case is blue. Why not? And then let's also include that down here. And you will see why I'm doing this in this way in a minute. Okay, so here we have another one and a blue one. But now let's say that for some reason they also really needed to display this rating somewhere in their user interface. So for example, they might have a paragraph saying this movie was rated X stars. So here let's actually already use a max rating of 10. And so now what they want to happen is that whatever rating we specify here should then be displayed right here in the user interface. So now it should say here that the movie was rated 7 stars. So how will they do this right now? So they basically need access to the state, so to this rating state that we have inside the component, but right here, so inside of the test component. So what they need is some state. So let's say movie rating and set movie rating. And then use state. And let's again set it to 0. And then here let's use that movie rating. But of course, this now will not change at all when we rate the movie right here. So we need a way to update this state here whenever the state inside this component is updated as well. So how do we do that? Well, basically, we want to give the consumer of this component the ability to pass in a set function. So basically, we want them to allow to specify an onSet rating handler. And so in this case, what this component wants to pass in is simply this function right here. Okay, so let's now specify then this prop here. So we want to accept this very important prop right here. And this one by default doesn't need any default value. All right, and now it's very simple. All we have to do here is on the handle rating is to not only set the internal rating, but also to basically set the external rating. So we can now just say on set rating, also set that external rating. And with this, we now gave the outside test component basically the ability to get access to that internal state right inside this component. Okay, and now if we change this here, you see that it did indeed get updated to 7. So this additional configuration, so this final prop that we updated here, or that we actually added here to our component, was really, really important. Because without this, this component would really just be presentational in the end. I mean, it contains some state internally, but from the perspective of the test component, we couldn't really touch that state in any way. And therefore, we couldn't use that state inside this component, which then, again, wouldn't make this component really useful. Okay, so this was the final prop that we added. And as I said, we could keep going and get really crazy here with our configuration options. And you could, of course, if you wanted, allow some other things, such as the ones that I have mentioned earlier. But we will just leave it as this, because I think this right now is a pretty good balance. Now there's just one final thing that we need to do here in our component, which is to prevent the user basically to pass in some values that we do not want. So here, for example, this shouldn't be a string, right? Because, well, then this wouldn't work at all. So we need to make sure that this is actually a number here. And so let's look at something called prop types in the next lecture. To finish this component, let's now add type checking to the component's props using prop types. So with prop types, we can basically specify the type of value that we expect the consumer of the component to pass in for each of the props. For example, we can define that this max rating here really must be a number and nothing else. And this is what we call type checking. So again, checking each type of the prop and specifying what type they need to have. Now, if you really care about this, you should actually just use TypeScript instead of JavaScript. Now, I will show you how to use React's built-in prop types because it actually does make a lot of sense for this reusable component, but I will not do this in the rest of the course for all the components that we're going to build, because that just takes too much time, and also developers these days don't really do this anymore. Again, if this is really important for your app, you can just use TypeScript instead of JavaScript, which is what many teams and many developers started doing, again, instead of using prop types. But anyway, let's now actually use prop types, and for that, we import the prop types object from the prop types package. So there's no need to install this prop types package here in this case, because Create React App already comes with this package pre-installed. But we do need to import it here, so just as we did here, because it is actually a separate package from React itself. Okay, and now in order to do the type checking, let's use our component, so that's star rating, and then on this component, we specify the prop types property. And here it's important that we write it with a lower case. So prop types, and then here we then assign those prop types an object. So again, we imported prop types here with the capital P, but the property name here is with this lowercase p. Okay, and now here for each of the props, we can specify the type. So let's say max rating. And so that's exactly the name of the prop that we have here. And then now we actually use that prop types object that we imported in the very beginning. And so now all we need to do is to use one of the validators that is inside this object. So here we can simply say prop types dot number. And that's it. So let's say that here we import this star rating, and instead of specifying a number, we specify a string. And so then here we get this problem, or this warning here, which says invalid prop of max rating. And that's because it has the type of string instead of the expected number. And it is these warnings right here that will then allow other developers to catch bugs like this. Because, I mean, no one would specify this here on purpose, but by mistake, we might end up here with a string. So for example, also this could happen. So we could specify the 5 here, but as a string, and then we would still get the same problem. Now the code does actually work with this here somehow. So JavaScript is somehow able to coerce the types into a number. But again, here we get this warning because we really should specify this not as a string, but as a number. And so then, of course, this disappears. Now we can also chain the is required property here, which, just as the name says, will then make this prop required. So somewhere here we probably have one without. Yeah, so this one doesn't have the max rating. And then immediately we get this warning down here. All right, but in our case, we actually have some default values for all of our props already defined. And so it doesn't make sense then to mark any of them as required. So by default, you shouldn't use this one. So instead, just use default values for all or most of your props. But anyway, now let's keep going And let's make this really complete. So the default rating should also be a number. Then the color should be a string. And so we basically have one of these validators here for all the types that we can imagine. So this one is also a number. Then we have the messages. And so here we have prop types.array. Let's see what else we have. So we also have the class name, which is a string. So here I wrote the wrong one. So always use the uppercase prop types. And now finally the onset rating prop. So prop types, and this one is a func, which stands for function. Okay, and besides these two, we also have a .bool, which stands for a boolean, so if it's a true or false value, and we also have object. So in this case, we have none of these, and so this one is just a function. Okay, and that's actually all that we have to do. And as you see here, adding prop types is also a nice way of documenting our components, because this type definition right here makes it really obvious what kind of data we are expecting. But as I said in the very beginning, I will not start using this in all components from now on. So this was mostly just to show you that you can use this yourself in case that you have some component like this, which you want to make highly reusable across multiple applications or even just inside one application. And if at the same time you don't want to switch to TypeScript. But in any case, with this, we finished our reusable component and we also reached the end of this section. All we have left to do is one final coding challenge to practice what we just learned here in this section. Welcome to another coding challenge. And I hope that you really are finding these useful. And if you do, then it's now time to build a reusable text expander component. So here I have 3 of these text expander components that we are going to build. So a text expander is basically when we have some part of a text and then we have this kind of button here that when we click it will reveal the entirety of the text. And then when we click it again, it will go back to hiding it. So this one here is basically one of the text expander components. And then here we have another one. And immediately you see that this one has by default a lot more text. And then this button here has some different text than this one and also a different color. But then when we click it, the behavior is exactly the same. Then finally, we have another one, and you see that this one has some different styling, and also by default, it is open. And so then when we click here, it will close. So let's go here to the starter code, which as always, I have attached as a link to this lecture. And if for some reason you don't want to build this challenge here on Code Sandbox, just copy paste the code from here and also from the CSS file. So that's not a lot, but we will still need that. All right. So here I already have the 3 components included inside the app, and the component itself right now only renders this to do. And so, yeah, this here is your to do. So to build this expander right here. Now, by including these 3 text expanders here, I'm already giving you a hint into what the public API of this reusable component will look like, because here we already used many of these props. And so from this, you can kind of imagine what each of them does in order to achieve the 3 results that we saw here. So the challenge for you is to now actually go ahead and implement this text expander using everything that we have learned up until this point. And if for some reason this is a bit difficult, then just imagine this as a collaboration between you and me, basically. So you build as much as you can on your own, and then if you can't move on anymore at some point, you simply watch the rest of the video, where I will then basically help you completing this component. And if you want, you can of course also go crazy with this one and include even a lot more props than just the ones that you see here. So you can really do a lot of customization here if you want, but of course it's also more than enough to just do what we have here. So this is a really nice exercise, which I hope you will complete, or at least part of it, and then I see you back here with my implementation. Okay, and let's get to work. And I will immediately start by copying all these prop names here. So selecting them one by one, then copy, and then I will just receive them here. Then of course, just some commas. And then we can get to work. And in fact, we are actually missing one, which is basically just the text here. So of course, inside of the expander, we need access to the text. Now this text is between the opening and the closing tag. And so what that means is that this is the children of this component. So it's going to be inside the children prop. So to start, we can actually immediately render that here, just so we see that this works. And indeed, here we get the 3 pieces of text that we have right here. Great. So we already have part of the output, but of course we also want that button. So let's do that. And here let's immediately allow the user to pass in a class name. So in this last one here, the user passes in this box class name. And so here we then accept that. And so then let's add it right here. So class name equals class name, like this. And so this is exactly what we also did in our reusable star rating component, right? Now in that example, we didn't actually have a class name, but now we have. And so immediately you see that this third one here got this different styling. Okay. Now let's place this text here inside a span so that then we can add the button. All right. And now the text of the button can actually be customized. So that is what we have the prop of the collapse button text for. So let's get that, place that here, and then we have some error. So let's see what's happening. Now we're not closing the span, so that doesn't look too good. And so here we already have one button. Now here then we have this like kind of very small button which doesn't have any text. And so that's because only this second text expander is actually passing in the text for the collapse button text property. And so that's because this text here, so this label of the button, is different from the default. So if we take a look here, then you see that by default, this one and this one display the text show more. And so then this one here is different and it says show text. So yeah, this one here is show text. And here it is actually expand. Okay, so expand button text should be by default show more. And so now here we have show more, then this one that's different, show text, and then again show more right here. But now, of course, we want something to happen when we click on this button. So we want only part of the text here to be visible. So we need some state, right? So let's call this is expanded and set is expanded. Use state, and then by default, let's make it false. So by default, the text should not be expanded. So we only want to see a small piece of the text. All right. And just make sure that your use state was correctly imported. Okay. And now let's use this isExpanded state in order to calculate or to compute the text that we actually want to display here. So let's do that in a separate variable, and let's call it the display text. So if it is expanded, so if expanded is true, then we want all the text to be shown. And so that's then the children, right? So children is that text. That's why we place that here in the beginning, right? But if not, then we want something else. So let's just write test there just to experiment. And then we will, of course, replace the children here with that display text. And so by default, now all three of them have this test here, which is this part. And so again, that's because by default isExpanded is false. Now, actually, if we take a look at one of these components here, then this last one will have the prop of extended equals true. So right here, I don't have that. So I have this one, but in the starter file that you will see, I will not have this one, but instead expanded. Okay, so again, in the starter file that I had here, I had a mistake. So we had the wrong prop here, and instead we want an expanded prop and not this one. So here it's not button inline, but expanded. But in the code that you see, this will already have been fixed. So the meaning of this expanded prop is that if it is set to true, then by default, the component here will be expanded. And so that's exactly this third situation right here. So if we reload this one here, then you see that the third text expander is by default already expanded. Okay, and so that's because expanded is set to true. So here, let's now actually not use false, but really get this initial state from expanded. And so then we can set expanded to false by default. And so this is very similar what we also did in our star rating component. So there we also set the initial state based on one of the props, right? So by default, we now have this last one here already opened. And so this one shows the entire text, while these ones here for now only show test. Now, another thing is that in this case that the text is expanded, here the text, so the label of this button should be different. So it should be show less by default. And so let's do that here again as a default prop. So show less. And so then here, let's conditionally display that text. So if is expanded, then show the collapse button text, and if not, then show the expand button text. And so now it says show less. And so this other component here will then show collapse text instead of show less. So because it passes in this special prop that we have defined here. And if all of these props here and all these default values here look very confusing to you, well, that's just because we are really trying to make this component here very flexible and reusable. So just like we did with our star rating component. When we build our normal components in applications, we will not do this, right? We will then usually have the text directly in here, for example, instead of relying on the props and on default values of those props. But again, here we are striving for maximum reusability. But anyway, let's now finally actually make this button work. So, specifying the onClick prop. Here we just need a function, and then let's say set is expanded. And then the new state will be based on the current state. So we use the callback function here. And instead of writing the entire word, let's just say exp, which stands for expanded. And then we just toggle that here. And that's it. So let's see. And indeed, as we click there, the text is now hidden. And if we click on one of these, then it will show the text. And again, it will then hide it. Great. Now, next up, let's take care of not displaying the test here, but instead displaying some actual part of the text. Now, notice how here we have this prop, which says collapsed number of words. And so here, let's again specify a default, which is 20. But of course, it could also be any other value. So the idea here is that by default, when the text is collapsed, it will only display exactly this number of words. So only 20 words. But then you have, for example, this component here, which shows more words. So 20, this one should then actually be 10, so that this one here shows, in fact, more words. So by default, only 10 words should be displayed. So let's do that. So this is just some standard string and array manipulation. So we can simply split this string by the empty space, which will then give us an array. And then we can slice, or in other words, we can take all the elements from 0 all the way to collapsed number of words. So by default, we take the first 10 words. So from 0 to 10. And now this is still an array, and so we need to put it back to being a string. And then we also want to add at the end these 3 dots. Okay, and we could have used a template literal for this, but we can also just add them here at the end like this. So that works the same way. And so, as we click here, it shows all of them. And otherwise, it just shows exactly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 words plus these 3 dots. Beautiful. So that is already working. Now all we have to do is to take care of the styling of this button. So let's again specify an object here. Let's say button style. And then background, set it to none. Also no border. And again, this is necessary because we want this component here to be 100% reusable and standalone. So it cannot depend on any external styles. So let's also set a cursor to pointer. Let's give it some margin on the left side of 4 pixels, or let's say 6. And finally, we also want to give it a text color. And so this is where this button color prop comes into play. So let's grab that and place that here. And now all we have to do is to assign this here to the style prop. So style, button style, give it a save, and beautiful. So now this button looks more like text, but it is still missing some color. So let's by default add some blue color here, which is 1F09 CD. All right, and there we go. So the second one again is personalizing not only these 2 texts here on the button, but also the color and the number of words. And so that's why this one here looks quite different. And then again, this one here has this special styling here that's coming right from our CSS file in the form of this box class. Great, so this is working. And in fact, we are now basically finished. So this text expander component is now highly reusability, and it hides all the complexity from the user, so from the consumer of this component, which again is really nice and really important. So as the developer of this component, then we chose the public API, basically, and therefore allowed the user to customize it to their needs. And as always, we could have gone really crazy here and, for example, allow the user to place this button here in different places, like below or on the left side or here right at the very beginning. We could have allowed some more styling here of the entire component, or we could also allow the user to specify whether they want to see these 3 dots here or not. But again, that's just not necessary, because with this we found a nice balance. So this is the interface that we chose. Welcome to probably the most challenging section in this course, but also one of the most exciting ones and most rewarding ones. So up until this point, we have only focused on how React concepts and features work in practice. But now it's time to understand how things actually work internally inside React behind the scenes. So just like my other courses, this course also includes a really deep dive, which most students absolutely love. Because this information you're about to learn will not only make you a much better and more confident React developer, but it will also allow you to ace the most common React interview questions with all the confidence that you need in order to nail that job. And I would go as far as saying that this knowledge will actually put you right in the top 5% of all React developers. Now, again, this section is quite intense, and it should probably be in the advanced part of the course. But since there is so much important stuff that we need to talk about before moving on, I decided to place it right here. If at some point it becomes a bit too much, or if you become bored, please watch at least the final lecture of the section, where I'm briefly gonna summarize everything we covered. So that video really is a must watch. But anyway, without further ado, let's dive right in and uncover how React works. Now, before we go learn about how React works behind the scenes, let's quickly set up and walk through a small demo project that we're gonna need in a few lectures of this section. Now, this time around, we will do things a bit differently. So we will not create a new project using create React app. Instead, in the starter files, I already basically have that entire project for you to copy. So open up the starter files, and then here in this folder called How React Works, let's copy this entire starter folder. So copy all of this right into the folder where we are building our projects. And so then simply call it How React Works. So you see that here we actually have the source folder, we have the public folder, and also these other files that are always automatically created by create React app. But again, this time we are not doing that because, well, everything has been done already for us. And so now all we have to do is to take this folder, open it up in VS Code like this, and then we need to install all the packages. So the node modules folder, which is the folder where all the npm packages are installed, is of course not here. So all the libraries like React, React DOM, and so on, they are not here. So we need to install them. But that's fortunately very easy. So let's open up our terminal here. It's here in view. And well, that's really small here. And as always, make sure that you are in the correct folder. And then all we have to do is to say npm install or npm I for short. So hit enter, and then this will install all the packages that are necessary for this create React application. So it will get this information here from this package.json file. Okay, and we see that it's already done, and so we can now start this project. So just write npm start. And then in my case here, it's asking me if I want to run the app on another port. And so that's because I already had something running here on 3000. So that's basically the demo project, but let's close that for now actually. So just inspecting this, and then let's open up our app.js file as always. So this time around in this section, I gave you this already started project so that you can now get the experience of looking at a project where someone already started writing some code. So that's exactly what we have here. So some code here has already been written, and so you can now pretend that basically some other developer on your team wrote this. So it's extremely important that you be able to understand other developers' code, especially when you work on a team as a professional React developer someday. And so, before we now start this section, I just want us to quickly walk through this code here so I can explain you how it works on a high level, and then by doing so, you can see how we can effectively read code that we didn't write ourselves. So let's start in the app component here, and all that one does is to include the tabbed component. And it passes the content in there, which is simply this array of objects here. So pretty standard. Then the tabbed component has some state variable here, which indicates the current tab. So it seems like this is a number. And then down here, we can see that the active tab state is used to render this tab content component using as the content array at the position of the currently active tab. So this at here is basically modern JavaScript, which is the same as this here. So basically reading something out of an array. And that array, again, is this content array up here. So for example, if the state here was 2, then the content here in the tab would be 0, 1, 2. So it would be this object right here. All right, let's just put this back here to this more modern form. And then let's check out what this tab content here actually is. And it's also always a good idea to take a look at the component tree. And so let's make this here bigger. And so indeed we have the app, we have tabbed, and then we have the tab content in there. And of course we also have these 4 tabs, but we will leave them for a bit later. So in here, in the tab content, let's see what we have. So we get the tab item, which is basically the content that we're going to use here. So we can double click on that, and then we see where it has been used. So we see that we use item.summary and item.details. Then we also see that we have 2 state variables here. So that's show details and set show details. And again, by double clicking, VS Code will then highlight all of them. So here we can see that we're doing some conditional rendering with this show details. And so, yeah, by default, this is true. And then only in that case, we are displaying the item details. And then we change that state down here where we have set show details in this button. And so this here is exactly that button. So if we click that, then here the text disappears. So this paragraph right here disappears. Right? Then we also have these 2 buttons down here, but we see that they have no event handler attached. So if we click here, then nothing happens. Then finally, we also have those hearts here, and that's why we have this second state of likes. So you see that likes is indeed used here, and then this button here has the handle ink function. So this first one here, while the second button again has no handler. So here nothing happens, but here each time we click, basically 1 like is added there. And so that's because of the handle ink function. So what this one does is simply take the current likes and adding 1, and then setting that as the new likes state. Now notice how here we didn't use a callback function in order to set state based on the current state, but more about that later. So I think this component here is pretty clear. And so let's now go back here and see what these tabs here actually are. So here we have these 4 tabs, and notice how we are actually writing them one by one manually and not looping over some array. So our array has these 3 elements here, and so the first 3 elements, so these 3 are for those 3 objects, and then we have another one where the number is 3. But let's take a look at that a bit later. So here we have the num as a prop, we have the active tab, and we have the onClick prop. And as the onClick, we are simply passing the setActiveTab state setter function. Now let's go here into the tab and see what happens there. So basically a tab is just a button. So it's these buttons right here. And what happens when we click on this button is that the onClick function is called with the current number. So let's then actually go back to where these props are passed so that we can understand what the onClick and the num actually are. So onClick is setActiveTab, and num are these numbers here. And so basically when we click on this first tab, it means that the active tab will get set to 0. And the same down here. So when we click on this tab right here, then the active tab will get set to 1, which is exactly what we have here. Then, based on this state, as I explained in the beginning, we see that the tab content will be rendered, at least if that value is less or equal to. So if it's greater than 2, which happens in this case, then the different content will be displayed. So let's check that out. And so this one is simply this one div, which has a simple h4. Okay, so again, basically the goal of this other tab right here is just to display this different content component right here. So let's see that in action. And so, indeed, when we click on tab 2, you see that the content here changed. And so the title here and the text are exactly what we have here in this second object. And then the same here. So here we now have the third object. So the title and the text. And finally, the last one is for, well, for that different content. And you saw that down here, actually the component tree changed. All right. And here, if we wrote any other number, like 0, then of course, you see that the number changed here. So that is always the number plus 1, and we get then the very first object. So now it says React is a library for building UIs. So just like here. And also both of them are now marked active, which also happens inside that tab component. But of course, let's put it back to 2. And with this, I think it is pretty clear what this very small demo application does. But before you move on to the next lecture, make sure that you take some more time to analyze this code on your own so that you truly understand what exactly is happening here. It happens with your components as you use them. And also, this is a pretty common interview question. And so this topic is definitely worth learning about. And let's begin by taking another look at components. So components are what we write in order to describe a piece of the user interface. And a component is just a regular JavaScript function, but it's a function that returns React elements. So it returns an element tree. And we usually write these elements using the JSX syntax. Now, a component is a generic description of the UI. So we can essentially think of a component as a blueprint or a template. And it's out of this one blueprint or template that React then creates one or multiple component instances. Now, React does this each time that we use the component somewhere in our code. For example, the tab component that we saw in the last slide is used, so it is included 3 times in this app component. And so therefore 3 instances of tab are placed in a component tree, so in our actual application. Behind the scenes, this happens because React will call the tab function 3 times, so 1 time for each instance. So we can say that an instance is like the actual physical manifestation of a component living in our component tree, while the component itself is really just a function that we wrote before being called. And actually, it's each instance that holds its own state and props, and that also has its own life cycle. So basically, a component instance can be born, it can live for some time until it will eventually die. So it's a bit like a living organism, really. Now, in practice, we many times just use the terms component and component instance interchangeably. For example, we just say component lifecycle and not component instance lifecycle. And we also say that a UI is made up of components, not of component instances, even though instances would technically be more accurate. Okay, so just keep that in mind in the future when you read documentation or some Stack Overflow post or something like that. But anyway, as React executes the code in each of these instances, each of them will return 1 or more React elements. So, as we learned when we first talked about JSX, behind the scenes, JSX will actually get converted to multiple React.createElement function calls. Then, as React calls these createElement functions, the result will be a React element. So, a React element is basically the result of using a component in our code. It's simply a big, immutable JavaScript object that React keeps in memory. And we will take a look at this later in our code. But what is this object actually? Well, a React element basically contains all the information that is necessary in order to create DOM elements for the current component instance. And so it's this React element that will eventually be converted to actual DOM elements and then painted onto the screen by the browser. So based on all this, the DOM elements are the actual final and visual representation of the component's instance in the browser. And again, it's not React elements that are rendered to the DOM. React elements just live inside the React app and have nothing to do with the DOM. They are simply converted to DOM elements when they are painted on the screen in this final step. Okay, so this is the journey from writing a single component to using it multiple times in our code as a blueprint, all the way until it's converted to a React element and then rendered as HTML elements into the DOM. So I hope you found this interesting and useful, and if you did, then let's move on to the next video and take a look at all this in code. So as promised, let's now shortly look at component instances and React elements in our code. So what I want to do in this lecture is just a couple of quick experiments to show you some interesting things. So first off, we can actually look at a component instance simply by using the component and logging it to the console. So let's try that out. So actually right out here, we can write JSX like this. So let's use the different component or the different content component because this one doesn't have any state. All right. And if we run this, then we should see something in the console. And indeed, there it is. So as soon as React sees this right here, it will internally call the different content function and will then return this React element. So just like we learned in the previous video. So let's take a quick look at this, and while this is not really interesting, we can see that the type here is of different content. And so that's exactly the name of the component right here. We can also see that we didn't pass in any props, but which we actually could. So let's just do test equals 23. And so then we should see that right here. So now in the second one. And indeed, there it is. So again, this is what React internally use to then later create our DOM elements. Now, if you're wondering what this weird $$ type of thing here is, well, this is simply a security feature that React has implemented in order to protect us against cross-site scripting attacks. So notice how this is a symbol, and symbols are one of the JavaScript primitives which cannot be transmitted via JSON. Or in other words, this means that a symbol like this cannot come from an API call. So if some hacker would try to send us a fake React element from that API, then React would not see this type of as a symbol. Again, because symbols cannot be transmitted via JSON. And so then React would not include that fake React element into the DOM. So protecting us against that kind of attack. All right. But anyway, let's come back here and try something else. So if React calls our component internally when it renders them, so just as it did here in this previous line, then maybe you have wondered, why don't we just call components directly? So why should we write it like this when we could also write different content like this? So basically calling the function ourselves. Well, there is really nothing stopping us from doing so. So if we save this, then we actually get a result as well. Let's just reload here so that we only get these two outputs. So one output from here and one from here. So you see that even here in this case, we still got a React element like this. However, it is a very different one. So this one no longer has the type of different content, and instead it is a div, which is basically just the content of that component. So this div here is now the type of this React element. And we can also see that because the props include the class name of tab content. So what this means is that right now React does no longer see this as a component instance, and instead it just sees the raw React element, which is really not what we want. So when we write, or actually when we use a component, we want React to see the component instance and not the raw output element like this one. So never do this, what we did right here. And let's actually demonstrate this one more time, but now inside the component here. So after all this, let's enter JavaScript mode here, and then let's just call, or actually tab content. This time let's call tab content, and we can pass in props just like this. So we pass in an object, and then item, and then let's say content at 0. And, well, we got some errors here, but let's try to reload. And now this somehow works. So you see that actually we got a second tab content rendered down here. So it looks like this works, right? Well, not so fast. Let's check out our component tree here again. We need some more space. And so now you see that we still only have one tab content here in our component tree. And so this happened exactly because of what I explained before, which is that when we call a component directly like this, then React no longer sees it as a component instance. Now we can also see that the state that this component manages is actually now inside the parent state, or the parent component. So if we check out the tabbed component here, you see that it has the normal state that it had before, which is this active tab, but it also has some other hooks here, which come from tab content. So these two are the two hooks that are inside this component, but they don't really belong here. So we actually want them to be inside tab content and not inside, well, not here inside the tabbed component. So what this means, again, is that this is here not really a component because it cannot even manage its own state at this point. So for all these reasons, you should never ever do what we just did here, because this will create multiple problems, such as violating the rules of hooks that we will talk about later. So instead, as you already know, always render it inside the JSX, so just like this. And so here we just use the component, so basically this blueprint, like we have always been doing. And so then React calls the component and actually recognizes this as a component instance. All right. So let's reload here again, and then we are back to normal. All right. And here we can see one of those examples that we talked about in the previous lecture. So we wrote one tab component here. So this is like the blueprint, but then we have 4 component instances, each with its own state and its own props. We are now ready to finally learn about how exactly React renders our applications behind the scenes. Now there's so much to learn here that I split up this lecture into 3 parts. So it's this video and the next 2 ones. This one serves more as an overview, and then in the next 2 videos we're gonna go really deep into some React internals. And let's start with just a small recap, so that we're all on the same page. So as we build our applications, what we're really doing is building a bunch of components. We then use these components inside other components as many times as we want, which will cause React to create one or more component instances of each component. So these are basically the actual physical components that live in our application and hold state and props. Now, as React calls each component instance, each JSX will produce a bunch of react.createElement function calls, which in turn will produce a React element for each component instance. And so this React element will ultimately be transformed to DOM elements and displayed as a user interface on the screen. So we have a pretty good understanding of the initial part of this process, so of transforming components to React elements. However, what we don't understand yet is the second part of the process, so how these React elements actually end up in the DOM and displayed on the screen. Well, luckily for us, that is exactly what this series of lectures is all about. So, in this lecture, we're going to have a quick overview of each of the phases involved in displaying our components onto the screen. Then we're going to zoom into each of these phases to learn how the entire process works internally behind the scenes. So, this process that we're about to study is started by React each time that a new render is triggered, most of the time by updating state somewhere in the application. So state changes trigger renders, and so it makes sense that the next phase is the render phase. In this phase, React calls our component functions and figures out how it should update the DOM, so in order to reflect the latest state changes. However, it does actually not update the DOM in this phase, and so React's definition of render is very different from what we usually think of as a render, which can be quite confusing. So again, in React, rendering is not about updating the DOM or displaying elements on the screen. Rendering only happens internally inside of React, and so it does not produce any visual changes. Now, in all the previous sections, I've always used the term rendering with the meaning of displaying elements on the screen, because that was just easy to understand and it just made sense, right? However, as we just learned, the rendering that I used to mean is really this render plus the next phase. And speaking of that next phase, once React knows how to update the DOM, it does so in the commit phase. So in this phase, new elements might be placed in the DOM and already existing elements might get updated or deleted in order to correctly reflect the current state of the application. So it's really this commit phase that is responsible for what we traditionally call rendering, not the render phase. Okay? Then finally, the browser will notice that the DOM has been updated and so it repaints the screen. Now this has nothing to do with React anymore, but it's still worth mentioning that it's this final step that actually produces the visual change that users see on their screens. Alright, so let's now zoom into each of these different steps, starting with the triggering of a render. So there are only two ways in which a render can be triggered. The first one is the very first time the application runs, which is what we call the initial render. And the second one is a state update happening in one or more component instances somewhere in the application, which is what we call a re-render. And it's important to note that the render process really is triggered for the entire application, not just for one single component. Now, that doesn't mean that the entire DOM is updated, because remember, in React, rendering is only about calling the component functions and figuring out what needs to change in the DOM later. Now, again, this might seem confusing now, because earlier in the course, I made it seem as though React only re-renders the component where the state update happened. But that's because we were learning how React works in practice. And in fact, when we look at what happens in practice, it looks as if only the updated component is re-rendered. But now we are learning how React actually works behind the scenes. And so now we know that React looks at the entire tree whenever a render happens. Finally, I just want to mention that a render is actually not triggered immediately after a state update happens. Instead, it's scheduled for when the JavaScript engine basically has some free time on its hands. But this difference is usually just a few milliseconds that we won't notice. There are also some situations, like multiple set state calls in the same function, where renders will be batched, as we will explore a bit later. So, this is how renders are triggered, which is the easy part. What follows is the hard part, which is the actual rendering. And so let's learn all about that in the next video. Welcome back to probably the most complicated and most confusing lecture of the entire course. But I don't say this to scare you, because this might also be the most interesting and fascinating lecture of the course. Now, if you don't immediately understand 100% of what I'm going to teach you here, that's absolutely fine. So don't stress about it at all. Again, you can use React without knowing any of this stuff. But if you have a curious mind and feel the need to understand how React does what it does, then this video is for you. Now, before we even start, let's first go back to where we first learned about the mechanics of state. Remember this diagram? Well, back then, I told you that we can conceptually imagine this as a new view being rendered on the screen, so into the DOM. However, now we know that this was technically not true, because rendering is not about the screen or the DOM or the view. It's just about calling component functions. I also told you that whenever there is a re-render, React discards the old component view and replaces it with a brand new one. However, that's also technically not true. So the DOM will actually not be updated for the entire component instance. So if those things are not true, then let's now learn what happens instead and how rendering actually works. So in the previous lecture, we talked about how renders are triggered. In this lecture, we're going to learn all about how renders are actually performed in the render phase. So, at the beginning of the render phase, React will go through the entire component tree, take all the component instances that triggered a re-render, and actually render them, which simply means to call the corresponding component functions that we have written in our code. This will create updated React elements, which all together make up the so-called virtual DOM. And this is a term that you might have heard before, and so let's dig a little bit deeper now into what the virtual DOM actually is. So on the initial render, React will take the entire component tree and transform it into one big React element, which will basically be a React element tree like this one. And this is what we call the virtual DOM. So the virtual DOM is just a tree of all React elements created from all instances in the component tree. And it's relatively cheap and fast to create a tree like this, even if we need many iterations of it, because in the end, it's just a JavaScript object. Now, virtual DOM is probably the most hyped and most used term when people describe what React is and how it works. But if we think about it, if the virtual DOM is just this simple object, it's actually not such a big deal, right? And that's why the React team has really downplayed the meaning of this name, and the official documentation actually no longer mentioned the term virtual DOM anywhere. But I'm still using this term here because everyone still uses it, and also because it just sounds a bit nicer than React element tree. Also, some people confuse the term with the shadow DOM, even though it has nothing to do with the virtual DOM in React. So the shadow DOM is actually just a browser technology that is used in stuff like web components. But anyway, let's now suppose that there is going to be a state update in component D, which will of course trigger a re-render. That means that React will call the function of component D again and place the new React element in a new React element tree, so in a new virtual DOM. But now comes the very important part, which is this. Whenever React renders a component, that render will cause all of its child components to be rendered as well. And that happens no matter if the props that we pass down have changed or not. So, again, if the updated components returns one or more other components, those nested components will be re-rendered as well, all the way down the component tree. This means that if you update the highest component in a component tree, in this example component A, then the entire application will actually be re-rendered. Now this may sound crazy, but React uses this strategy because it doesn't know beforehand whether an update in a component will affect the child components or not. And so by default, React prefers to play it safe and just render everything. Also, keep in mind once again that this does not mean that the entire DOM is updated. It's just a virtual DOM that will be recreated, which is really not a big problem in small or medium-sized applications. Okay, so with this, we now know what this new virtual DOM here means, and so let's keep moving forward. So what happens next is that this new virtual DOM that was created after the state update will get reconciled with the current so-called fiber tree as it exists before the state update. Now, this reconciliation is done in React's reconciler, which is called fiber. And that's why we have a fiber tree. Then the result of this reconciliation process is going to be an updated fiber tree, so a tree that will eventually be used to write to the DOM. So this is a high-level overview of the inputs and the outputs of reconciliation. But of course, now we need to understand what reconciliation is and how it works. So you might be wondering, why do we even need stuff like the virtual DOM, a reconciler, and those fiber trees? Why not simply update the entire DOM whenever state changes somewhere in the app? Well, the answer is simple. Remember how we said that creating the virtual DOM, so the React element tree for the entire app, is cheap and fast because it's just a JavaScript object? Well, writing to the DOM is not cheap and fast. It would be extremely inefficient and wasteful to always write the entire virtual DOM to the actual DOM each time that a render was triggered. Also, usually when the state changes somewhere in the app, only a small portion of the DOM needs to be updated, and the rest of the DOM that is already present can be reused. Now, of course, on the initial render, there is no way around creating the entire DOM from scratch, but from there on, doing so doesn't make sense anymore. So, imagine that you have a complex app like udemy.com, and when you click on some button there, then show modal is set to true, which in turn will then trigger a modal to be shown. So in this situation, only the DOM elements for that modal need to be inserted into the DOM, and the rest of the DOM should just stay the same. And so that's what React tries to do. Whenever a render is triggered, React will try to be as efficient as possible by reusing as much of the existing DOM tree as possible. But that leads us to the next question. So, how does React actually do that? How does it know what changed from one render to the next one? Well, that's where a process called reconciliation comes into play. So reconciliation is basically deciding exactly which DOM elements need to be inserted, deleted, or updated in order to reflect the latest state changes. So the result of the reconciliation process is going to be a list of DOM operations that are necessary to update the current DOM with the new state. Now, reconciliation is processed by a reconciler, and we can say that the reconciler really is the engine of React. It's like the heart of React. So it's this reconciler that allows us to never touch the DOM directly, and instead simply tell React what the next snapshot of the UI should look like based on state. And as I mentioned before, the current reconciler in React is called fiber. And this is how it works. So during the initial render of the application, fiber takes the entire React element tree, so the virtual DOM, and based on it, builds yet another tree, which is the fiber tree. The fiber tree is a special internal tree where for each component instance and DOM element in the app, there is one so-called fiber. Now, what's special about this tree is that unlike React elements in the virtual DOM, fibers are not recreated on every render. So the fiber tree is never destroyed. Instead, it's a mutable data structure, and once it has been created during the initial render, it's simply mutated over and over again in future reconciliation steps. And this makes fibers the perfect place for keeping track of things like the current component state, props, side effects, list of used hooks, and more. So the actual state and props of any component instance that we see on the screen are internally stored inside the corresponding fiber in the fiber tree. Now, each fiber also contains a queue of work to do, like updating state, updating refs, running registered side effects, performing DOM updates, and so on. This is why a fiber is also defined as a unit of work. Now, if we take a quick look at the fiber tree, we will see that the fibers are arranged in a different way than the elements in the React element tree. So instead of a normal parent-child relationship, each first child has a link to its parent, and all the other children then have a link to their previous sibling. And this kind of structure is called a linked list, and it makes it easier for React to process the work that is associated with each fiber. We also see that both trees include not only React elements or components, but also regular DOM elements, such as the H3 and button elements in this example. So both trees really are a complete representation of the entire DOM structure, not just of React components. Now, going back to the idea that fibers are units of work, one extremely important characteristic of the fiber reconciler is that work can be performed asynchronously. This means that the rendering process, which is what the reconciler does, can be split into chunks, some tasks can be prioritized over others, and work can be paused, reused, or thrown away if not valid anymore. Just keep in mind that all this happens automatically behind the scenes. It's completely invisible to us developers. There are, however, also some practical uses of this asynchronous rendering, because it enables modern so-called concurrent features like suspense or transitions starting in React 18. It also allows the rendering process to pause and resume later so that it won't block the browser's JavaScript engine with too long renders, which can be problematic for performance in large applications. And again, this is only possible because the render phase does not produce any visible output to the DOM yet. Okay, so at this point we know what the fiber reconciler is and how the fiber tree works. But now it's time to talk about what fiber actually does, which is the reconciliation process. And the best way to explain how reconciliation works is by using a practical example. So let's take the virtual DOM and the corresponding fiber tree from the last slide, which correspond to this piece of code right here. So in the app component, there is a piece of state called showModal, which is currently set to true. And you can pause the video here to analyze it, but it's not really necessary. So let's say now that the state is updated to false. This will then trigger a re-render, which will create a new virtual DOM. And in this tree, the modal and all its children are actually gone, because they are no longer displayed when showModal is not true. Also, all remaining React elements are yellow, meaning that all of them were re-rendered. And do you remember why that is? That's right, it's because all children of a re-rendered element are re-rendered as well, as we just learned a few minutes ago. But anyway, this new virtual DOM now needs to be reconciled with the current fiber tree, which will then result in this updated tree, which internally is called the work in progress tree. So whenever reconciliation needs to happen, Fiber walks through the entire tree step by step and analyzes exactly what needs to change between the current fiber tree and the updated fiber tree, based on the new virtual DOM. And this process of comparing elements step by step based on their position in the tree is called diffing. And we will explore exactly how diffing works a bit later in the section, because that's actually pretty important in practice. But anyway, let's quickly analyze our updated fiber tree, where I marked new work that is related to DOM mutations. So first, the btn component has some new text, and so the work that will need to be done in this fiber is a DOM update. So in this case, swapping text from height to rate. Then we have the modal, overlay, h3, and button. So these were in the current fiber tree, but are no longer in the virtual DOM, and therefore they are marked as DOM deletions. Finally, we have the interesting case of the video component. So this component was re-rendered because it's a child of the app component, but it actually didn't change. And so as a result of reconciliation, the DOM will not be updated in this case. Now, once this process is over, all these DOM mutations will be placed into a list called the list of effects, which will be used in the next phase, so in the commit phase, to actually mutate the DOM. Now, what I showed you here was actually still a bit oversimplified, if you can believe that. But I think that this is more than enough for you to understand how this process works. Okay, so that was quite a deep dive. But now we're back here in the high-level overview of the render phase. So we learned that the result of the reconciliation process is a second updated fiber tree, plus basically a list of DOM updates that need to be performed in the next phase. So React still hasn't written anything to the DOM yet, but it has figured out this so-called list of effects. So this is the final result of the render phase, as it includes the DOM operations that will finally be made in the commit phase, which is the topic of our next video. So if you don't want to break the flow, then let's move on there right now. Welcome back to part 3 of how rendering works behind the scenes. So we just finished learning about the render phase, which resulted in a list of DOM updates. And this list will now get used in the commit phase. Now, technically speaking, the current work in progress fiber tree also goes into this commit phase, but let's keep it simple here. So these are more conceptual diagrams so that we can understand what is happening, not a 100% accurate description of the algorithms inside React. All right. But anyway, as you know by now, the commit phase is where React finally writes to the DOM. So it inserts, deletes, and updates DOM elements. You will sometimes also read that React flushes updates to the DOM in this phase. So basically, React goes through the effects list that was created during rendering and applies them one by one to the actual DOM elements that were in the already existing DOM tree. Now, writing to the DOM happens all in one go. So we say that the commit phase is synchronous, unlike the rendering phase, which can be paused. So committing cannot be interrupted. And this is necessary so that the DOM never shows partial results, which ensures that the UI always stays consistent. In fact, that's the whole point of dividing the entire process into the render phase and the commit phase in the first place. It's so that rendering can be paused, resumed, and discarded, and the result of all that rendering can then be flushed to the DOM in one go. Then, once the commit phase is completed, the work in progress fiber tree becomes the current tree for the next render cycle. That's because, remember, fiber trees are never discarded and never recreated from scratch. Instead, they are reused in order to save precious rendering time. And with that, we close up the commit phase. The browser will then notice that the DOM has been changed, and as a result, it will repaint the screen whenever it has some idle time. So this is where these DOM updates are finally made visible to the user in the form of an updated user interface. Now, I'm not going to go into how this phase works, because this is really more about how browsers work internally and not React. However, there's still one more thing that we need to talk about. So, the browser paint phase that we just mentioned is of course performed by whatever browser the user is using. And the render phase is obviously performed by the React library. But what about the commit phase? We would think that it's also done by React, right? But actually, that's not true. It's actually a separate library that writes to the DOM, and it's called React DOM. So, not very creative, but that's just what it's called. So, in fact, React itself does never touch the DOM, and it actually has no idea where the result of the render phase will actually be committed and painted. So React only does the render phase, but not the commit phase. And the reason for that is that React itself was designed to be used independently from the platform where elements will actually be shown. And therefore, React can be used with many different so-called hosts. Now, up until this point, we have only ever thought of React in conjunction with the DOM, because we usually use it to build web application. And in 90% of the cases, that's actually what we do with React. But the truth is that React is used with other hosts as well. For example, we can actually build native mobile applications for iOS and Android using React Native. Or we can build videos with React using a package called Remotion. And we can even create all kinds of documents like Word or PDF documents, Figma designs, and many more using different so-called renderers. Now, if we think about this, renderer is actually a pretty terrible name, because according to React's own terminology, renderers do not render, but they commit the results of the render phase. But I think that this renderer name comes from a time before React divided the render and the commit phase into two separate phases. And so they chose this term of renderer because it fits with the common sense definition of rendering. But anyway, in all these situations, the result of the render phase is not really a list of DOM updates, but a list of updates of whatever elements are used in the host that's being used. So the term virtual DOM then also doesn't really make much sense when we look at it from this angle, which is just one more reason why the React team prefers the more accurate name of React Element Tree. Now, all these details are, of course, not really that important. What I want you to retain from this slide is that the React library is not the one responsible for writing to the DOM, because the DOM is just one of many hosts to which React apps can be committed, so to which they can be output, basically. And for each of these hosts, we have a different package that we can use. And that's why in our index.js file, we always import both React and React DOM, right? And so now you know the exact reason why we have to do that. All right, so after looking at all these phases in so much detail, let's do a quick recap here and summarize everything that we have learned. So, the whole process of rendering and displaying a React application on the screen starts with a trigger, which can either be the initial render of the app or a state update in one of the component instances. This then triggers the render phase, which does not produce any visual output. So this phase starts by rendering all component instances that need a re-render. And rendering in React simply means to call the component's functions. This will create one or more updated React elements which will be placed in a new virtual DOM, which is actually simply a tree of React elements. Now, what's really important to remember about this process is that rendering a component will cause all of its child components to be rendered as well, no matter if props changed or not. This is because React doesn't know whether children have been affected by the parent re-rendering or not. Now, next up, this new virtual DOM needs to be reconciled with the current fiber tree. so with the representation of the element tree before the state update. This is necessary because it would be slow and inefficient to destroy and rebuild the entire DOM tree each time that something on the screen must be updated. Instead, reconciliation tries to reuse as much of the DOM as possible by finding the smallest number of DOM updates that reflect the latest state update on the screen. Now, this reconciliation process is done using a reconciler called fiber, which works with a mutable data structure called the fiber tree. And in this tree, for each React element and DOM element, there is a fiber. And this fiber holds the actual component state, props, and a queue of work. After reconciliation, this queue of work will contain the DOM updates that are needed for that element. Now, the computation of these DOM updates is performed by a diffing algorithm, which step by step compares the elements in the new virtual DOM with the elements in the current fiber tree, so to see what has changed. So, the final result of the render phase, so basically of this reconciliation and diffing process, is a second updated fiber tree as well as a list of all necessary DOM updates. Now, it's important to note that the render phase is asynchronous, so Fiber can prioritize and split work into chunks and pause and resume some work later. And this is necessary for concurrent features and also to prevent the JavaScript engine to be blocked by complex render processes. But anyway, the output of the render phase, so the list of DOM updates, will finally actually be written to the DOM in the commit phase. So in this phase, a so-called renderer like React DOM will insert, delete, and update DOM elements so that we end up with an updated DOM that reflects the new state of the application. And unlike the render phase, the commit phase is actually synchronous. So all the DOM updates are performed in one go in order to ensure a consistent UI over time. Now, finally, once the browser realizes that the DOM has been updated, it starts a new browser paint in order to visually update the user interface on the screen. Okay, and there you have it. This is how, in a nutshell, we go from updated React elements all the way to an updated DOM and user interface on the screen. So it sure was a really long process, but I hope that you have learned a lot along the way and that it wasn't too overwhelming. And again, keep in mind that you can build React apps without being aware that most of these things even exist. Now, some of these things do have practical implications and also implications for performance, but we will talk about those later. For now, just take a breath, as this was probably the hardest part of the entire course. So, good job of sticking with it to the end, and let me know what you think of this series of lectures in the Q&A. In the lecture about the render phase, we left out one critical piece, which was the diffing algorithm that is part of the reconciliation process. So we mentioned diffing back then, but we didn't really go into how diffing works. And since that's really important, let's do that now. So diffing is, first of all, based on two fundamental assumptions. The first one is that two elements of different types will produce different trees. The second assumption is that elements with a stable key, so a key that is consistent over time, will stay the same across renders. Now, these assumptions may seem pretty obvious, especially the first assumption, but they allow the algorithm to be orders of magnitude faster, going, for example, from 1 billion operations per 1,000 processed elements to just 1,000 operations. Now, remember that diffing is comparing elements step by step between two renders based on their position in the tree. And there are basically two different situations that need to be considered. First, having two different elements at the same position in the tree between two renderers. And second, having the same element at the same position in the tree. So those are the only two situations that matter. And so let's now start with the first situation. So let's say that at some point an application is re-rendered. And in the diffing process, we find that an element has changed in a certain position of the tree. Now here we're actually not looking at a tree, but at the JSX code which leads to that tree, because I find that it's a bit easier to understand this way. But anyway, in the case of a DOM element changing like this, changing simply means that the type of the element has changed, like in this example from a div to a header. So in a situation like this, React will assume that the element itself plus all its children are no longer valid. Therefore, all these elements will actually be destroyed and removed from the DOM. And that also includes their state, which is really important to remember. So as we see in this example, both the div element and the search bar component will be removed from the DOM and will then be rebuilt as a header with a brand new search bar component instance as a child. So if the child elements stayed the same across renders, the tree will actually get rebuilt. But it gets rebuilt with brand new elements. And so if there were any components with state, that state will not be recovered. So this effectively resets state. And this has huge implications for the way that React applications work in practice. And that's why we will see some examples of this behavior in the next lecture. Now, everything we just learned works the exact same way for React elements. So basically for component instances, as we can see in this second example. So here the search bar component changed to a profile menu component, and therefore the search bar is again completely destroyed, including its state, and removed from the DOM. Okay, so this is the first situation. The second situation is when between two renders we have the exact same element at the same position in the tree. And this one is actually way more straightforward. So if after a render an element at a certain position in the tree is the same as before, like in these examples right here, the element will simply be kept in the DOM. And that includes all child elements and, more importantly, the component's state. Now this may sound pretty obvious, but it actually has some important implications in practice. So, again, the same element at the same position in the tree stays the same and preserves state. And it works like this for DOM elements and for React elements as well. Now, looking at these examples, we actually see that something has changed. However, it was not the element type that has changed, but simply the class name attribute in the div and the weight prop in the search bar component. And so what React is going to do is to simply mutate the DOM element attributes, and in the case of React elements, it will pass in the new props. But that's it. So React tries to be as efficient as possible, and so the DOM elements themselves will stay the same. They are not removed from the DOM, and even more importantly, the state will not be destroyed. Now, sometimes we actually don't want this standard behavior, but instead to create a brand new component instance with new state. And so that's where the key prop comes into play, as we will learn about after seeing these rules that we just learned about in action. In this lecture, I just want to quickly demonstrate the diffing rules that we just learned in our project, so that you can see that they actually do have a practical effect in the real world. So let's start by examining a bit better what happens as we use this tab component. So again, here we have this button that when we click will hide that paragraph, right? And also when we click here, then we update the state and the likes number increases. So that's what happens in this tab. But now watch what happens when we go to another tab. So you see that the text is still hidden and the number of likes is still at 4. So what this means is that the state of this tab component instance has been preserved. Now, if we hadn't learned about this in the previous section, then this would look really strange, right? Because we would expect that whenever we go to a new tab, that the state would be reset. But that's not what happens. So as we click around here, the only thing that happens is that this title here is changed. I mean, this text down here also changes, but it stays invisible. So here the text changed, and the state again stayed the same. And the same here for the number of likes. So what is actually happening? Well, basically each time that we click on one of these tabs, the tab component down here is re-rendered. However, as we can see down here in this component tree, as we keep clicking around, we see that the tab content component instance always stays in the exact same position in the tree. And so with this, we are now in the situation that we learned in the previous lecture, where we have the same element, so in this case, the same component in the same position. And so because of that, the state is preserved across renders. So just like we learned before. So again, as we keep clicking around these tabs here, this component instance here is actually not destroyed. So it stays in the DOM, and the only thing that changes is the props that it receives. So of course, the props will change. So where is that? Right here. So you see that now as I click here, then of course, down here, the prop will have changed. But that's the only thing that changes. So the state, again, remains completely unchanged. But what if we now click on this tab number 4? So as we can see in our code, in this case, so when the tab num is 3, actually this different content component will be rendered, right? And so let's see what's going to happen. So we have number 4 here, and we have the text closed. So now we click here, and immediately we see that we get a completely different component instance right here. So it's still in the same position of the tree, but it's no longer tab content, but different content. And so now when I go back, watch what happens. So now the state has actually been reset. And so that's because the tab content that we had here before has been completely destroyed and removed from the DOM in the meantime. So while we were at the different content. And so that's why I placed this string here, which says that this is a different tab, and so it resets state. And so indeed, if we keep going here, maybe we hide this, then again, when we go here and we go back, then the state has been reset. Because again, in the meantime, this component here has disappeared, and with it, its state. So this is a direct consequence of the diffing rules that we just learned about. And so this means that these rules are very important actually in practice. So you can see the situation happening all the time. And actually we saw the exact same thing in our eat and split application. But don't worry about that for now, because we will come back to that app actually in a few lectures from now. Now, sometimes, of course, we do not want this behavior. So actually, just as I was saying in the last lecture as well. So for example, let's say I hide the details here, but then I actually expect that when I go to a new tab, that it starts again with the default. So with this opened again. So again, usually this is not what we want. And so let's take a look at how we can solve this in the next video. Remember how I mentioned the key prop when we talked about how the diffing algorithm works. And so let's now take some time to look at the key prop in detail in order to learn what it does and when we need to use it. So, the key prop is a special prop that we can use to tell the diffing algorithm that a certain element is unique. And this works for both DOM elements and React elements. So, in practice, this means that we can give each component instance a unique identification, which will allow React to distinguish between multiple instances of the same component type. Now, that's all great, but why do we actually need this? Well, remember that the second assumption of the diffing algorithm is that whenever an element has a stable key, so a key that stays the same across renders, the element will be kept in the DOM, even if the position in the tree has changed. And this is the whole reason why we should use the key prop in lists, as we have already done so many times throughout the course. And so in the next slide, you will finally learn why we need to do that. On the other hand, when the key of a certain element changes between renders, the element will be destroyed and a new one will be created in its place, even if the element's position in the tree is exactly the same as before. And so this is great to reset state, which is the second big use case of the key prop. But let's go back to the first big use case of the key prop, which is to use keys in lists. And let's start by considering this example without keys. So here we have a list with two question items, which clearly have no key prop. But let's see what happens when we add a new item to the top of the list. Well, the two list items that we already had are clearly still the same, but they will now appear at different positions in the React element tree. They are no longer the first and second children, but now they are the second and the third children. So we basically have the same elements, but at different positions in the tree. And so according to the diffing rules that we learned earlier, these two DOM elements will be removed from the DOM and then immediately recreated at their new positions. And this is obviously bad for performance, because removing and rebuilding the same DOM element is just wasted work, right? But the thing is that React doesn't know that this is wasted work. Of course, we developers intuitively know that these two elements are actually the same as before, but React has no way of knowing that. But what if we could actually change that? Well, that's where keys come into play. Because remember, a key allows us developers to uniquely identify an element. So we can give React that information that it doesn't have on its own. And so now, when we add a new item to the top of the list, the two original elements are of course still in different positions of the tree, but they do have a stable key. So a key that stays the same across renders. So that's Q1 and Q2 in this case. And so, according to the diffing rules, these two elements will now be kept in the DOM, even though their position in the tree is different. So they will not be destroyed, and the result will be a bit more of a performant UI. Now, of course, you won't really notice this difference on small lists, but it will make a huge difference when you have a really big list with thousands of elements, which can actually happen in some applications. So, in summary, always use the key prop when you have multiple child elements of the same type. So just like the question elements in this example. And you already knew that you should do that because, well, otherwise React will complain and give us a warning. But now you hopefully understand exactly why you need to do it. All right. So we looked at the use case for a stable key, and so now let's look at the use case for a changing key, which is used to reset state in component instances. Now here we don't need a big code example because we will do this in practice in the next lecture, but let me just show you what I mean by resetting state. So let's say we have this question inside question box and we pass in this object as a prop. Now, the question component instance has an answer state, which right now is set to React allows us to build apps faster. But now let's imagine that the question changes to this one. So we still have the same element at the same position in the tree. All that changed was the question prop. So what do you think will happen to the state in this case? Well, let's remember one of the diffing rules, which says that if we have the same element at the same position in the tree, the DOM element and its state will be kept. Therefore, what's gonna happen is that the state of question will be preserved. So it will still show the answer that was in the component state before. But that answer is of course completely irrelevant to this new question, right? So it doesn't make any sense to keep this state around here. So basically what we need is a way to reset this state. And as you can guess, this is where the key prop comes into play once again. So now we have a key of Q23 in this first question, which allows React to uniquely identify this component instance. Then, when a new question appears, we can give it a different key. And so, by doing this, we tell React that this should be a different component instance, and therefore that it should create a brand new DOM element. And the result of doing this is that the state will be reset, which is exactly what we need in this situation in order to make this small app work in a logical way. So, whenever you find yourself in a position where you need to reset state, just make sure that you give the element a key and that the key changes across renders. Now, this actually isn't necessary very often, but you will sometimes find yourself in this situation. And so when this happens, it's very important to know that this is the solution. Okay, and to make this even more clear now, let's go back to our small project. So let's now use what we just learned about the key prop to our advantage and fix our tabbed component. So as we have just explored previously, as we change the state here in this tab component, that state will be preserved as we re-render that component. And so again, that's because this component is exactly of the same type as before, so it stays the same element between renders, and it also stays in the exact same place in the component tree. And so therefore, its state is not reset. It is only reset when we change to a different component type here. So now that's different content, and then change back. So now in the meantime, our state was lost. But if we do this and then change here, then the state is preserved across renders. Now, as we were saying also before, this is usually not what we want. And so let's now use the key prop to change this. And actually, it is extremely easy. All we have to do is to give this tab content here a different key for each of the tabs, basically. So then each time that this tab content component here is re-rendered, it will get a different key. And so then React will see it as a unique component instance. And therefore, then the old one will be destroyed and the state will be reset. So just as we just learned in the previous lecture. And so let's do that. So let's give it a key that will change between renders. So something unique here. So let's take the content object again at the current position, and then let's, for example, take the summary. All right, so here we do not have like a unique ID, but we can see that the summary is always different. And so, as soon as the tab content component will be re-rendered, then not only this item here will change, but also the key. And so we are then in that situation where the key changes across renders. And again, that will then reset our state. So let's hide this here. Let's improve our likes. And then let's go to another tab. And beautiful. So you see that our component state has indeed been reset. And again, that's just because React now views this as a completely different instance of tab content. And we can see that here because now our DevTools display this key. And when we move here, then we get another one. And so, yeah, this is exactly how React now makes each of these tab contents here unique and distinguishes between them. Yeah, so this is really nice, really helpful. And so you really need to understand what just happened here and then keep it in mind for future situations. So I actually still remember personally when I first learned about the power of the key prop here. So this was actually a key learning moment for me. So it was really eye-opening. And so I hope I could provide the same experience here for you. So this key prop here, it looks very simple, but it can make a huge difference. And so let's now actually also use this key prop in the Eat and Split app that we built before. So let's do that in the next video. So, as I was just saying, let's now go back to our Eat and Split app to fix one problem that we have left in that application. So, let's come to our desktop and then grab the project folder and open it in VS Code. Okay, and so now we have two VS Code windows open, and we will also start two React apps at the same time. So let's just write npm start, hit enter, and then it will ask you to use another port instead. And so that's simply because you're already running one app here in this other port. And of course, each one can only have one app running. So just hit enter or Y as you reached this step, and then you will see your application pop up right here. Let's get a bit more space. And then let me show you the problem that we actually left here. So let's say that we typed some values in here, and then we moved to another friend. So here we have exactly the same problem as before. So as we select another friend, the only thing that changes is really the props that is being passed here into this component. So let's check out the name of that component, as I don't remember it. So yeah, it's this form split bill. So this one receives the selected friend object. But as you see here, as we change, nothing changes in the DOM tree. And so across these re-renders, exactly the same component is rendered in exactly the same position of the tree. So just like before. And so therefore, the state is not reset across renders. But also, just like before, this is not the behavior that we would expect in this application, right? So if suddenly we move from one friend to the other one, we would certainly expect that the bill value here should be reset. So how can we do that? Well, let's see where we are using this form split bill. So that should be somewhere here in the app, probably. So yeah, here it is. And so now we basically need to make each component instance here unique, so that each time that it is rendered with a new friend, React will see this as a completely new component instance. And as you already know, the way we do that is by providing a key that will actually change across the re-renders. So here we can use the selected friend.id, I guess. So let's just see if they actually have an ID. And yeah, they have. So we could also use the name here, really. So those are also different, but the ID is really a unique identifier. So let's see. So we are at Sarah, And so therefore, let's see down here. So here we see that the key now is 933 whatever. And so let's move to another friend. And there we go. So we fixed our problem because now the component instance has another key. And so therefore it is a completely unique instance right now. Great. And that's actually it. So that's all we have to do here. So let's close this one and let's also close this. So we are finished. We are back in our project that we were working on before. And so, yeah, there's nothing left to do. And so let's move on right to the next lecture. In order for the rendering process to work in the way that we just learned before, our render logic needs to follow some simple rules. So let's look at these rules in this lecture. But first of all, what actually is render logic? Well, in order to understand that, let's actually take a look at the two types of logic that we can write in React components. So that's render logic and event handler functions. So render logic is basically all the code that lives at the top level of your component functions and that participates in describing how the view of a certain component instance should look like. So in this code example, there is a lot of render logic. So we have these two lines of code at the top level, and then also the return block where our component returns its JSX. So these describe exactly how the component will be displayed on the screen. However, if we look closely, we can identify yet another piece of render logic here, even though this code is actually inside a function. So as you can see in the return block, the code there is actually calling this createList function. And therefore, that logic also participates in describing the component view. And so it's also render logic. So basically, render logic is all the code that is executed as soon as the component is rendered. So each time that the function is called. Now, moving on to event handler functions, those are very easy to identify. So they're basically pieces of code that are executed as a consequence of the event that the handler is listening to. So in our example, we have this line of code that essentially registered handle new answer for the change event, and therefore handle new answer is our event handler function. And this is of course nothing new at this point. So we have done this many times in the course, right? But it's still important to differentiate between these two types of logic because they do actually do fundamentally different things. So while render logic is code that renders the component, event handlers contain code that actually does things. So basically code that makes things happen in the application. So event handlers contain things like state updates, HTTP requests, reading input fields, page navigation, and many more. So all things that basically change and manipulate the application in some way. Now, why is this all so important? Well, it's important because React requires that components are pure when it comes to render logic in order for everything to work as expected. But what does pure actually mean? To answer that, let's have a quick refresher on functional programming principles, which are quite important in React in general. And let's start with side effects. So a side effect happens whenever a function depends on any data that is outside the function's scope. Or even more importantly, whenever a function modifies data that is outside its scope. And I like to think as a side effect as a function's interaction with the outside world. For example, this function is mutating an outside object, and so this is clearly a side effect. Other examples of side effects are HTTP requests, writing to the DOM, setting timers, and more. The other important functional concept is pure functions, which are basically functions without side effects. So basically, these are functions that do not change any variable outside their scope. Also, when we give a pure function the same input, it will always return the same output. For example, this function is clearly a pure function, because if we give it the same argument r, it will always give us the area of the circle based on that r value. So the output only depends on the inputs, which makes this function predictable. This other function right here, on the other hand, is completely unpredictable, because it returns a string that contains a date, and that date changes every second. So in this case, even if we give the function the same input, the output will always be different, because the date will always be different, and therefore this is an impure function. And the same is true for the second function. So notice how this function mutates an outside variable, which of course makes this function impure as well. Now, calling functions impure makes it sound as if side effects are somehow bad, but that's actually not true. So side effects are not bad in themselves. In fact, if we think about it, any program can only be useful if it has some interaction with the outside world at some point, right? Like a web application that never fetches any data or never writes to the DOM is just completely useless. However, in order to make useful and bug-free applications, we need to know when and how to create side effects, which brings us back to React and its rules for render logic. And essentially, there's just one big rule, which is that components must be pure functions when it comes to render logic. This means that if we give a certain component instance the same props, so the same input, then the component should always return the exact same output in the form of JSX. In practice, this means that render logic is not allowed to produce any side effects. So, in other words, the logic that runs at the top level and is responsible for rendering the component should have no interaction with the outside world. This means that render logic is not allowed to perform network requests, to create timers, or to directly work with the DOM API, for example, listening to events using add-event-listener. Now, according to what we learned previously, render logic must also not mutate objects or variables that are outside the scope of the component function. And this is actually the reason why we cannot mutate props, which, remember, is one of the hard rules of React. And so now you know why that rule exists. It's because doing so would be a side effect, and side effects are not allowed. Finally, we really cannot update state or refs in render logic. And updating state in render logic would actually create an infinite loop, which is why we can never do that. State updates are technically not side effects, but it's still important for them to be on this list. Now, there are other side effects that are technically not allowed as well, but that we create all the time, like using console.log or creating random numbers. So these are clearly interactions with the outside world, but they don't seem to do any harm, and so we can safely keep doing them. Alright, but now you might be wondering, if all this stuff is not allowed, then how will I ever be able to make an API call to fetch some data? Well, keep in mind that these side effects are only forbidden inside render logic. This means that you have other options for running your side effects. First of all, we saw earlier that event handler functions are not render logic, and therefore side effects are allowed and actually encouraged to be used inside these functions. And second, if we need to create a side effect as soon as the component function is first executed, we can register that side effect using a special hook called useEffect. But we will learn all about that in the next section. For now, let's move on to another super important topic, which is state update batching. So we have dived really deep into some aspects of the render phase, like the rules for render logic and how the keyprop works. But now let's take one step back and go back to one very important aspect of the first triggering phase, which is the fact that state updates are batched. So in that first lecture about how rendering works, we had this sentence, which says that renders are not triggered immediately. And so in this lecture, I want to focus on this part, which says that there is also batching of multiple set state calls. Now, as always, the easiest way of explaining difficult concepts is by using a small code example. So here we have 3 pieces of state defined using the useState hook, and we also have a button in the user interface. Then, whenever there is a click on the button, the event handler function named reset is called. In this function, the 3 pieces of state answer, best, and solved are basically reverted back to their original state. And therefore, this function is called reset. Now, actually, this is the part that interests us in this lecture. And so let's now focus only on the event handler function. Now, what I want to do here is to analyze how these 3 pieces of state are actually updated behind the scenes. So we might think that as React sees the setAnswer function call, it would update the state to the empty string as requested, and then trigger a re-render and the commit phase. Then it would move on to the next line and do the same thing again. And finally, do the entire thing one more time for the 3rd state update. So intuitively, we would think that if there are 3 state variables being updated in this event handler, then React would re-render 3 times, right? However, this is actually not how it works. So this is not how React updates multiple pieces of state in the same event handler function. Instead, these state updates will actually get batched into just one state update for the entire event handler. So updating multiple pieces of state won't immediately cause a re-render for each update. Instead, all pieces of state inside the event handler are updated in one go. So they are batched, and only then will React trigger one single render and commit. And conceptually, it makes sense that React works this way, because if we're updating these pieces of state together, it probably means that they should just represent one new view, and therefore React only updates the screen once. So if these state updates belong together, it really wouldn't make much sense to update the screen 3 times. Doing so would also create 2 wasted renders, because we're not interested in the first 2 renders, only the final one, which already contains all the 3 state updates. Therefore, the fact that React automatically batches state updates in this way is yet another performance optimization that React gives us out of the box. Now, batching state updates is extremely useful, but it can also have surprising results. So let's turn our attention to this line of code now, where we reference the answer state variable right after updating it. So what do you think will be the value of this variable at this point? Well, let's try to think about this. So remember that component state is stored in the fiber tree during the render phase. Now at this point in the code, the render phase has not happened yet. So React is still reading the function line by line to figure out what state needs to be updated. But it hasn't actually updated the state yet, and it also hasn't re-rendered yet. That's the whole point of batching state updates in the first place, right? So what this means is that at this point of the code, the answer variable will still hold the current state, so the state before the update, even though we already told React to update it. So at this point, we say that our state is stale, meaning that the state is no longer fresh and updated. Because, in fact, a state update will only be reflected in the state variable after the re-render. And so, for this reason, we say that updating state in React is asynchronous. And again, it is asynchronous because React does not give us the updated state variable immediately after the setAnswer call, but only after the re-render has happened. Now, the same thing is also true whenever there is only one piece of state being updated. So, no matter how many state variables are being updated, the updated state is only available after the re-render, not immediately. Now, sometimes we actually do need the new value immediately after updating it. And in the case that we need the new value in order to update the same state again, or in other words, if we need to update state based on a previous state update in the same event handler, we can pass a callback function into the setState function instead of a single value. And we have actually done this in practice all the time, right? Now, so far we have only talked about batching in event handler functions like our reset function. That's because before React 18, React only did automatic batching in event handlers, but not in situations that happen after a browser event has already happened. However, there are certain very important situations in which we do need to update state long after a browser event, like a click, has happened. Examples of that are timeouts and promises. For instance, we might want to run our reset function only a second after a click event, or we might want to run it after some data has been fetched. So it would be nice to also have automatic batching in those situations to improve performance, right? Well, that's actually one of the important features that React 18 gave us. So before React 18, if this reset function was called by a timeout or by a promise, state updates inside the function would not be batched. Instead, in these situations, React would actually update the state variables one by one, and therefore, in this case, render 3 times. Now, another case is handling native events using DOM methods such as addEventListener, where state updates also used to not be batched, but now they are. So again, if you're using the latest React version, you will now get automatic batching all the time, everywhere in your code. And if, for some reason, you're working with an older version of React, maybe at your work, it's important that you know that batching used to work in a different way before version 18. Now, there are also some extremely rare situations in which automatic batching can be problematic. So if you ever find yourself in a situation like that, you can just wrap the problematic state update in a React DOM.flushSync function, and React will then exclude that update from batching. But you will most likely never need this. I'm just mentioning this here so that you know that it exists. Okay, and that's it about state update batching. It turned out to be a bit longer than I thought, but as always, there's just so much interesting stuff to learn, and so I hope that you don't mind at all. But in any case, let's quickly go to the next video so I can show you some of this in practice. Alright, so let's move back to our project and see how React batches state updates in practice and how this state updating is in fact asynchronous. So let's come down here to our tab content component and then let's play around a little bit with the states that we have here. And first of all, I want to now implement the functionality of this undo button here. So this undo will basically undo or reset the 2 states that we have here. So this one and this one. So let's write a simple function, handle undo, and then what it does is set show details back to true and set the likes back to 0. And then let's use that handler right here. So easy enough, handle undo, and yeah, that works great. So as we just learned in the previous lecture, inside of this event handler function here, these two state updates are batched. So they will only cause one component re-render. Now, how can we actually prove that? Well, one simple way is to log something to the console here. So let's say render, and so then each time that the component gets re-rendered, and so then each time this console.log will log render to the console. So let's see. Let's first get rid of these other ones that we had here. So here they are. And okay. Now never mind this one here that is a bit more grayed out. This is coming from somewhere else. So only this one render here is important. So this first render string here comes from the initial render of this tab content component. And if we go to another tab, then we get another one, because of course, then this component here is updated. Okay, now let's remove this so that we start empty. Or actually, we will see a few more. So each time that we click here, the component function gets rendered, and so then the console.log is executed. And so this is actually a really nice way of proving that rendering is calling the component function. All right. But now let's empty this. And then as I click this button here, we should only see one render here, which would then mean that these two state updates were batched. So let's see. And indeed, we only get one here. Great. Now let's also see that the state updating is asynchronous. So basically, if I try to access the number of likes here right after updating the state, then what happens? So first I need to, of course, increase a little bit. Then let's clean this. And as I reset, well, we get 5, which might be surprising, but if you paid good attention in the previous lecture, then this will actually no longer come as a surprise to you. So the reason that here we get 5 is that the state is in fact actually only updated after the re-rendering, or basically during the re-rendering, but not immediately after we call this function. So that's impossible, and therefore here we still get that old likes state, which again is still at 5. Then now it is of course at 0, because now the re-rendering has already happened. Now, by the way, what do you think will happen? So what do you think will get rendered if we click the undo button again? So let's clear this, and so let's see what happens. So I click this now, and you see that no render was logged to the console. So why do you think that is? Why was the component instance not re-rendered this time? Well, it's because both of the state values were already at their default, basically. So details was already true and likes was already 0. And so then, as we attempted to update the state, both of them were actually not updated. And again, that's because the new state was equal to the current state. And so in that situation, React will not even try to attempt to update the state. And then, of course, it will also not re-render the component instance. And so that's why, well, nothing happens. So as we keep clicking here, of course, the console.log keeps getting executed. But again, the component itself is not re-rendered. Okay, but let's move on here and let's implement this next button here. So here I have these 3 pluses, which means that when I click here, I actually want like a super like. So this should then improve by 3. So let's create a function for that. And I will just copy this one. And let's call it triple ink. And then I'll just duplicate this here. And then let's come down here on click. And then handle triple ink. Okay, let's go back to our function because this will become very important. So what do you think is going to happen when I click here now? Again, let's close. So what do you think will happen to this state here in particular? So let's see. And well, it only increased once. So not 3 times as we might expect. But were we actually really expecting that it would increase 3 times? I mean, with what we already know, we should know that this here could never work. So let's see why that is. So right here at the beginning of this function, likes was 0, right? And so then here, set likes would be 0 plus 1 equals 1, right? So this one is pretty clear. But then what in the next line? So what is the value of likes here in this line? Well, it is actually still 0. And so that's because the state update is once again asynchronous. So we do not get access to the new state value after this line of code right here. And so this is exactly what happens down here. So here, the state is now stale. So as we learned in the previous lecture as well. So we can very easily see that here again with this console.log. So if I click again, and actually I want the other one, so this one here, well, then you see that it became 2, which is exactly the value that we had before. And so here it was 2 plus 1 made this new 3. But here it was still 2, and here as well, and here as well. So how could we make this work if we really wanted to update the state 3 times like here? I mean, of course, we could just do this, but this is not the point here. So we are trying to learn how we could do this right here in another way. So actually, we have been doing that all along. So all the time, whenever we were updating state based on the current state, we would use a callback function instead of just a value. So we also talked about that in the previous lecture. And so now the time came where we really learn why we have been doing it with the callback function all the time. So let's remove this here or comment it out. And then let's do it the right way. So set likes, and now we pass in the callback function. And then, as you already know, the first argument here is the current value of the state, and then we just return the new one. And again, here likes could be called anything. Okay, let's do this 3 times. And then let's reload. And now, yeah, now it works. So this is the trick that changes the way the state is updated. So here in the callback function, we do actually get access to the latest updated state. So initially likes was 0, and then it returned 1. And so then in the next call here, this likes in this callback function will be 1. And so then we can update it to another one and to another one. Beautiful. And so this is the reason why I've been telling you that each time that we set state based on the previous state or based on the current state, we should always use a callback function like this here. Now, you might be wondering, like, why should we do that here? I mean, it works perfectly fine, right? And you're right about that. It works perfectly fine, but we never know what other developers might do with our functions, or even what we might do later ourselves. So let's say that at some point we want to change how this function works, and then without thinking about it, we just do this. And so then we go back to this not working as expected. So now we want to increase the likes by 2, but it will still only increase by 1, right? Or another situation, maybe, let's comment this one out. So maybe here we could think that we could just call this function here 3 times. Or maybe some other developer might think that. And so then they would get surprised when they see that this is actually not working. Right? And so, again, you should always use the callback function, because then you are always safe for whatever change your code goes through in the future. So with this, it will now work. But of course, we need to write the correct variable name. So yeah, now it does work. So even if you then use the function somewhere else, by doing this, you are safeguarded about, well, any changes that might occur in the future. All right. And now to finish, let's just prove that automatic batching now works in React 18, even outside of event handlers. So here we have this button that should undo, so it should reset our state 2 seconds later. Well, that's easy enough. Let's just create a function called handle undo later. And this function will simply set a timeout, and then after 2 seconds, it will call handle undo. So after 2000 milliseconds. And so what this will do is to schedule this handle undo function to be executed 2 seconds after this function here was called. And so then handle undo is no longer really an event handler function. It's just any function that simply gets called at a later time. So that's just what set timeout does. So let's then wire that up here with the onClick prop. So handle undo later. All right. Let's just then set our state. Let's clean up here. And then I just clicked and let's wait. And indeed, 2 seconds later, our state was updated. And indeed, our component was only rendered once, which is proved here by this single render string. Great. So again, this proves that in React 18, batching happens not only inside event handlers, but also inside a set timeout. And the same is true for promises and other situations. Now, just to really make sure, and you don't have to do this, but I like to play around with this stuff. So what I want to do now is to render this using React 17. So I will comment this one out and comment this one. Okay, and then here we need to also change here from here. And so now this is basically back to being a React 17 application. And that's exactly what it says here in this warning. So until you switch to the new API, your app will behave as if it's running React 17. But right now, that's actually exactly what we want. So now we get some error here, but yeah. So let's do some state updating here. Then I will clean and watch what happens when I click this button now. So let's wait. And now we got 2 re-renders. And so this does actually prove that before React 18, automatic batching was not happening inside a set timeout. So that's really curious. But of course, let's now put it back. All right. So this was just to show you that there really is a difference. So that React 18, well, really changed this. So again, now we should be back to only 1. Yeah, there we go. Okay, and this is actually all I had to show you here. So this was a bit longer than expected, but we did do a lot of stuff here. So after you do a quick recap of everything we just do here, or that we did here actually, then let's go to the next lecture. Let's now leave the topics of rendering and state and turn toward another essential part of React applications that we haven't really talked about yet, and that's events. So in this lecture, we will learn how React handles events and how they work behind the scenes. But let's start with a quick refresher on how event propagation and event delegation work in the DOM, because this is important to understand how React works, and also because I believe that many people don't have a good grasp on how events actually work in the browser. So let's consider this tree of DOM elements. And note that this really is a DOM tree, so not a fiber tree or a React element tree. And now let's say that some event happens, like a click on one of the three buttons. And so here is what's going to happen in the browser. As soon as the event fires, a new event object will be created, but it will not be created where the click actually happened. Instead, the object will be created at the root of the document, so at the very top of the tree. From there, the event will then travel down the entire tree during the so-called capturing phase, all the way until it reaches the target element. And the target element is simply the element on which the event was actually first triggered. So at the target, we can choose to handle the event by placing an event handler function on that element, which usually is exactly what we do. Then, immediately after the target element has been reached, the event object travels all the way back up the entire tree during the so-called bubbling phase. Now, there are two very important things to understand about this process. The first is that during the capturing and bubbling phase, the event really goes through every single child and parent element one by one. In fact, it's as if the event originated or happened in each of these DOM elements. The second important thing is that by default, event handlers listen to events not only on the target element, but also during the bubbling phase. So if we put these two things together, it means that every single event handler in a parent element will also be executed during the bubbling phase, as long as it's also listening for the same type of event. For example, if we added another click event handler to the header element, then during this whole process, both the handlers at the target and the header element would be executed when the click happens. Now, sometimes we actually don't want this behavior, and so in that case, we can prevent the event from bubbling up any further simply by calling the stop propagation method on the event object. And this works in vanilla JavaScript and also in React, but it's actually very rarely necessary, so only use this if there really is no other solution. Okay, so this is essentially how events work in the browser. Now, the fact that events bubble like this allows developers to implement a very common and very useful technique called event delegation. So, with event delegation, we can handle events for multiple elements in one central place, which is one of the parent elements. So, imagine that instead of 3 buttons, there would be like 1,000 buttons. Now, if we wanted to handle events on all of them, each button would have to have its own copy of the event handler function, which could become problematic for the app's performance and memory usage. So instead, by using event delegation, we can simply add just one handler function to the first parent element of these buttons. Then, when a click happens on one of the buttons, the event will bubble up to the options div in this example, where we can then use the event's target property in order to check whether the event originated from one of the buttons or not. And if it did, we can then handle the event in this central event handler function. Now, if you took my JavaScript course, then you will already know how to do this in practice, because, in fact, we do this all the time in vanilla JavaScript applications. However, in React apps, it's actually not so common for us to use this technique. But that might leave you wondering, if this is actually not important in React, then why are we even talking about this? Well, for two reasons. First, because sometimes you find some strange behaviors related to events in your applications, which might actually have to do with event bubbling. And so, as a good React developer, you always want to understand exactly what's going on in order to fix these problems. And the second reason is that this is actually what React does behind the scenes with our events. And so let's take a look at that. So let's consider this same DOM tree, and let's say again that we want to attach an event handler to one of the buttons or even to some other DOM element. And this is what that would look like in React code. So we would simply use the onClick prop to listen for click events and then pass it a function. So that's really easy, right? Now, if we think about how React actually registers these event handlers behind the scenes, we might believe that it would look something like this. So React might select the button and then add the event handler to that element. So that sounds pretty logical, right? However, this is actually not what React does internally. Instead, what React actually does is to register this and all other event handler functions to the root DOM container. And that root container is simply the DOM element in which the React app is displayed. So if we use the default of create React app, that's usually the div element with an ID set to root. So again, instead of selecting the button where we actually placed our event handler, we can imagine that React selects the root element and then adds all our event handlers to that element. And I say imagine because the way React does all this behind the scenes is actually a lot more complex than this, but that's not really worth diving into here. The only thing that's worth knowing is that React physically registers one event handler function per event type, and it does so at the root node of the fiber tree during the render phase. So if we have multiple onClick handlers in our code, React will actually somehow bundle them all together and just add one big onClick handler to the root node of the fiber tree. And so this is yet another important function of the fiber tree. But anyway, what this means is that behind the scenes, React actually performs event delegation for all events in our applications. So we can say that React delegates all events to the root DOM container because that's where they will actually get handled, not in the place where we thought we registered them. And so this works exactly how we just learned in the previous slide. So again, whenever a click happens on the button, a new event object is fired off, which will then travel down the DOM tree until it reaches the target element. From there, the event will bubble back up. Then, as soon as the event reaches the root container where React registered all our handlers, the event will actually finally get handled according to whatever handlers match the event and the target element. And finally, once that's all done, the event of course continues bubbling up until it disappears into nowhere. And the beauty of this is that it all happens automatically and invisibly just to make our React apps yet a little bit more performant. Now just one small detail that I want you to notice is that it's really the DOM tree that matters here, not the component tree. So just because one component is a child of another component, that doesn't mean that the same is true in the displayed DOM tree. So just keep that in mind when thinking about bubbling in React applications. Alright, so we talked a lot about events and event objects, and so now let's finish by taking a look at how these event objects actually work behind the scenes. So Whenever we declare an event handler like this one, React gives us access to the event object that was created, just like in vanilla JavaScript. However, in React, this event object is actually different. So in vanilla JavaScript, we simply get access to the native DOM event object. For example, pointer event, mouse event, keyboard event, and many others. React, on the other hand, will give us something called a synthetic event, which is basically a thin wrapper around the DOM's native event object. And by wrapper, we simply mean that synthetic events are pretty similar to native event objects, but they just add or change some functionalities on top of them. So these synthetic events have the same interface as native event objects, and that includes the important methods stop propagation and prevent default. What's special about synthetic events though, and one of the reasons why the React team decided to implement them, is the fact that they fix some browser inconsistencies, making it so that events work in the exact same way in all browsers. The React team also decided that all of the most important synthetic events actually bubble, including the focus, blur, and change events, which usually do not bubble. The only exception here is the scroll event, which does also not bubble in React. Okay, and now to finish, I want to quickly mention some differences between how event handlers work in React and vanilla JavaScript. The first one is that in React, the prop name to attach an event handler are named using camel case, so something like onClick with an uppercase C. In HTML, on the other hand, it would be onClick all lowercase, and if we used an add event listener in vanilla JavaScript, the event would simply be called click, so without the on prefix. Now, in vanilla JavaScript, whenever we want to stop the default behavior of the browser in response to an event, we can return false from the event handler function. And the big example of that is the browser automatically reloading the page when we submit a form. However, if we would attempt to return false in a React event handler, that would simply not work. So in React, the only way to prevent the browser's default behavior is to call prevent default on the synthetic event object. And finally, in the rare event that you need to handle an event in the capturing phase rather than in the bubbling phase, you can simply attach capture to the event handler name. For example, onClick capture instead of just onClick. But most likely you will never use this, so just keep this somewhere in the back of your mind. Alright, so what we just learned in this slide is basically everything that you need to know in practice in order to successfully work with events in React. The rest all happens invisibly behind the scenes, but I hope that you also found the rest of the lecture interesting and that it gave you even more confidence in working with events in your applications. Alright, and now to finish off this section, let's talk about something entirely different. So this lecture is not really about how React works behind the scenes, but more about what React actually is, which is a library. So for future React developers like you, it's important to understand what it means that React itself is a library and not a framework. And so let's now learn about the differences as well as the React ecosystem. And to understand the difference between a framework and a library, let's start with an analogy. So imagine that you want to make your own sushi for the first time, just like I did recently for the first time as well. So you have two choices about how you want to do it. The first option is to just buy one of those all-in-one sushi kits, which will come with all the ingredients that you need. And so then you don't have to buy anything separately. All you have to do is to assemble these ingredients into your sushi. However, there is also a downside to this, because now you're stuck with the ingredients that are included in the kit that you bought. So if you find out that you don't like one of these ingredients, then you still have to use it anyway. Now, instead of getting an all-in-one kit, you also have the option to buying all the ingredients separately. And so this will give you complete freedom to choose only the best ingredients and the ones that you like the most. On the other hand, all this freedom can give you decision fatigue, because now for each ingredient you need to research which brand is the best option, and then you also have to go buy each of the products separately. And even worse, if one of your selected brands changes or is no longer sold, then you need to start the whole process over. Okay, but probably at this point you're wondering, why is he going on and on about sushi? Well, the reason is that this analogy actually translates beautifully into the difference between building a web application using a framework or using a library. So we could actually just replace the images here and call it a day. So we could describe Angular, Vue, or Svelte, for example, as the all-in-one kit, and React as buying separate ingredients. And the pros and cons of building a web app with each of these approaches are basically exactly the same as in making sushi at home. Okay, but actually let's now replace these terms with their actual definitions and actually learn what's the difference between a framework and a library. So, in the world of JavaScript, a framework is basically a complete structure that includes everything that you need in order to build a complete, large-scale application. We can say that frameworks like Angular are batteries included, because they include stuff like routing, styling, HTTP requests, form management, and more, all out of the box. Now, the downside of this is that you're stuck with the framework's tools and conventions, even if you don't like or agree with them. However, that's actually not always bad, and so this is not a real downside for some developers. Now, on the other hand, we have JavaScript libraries, which are basically pieces of code that developers share for other developers to use. And the prime example here is, of course, React, which is what we call a Vue library. Vue, because all React does is to draw components onto a user interface, so onto a so-called view. Now, if you want to build a large-scale single-page application, you will need to include many external third-party libraries for things like routing, styling, HTTP requests, and so on. So all these functionalities are not part of React itself, unlike what happens with Angular and other frameworks. And so this is how this notion that React is a library ties into the analogy of buying separate ingredients to make sushi. Because to build a React app, we have to choose all these separate libraries. Now, don't get me wrong here. We can actually build React apps with just React itself, so without using any libraries. But that only makes sense for small apps or while we are still learning React. Now, being able to choose multiple libraries in order to build your application offers you incredible freedom, because you can choose exactly the ones that you like the most. And also, every app will have different requirements, and so each app will require a different combination of libraries. And so including all of them in a framework might not even be necessary. However, on the other hand, the implication of this is that as a React developer, you need to be able to find and download all the right libraries for your specific application. And of course, on top of that, you then need to learn how to use these libraries and even stay up to date with them over time. But don't worry, it's actually not as bad as it may sound. So if you follow this course until the end, you will have a very good understanding of the most important libraries that we usually include into most React projects, which leads me actually to the next point, which is React's huge third-party library ecosystem. So React's huge popularity has led to a really large ecosystem of libraries that we can include in our React projects for different needs like routing for single-page applications, making HTTP requests, managing remote server state, managing global application state, styling, managing forms, animations and transitions, and even entire UI component libraries. Now, I will not go over all of them here one by one, because that just takes too much time, and you can also just research them if you need. So instead, I will show you which ones I consider the most important libraries, and so these are the ones that we will use later in the course. So things like React Router, React Query, Redux, styled components, or Tailwind. Now, many React developers actually do feel overwhelmed by having to take so many decisions and choosing between so many third-party libraries. And so this fact, among some other reasons, has led to the development of multiple opinionated React frameworks, such as Next.js, Remix, or Gatsby. So Next.js or Remix are React frameworks because they are actually built on top of React. So they basically extend React's functionality. And they are opinionated because other developers basically included their own opinions into how to handle stuff like routing, state management, or styling into these frameworks. So where in a traditional React app we have to make decisions about what libraries to include, in an app built with a React framework, some of these important decisions have already been taken away from you, the developer. And so this makes project development much easier and much faster, and it can also lead to a better overall developer experience. Now, different frameworks specialize in different aspects, but all of them offload much of the setup work from you. Also, all of them offer many other advantages besides just being opinionated, such as server-side rendering or static site generation. In fact, we can even describe many of these frameworks as full-stack React frameworks, because they include so many features that we can actually build full-stack apps with them, all while using React as the base layer. But anyway, this is just a brief overview of React frameworks. We will learn a lot more about this in the last part of the course, where we will actually build a very large project using Next.js. Now, this will not be included in the course at launch time, but I will include it at a later point. But at this point, I just wanted to let you know that these frameworks exist, because of course, we can only learn about them once we really master React itself and also its most important third-party libraries. Welcome to the last lecture of the section. And it was a long and complicated section, I know, but hopefully you enjoyed learning about all these internal workings of React as much as I did. And now to finish, I thought it was a great idea to summarize the key learnings that you should retain from this section. Now, this is not a summary of everything that we learned, but only the practical takeaways and conclusions that you will actually need to know in practice, so as you build your own React apps. And this is necessary because I've mentioned multiple times that you actually don't need to know all this complicated stuff about how React works behind the scenes, but you do need to know the practical implications of it. And so in this lecture is where I gathered all those practical implications in the form of text slides that you can save and read in the future. But anyway, let's now move on to our first point, which is that a component is basically like a blueprint for a piece of UI that will eventually exist on the screen. When we then use a component, React creates a component instance, which is like an actual physical manifestation of a component which contains props, state, effects, and more. So, following the analogy of the blueprint, the component is like a blueprint for a house, and the component instances are like the actual houses that have been built from that blueprint. Finally, a component instance, when rendered, will return a React element. Okay, so let's now move on to rendering. So in React, rendering only means calling component functions and calculating what DOM elements need to be inserted, deleted, or updated later. So rendering has nothing to do with actually writing, with actually updating the DOM. Writing to the DOM is actually called committing in the React language. So what I want you to remember here is that each time a component instance is rendered and re-rendered, the function is simply called again. But what actually triggers a render to happen? Well, as you should probably know already, only the initial app render and state updates can cause a render, which will happen for the entire application. So even though it might look as if only one single component is rendered, the process is actually executed for all components. Now, when a component instance does get re-rendered, all its children will get re-rendered as well. Now, this doesn't mean that all children will get updated in the DOM, because thanks to reconciliation, React will check which elements have actually changed between the two renders. Now, one of the main parts of this reconciliation that I just mentioned is diffing. So, diffing is how React decides which DOM elements need to be added or modified later. Now, if between two renders a certain React element stays at the same position in the element tree, the corresponding DOM element and the component state will simply stay the same. So the DOM will not be modified in this case, which is a huge win for performance. However, if the element did change to a different position in the tree, or if it changed to a different element type altogether, then the DOM element and the corresponding state will be destroyed. So they will basically be reset. Now, one cool thing about the diffing algorithm is the fact that we can actually influence it by giving elements a key prop, which then allows React to distinguish between multiple component instances of the same component type. So when the key on a certain element stays the same across renders, the element is kept in the DOM even if it appears at a different position in the tree. And so this is the reason why we need to use keys in lists, because it will prevent unnecessary recreations of elements in the DOM. Now, on the other hand, when we change the key between renders, the DOM element will be destroyed and rebuilt. And so this is a very nice trick that we can use in order to reset state, which is sometimes necessary, as we saw in two practical examples in this section. Next, we have one very important rule that you must never ever forget, which is that you should never declare a new component inside another component. That's because doing so will recreate that nested component every time the parent component re-renders. So that nested component would always be a new variable, basically. And so this means that React would always see the nested component as a brand new component, and therefore reset its state each time that the parent state is updated. Now, the reason why this happens is not the important part, but what matters is that you should always declare, so you should write new components at the top level of a file, never inside another component. Now, the logic that is responsible for creating DOM elements, so basically logic that produces JSX, is called render logic. And this render logic is not allowed to produce any side effects. So render logic can have no API calls, no timers, no object or variable mutations, and no state updates. The only place where side effects are allowed is inside event handlers and inside useEffect. Okay, now after all this rendering, it's time to finally update the DOM, which happens in the commit phase. However, it's actually not React that does this committing, but a so-called renderer called React DOM. That's why we always need to include both these libraries in a React web application project. We can also use other renderers to use React on different platforms, for example, to build mobile or native applications with React Native. Alright, and now for the rest of this last slide, let's leave the topics related to rendering behind and quickly talk about state and events. So, when we have multiple state updates inside an event handler function, all these state updates will be batched. So basically, they will happen all at once. And this is super important because it means that multiple related state updates will only create one re-render, which once again is great for performance. And since React 18, automatic batching even happens inside timeouts, promises, and native event handlers. Now, one super important practical implication of this is that we cannot access a state variable immediately after we update it, which is why we say that state updates are asynchronous. Next up, when we use events inside event handler functions, we get access to a so-called synthetic event object, not the browser's native object. So the React team created synthetic events so that events work the exact same way across all browsers. And the main difference between synthetic and native events is that most synthetic events do actually bubble, and that includes the focus, blur, and change events, which do usually not bubble as native browser events. The only exception here is the scroll event. Okay, and now finally, let's remember that React is a library and not a framework. This means that you can basically assemble your applications using your favorite or the community's favorite third-party libraries. And this is great for flexibility and creative freedom. The downside of this freedom is that there is an basically infinite amount of libraries that you can choose from. And so you need to first find and then learn all these additional libraries that you need. However, that's not that big of a problem because you will learn about the most commonly used libraries in the main projects of this course. All right, and there you have it. So this is essentially what I need you to remember from this section going forward. And again, I hope that you found this section as interesting as I did. But no matter if you did or not, please leave your comments about it in the Q&A section. And now, maybe take some time to basically recover from all this new material and all these new concepts that you learned. And then, once you're done, I see you in the next section.